Hello everyone. Welcome to Sally and Bytes. This is your complete Python programming course, covering everything from getting started to strings, loops, lists, tuples, dictionaries, and modules. If you're a student, beginner, or just curious about Python, you're in the right place. This full-length video combines 20+ lessons into a single, easy-to-follow journey. Use the timestamps in the description or pinned comment to jump between topics. Grab your notebook, sit back, and let's master Python step by step together. Getting started with Python. In this video, we are going to discuss about Python programming language, installing Python, interacting with Python, Python IDLE, Python shell, command line interaction, Python editor window, working in script mode, exiting Python. Let's know about the uses of Python. It is being widely used for system programming, GUI programming, internet scripting, web, gaming, text processing, network programming, commercial robots, and in space and scientific applications. Python is used by Google search engine, YouTube, Netflix, Spotify, Dropbox, Instagram, etc. Here, we can see how to download and install Python. Python needs to be installed on our system. Python is available for all major operating systems, Windows, Linux, Unix, Mac, etc. Be careful to choose the version for your operating system and hardware. Python can be downloaded and installed for free from this link, https://www.python.org/download/windows. To download Python, we have to follow the steps given below. Step 1. Launch a web browser like Google Chrome, Internet Explorer, or Mozilla Firefox. Step 2. Type http://www.python.org/download at the address bar. The downloaded page for Python appears like this, as shown in the picture. Step 3. Click on the 3.8.3 version of the download link as shown in this figure. Step 4. Click the download link, download Python. Step 5. You will observe that the browser window prompts the download information. Step 6. After a few moments, the Python 3.8.3.exe application file gets downloaded in your download folder. Here, you can see how to install Python. Step 1. After the application file is downloaded, we can install it by opening it. This will open the Python 3.8.3, 32-bit, setup window as shown in the picture below. Step 2. Click on the checkbox to select Add Python 3.8.3 to path. Step 3. Now, click on Install Now option. Step 4. Python will begin to get installed on your system as shown in this figure. Step 5. When the installation is complete, you will see a screen displayed as seen in this figure. Step 6. Click Close to finish. Step 7. As you will see, the computer interface, IDLE, Python 3.8.3, 32-bit, gets installed, as shown in the figure, and is ready to use now. Step 8. When we first start Python IDLE by clicking on its icon created on the desktop or menu item on the Start menu, Apps by Name, IDLE, Python 3.8.3, 32-bit option, it always starts up in the shell. You can now write Python code in the newly installed Python shell, editor, or script window. To write or run Python programs interactively, we can either use the command line window or the IDLE. IDLE is a simple integrated development learning environment that comes with Python. The most important feature of IDLE is that it is a program that allows the user to edit, run, browse, and debug a Python program from a single interface. Python shell is an interactive window where we can type in the Python code and see the output in the same window. It is an interface between Python commands and the operating system. The interactive interpreter of Python is termed as Python shell. Python IDLE comprises Python shell, interactive mode, and Python editor, script mode. Now let's discuss about the Python shell. The Python shell is an interactive window where we can type in the Python code and see the output in the same window. It is an interface between Python commands and the operating system. So, the interactive interpreter of Python is termed as Python shell. On opening Python shell shows a welcome message displaying its version and a copyright notice. After this, the command prompt, seen as 3 sign, followed by a blinking cursor gets displayed which indicates that IDLE is now ready to take Python commands from the user. Look at the picture of the Python shell, interactive mode, which is part of Python's integrated development environment. The 3 signs are called the prompt or Python command prompt. The Python shell displays the command prompt to indicate that it is waiting for a user command to be entered. When commands are entered directly in IDLE from the keyboard, the interpreter or IDLE is said to be in interactive mode. In interactive mode, type the command, hello, world, in front of the prompt that is in front of the 3 greater than sign. Now, press enter and see what happens. And Python would immediately output, hello, world. Congratulations! This is our first program. As soon as we press the enter key after typing our first statement, it gets executed immediately and the output is displayed then and there. Alternatively, we can use print function. Print is a function which is used to display the specified content on the screen. The content, called argument, is specified within the parentheses. Print statement without any arguments will simply jump to the next line. For example, look at the picture. We type print, open parentheses, start double quotes, type hello world, then end the double quotes and close the parentheses. Press the enter key. The output will be displayed immediately in the same window as hello world. Same way, type welcome to Python programming using print function. Press the enter key. The output will be displayed as welcome to Python programming. In this case, we have given 2 print statements for displaying 2 different messages upon pressing the enter key. So, we can give commands at the primary prompt and see the immediate results. If you prefer not to download and install Python directly on your computer, there are a few alternative options available. Some popular online integrated development environments, IDEs, for working with Python are online Python IDEs like Replit, Python Anywhere, or Code Anywhere, and online GDB. Cloud-based Jupyter notebooks, virtual environments like Anaconda or Miniconda, Docker containers, and PyCharm Edu. Here, I am working with Online GDB, a web-based integrated development environment, IDE. You can see the working area, where the program is worked, and the console area, where the output is displayed. Python is a case-sensitive language. This means that Python differentiates between capital and small alphabets. For example, print, P capital, and print, P small, are 2 different things for Python. Whereas print, small p, is a valid command in Python, print, capital P, is just a word and not a command. This can be observed by typing the command print, hello world, in capital P. Python will not be able to interpret it and will show an error, that is name error as shown in this picture. We must remember that while using the print command, the message or the argument to be displayed should be placed within quotation marks, single quotes or double quotes. The argument is there displayed as it is. If the argument is not placed within quotation marks, then the interpreter tries to evaluate the argument and displays the result. This feature is used to perform calculations. If we give an arithmetic expression as an argument, the interpreter shows its value, which is shown in this picture. Using IDLE as a calculator just like text or string messages we have given so far, we can also perform mathematical calculations using the Python command prompt. Now, look at the input statements in this picture. We have performed mathematical calculations using print statement and the output are displayed on the console area. Print function will convert the argument or message into string before writing to the screen. You can pause the video and check the output of the 5 mathematical calculations, one by one. Let's see the syntax or rules of the print function. Consecutive arguments are separated by commas in print function. When print function is executed, the values of consecutive arguments are separated by a space between them. So we can say space is the default output. We can also specify some other string as the separator using the sep argument of print function. Now look at the syntax. Here, sep describes string inserted between values or default value or a space. End describes string appended after the last value or default value or a new line. File is optional. By default, file attribute is used to print objects on the standard output device, that is sys.stdout, that is screen. The sep argument allows you to specify a string that will be used as the separator between the values being printed. For example, if you pass sep equals hyphen, the values will be separated by hyphens instead of spaces. Now, we can look at the examples. First program. Print 10, 20, 30. Now look at the output in the console area. Here space is the default separator. Second one. Print 10, 20, 30, sep equals asterisk. So the output displays as asterisk, as the separator. Third one. Print 10, 20, 30, sep equals hyphen, asterisk. So the output displays as hyphen and asterisk, as the separator. Fourth one. Print 10, 20, 30, sep equals comma. So the output displays as comma, as the separator. Fifth one. Print 10, 20, 30, sep equals new line character, \n. So, the output displays the values in the new line. Sixth one. Print 10, 20, 30, sep equals tab. So, the output displays the values in one tab space, which means moving 4 spaces towards right. When using the sep argument, it must be specified after all the values to be printed. This is because the Python interpreter expects the values to be printed to come first, followed by any keyword arguments such as sep. If you specify sep before the values, it will result in a syntax error because the interpreter doesn't expect a keyword argument at that position. Look at the first example. We have specified the sep argument before the values. Therefore, the interpreter will show a syntax error because it expects the values to be printed first and then the separator. Look at the second example. We have specified the sep argument after all the values to be printed. Therefore, the output is printed correctly. Let's learn about the end parameter. Python's print function comes with a parameter or argument called end. By default, the value of this parameter is \n, that is, the new line character. We can end a print statement with any character or string using this parameter. The print function uses sep to separate the arguments and end after the last argument. For example, type the following statement using end parameter with the print function. Print pen, pencil, ruler, sep equals comma, end equals 3 exclamation marks, new line character \, and press the enter key. Python shell will execute it and display the output shown in the figure. The values pen, pencil, and ruler are printed. The sep argument specifies that the values should be separated by a comma and a space. The end argument specifies that the output should end with 3 exclamation marks, followed by a new line character, which causes the next print statement to start on a new line. The Python shell window comprises drop-down menus. The menu items are File menu. File menu provides different options such as open a new file, open an existing file, open module, reset files, save, save as, print, close and exit. The edit menu allows us to edit the text we type in the shell by applying various editing options such as undo, redo, cut, copy, select all, paste, find and replace. The shell and debug menus are useful when creating larger programs. The shell menu allows us to restart the shell or search the shell's log to trace the most recent reset. The debug menu provides useful menu items for debugging the Python program in order to trace errors while checking for line-by-line execution of the entered Python statements. The options menu allows the user to configure IDLE according to the suitability and working requirements. For example, changing font style of the Python shell window, highlighting code, color, shortcut keys, etc. The help option provides Python help and documentation. Already we learned that Python IDLE comprises Python shell, interactive mode, and Python editor, script mode. Until now, we worked some Python programs in Python shell, that is the interactive mode. Now, we are going to learn about the Python editor, script mode. Working with Python script mode involves the following steps. Step 1. Creating script or program file. From the File menu, click on the New File option. A new window opens, that is Python script mode or Python editor window, as shown in the first picture. Python script mode is simple and standard text editor where you can type or edit your code. At the time of its opening, this file window is named untitled by default, as shown in picture. The name can be changed by the user by renaming the file. Our next step is to save this file by clicking on File menu, Save or Save as option, followed by typing a proper name for it instead of the default name untitled. Now, we can see how saving file with extension .py can be done. Enter the name with which you have to save the file along with the extension .py. Even if we forget to give the extension .py or .pyw while saving the file for the first time, the Python compiler automatically gives the extension along with the file name. While working in the script mode, when we enter the statements to be executed and press enter key, we won't automatically see the results the way we would see in the interactive mode. To see output from a script mode, we have to run this script or invoke the print function. It must be remembered that even if we enter the print statements in the script mode, the output shall be displayed only in Python shell. Also, all commands are given together in the form of a module or program or script, and all output lines are displayed together, which offers better understanding and clarification of the output obtained and, hence, no more cluttering between command and output takes place. To execute a Python script file, we have to choose the Run module option from the Run menu or press the function key F5. Look at the second picture. Output of the program is displayed in the Python shell. In order to exit the Python command prompt, press Ctrl+Q, shortcut key, or type quit or exit, built-in function, and press the enter key. If exit or quit does not work, then alternatively you can type the following commands: import sys::sys.exit. You can see the difference between script mode and interactive mode in Python. First point. In script mode, you write your Python code in a file with a .py extension and then run it using the command line or an IDE. But, in interactive mode, you can write and run Python code one line at a time. You can type Python code and see the results immediately. Second point. In script mode, the code is executed from top to bottom and the results are displayed in the console. In interactive mode, you can enter interactive mode by starting the Python interpreter from the command line or by using an IDE with a Python console. Third point. In script mode, you can use script mode to write and save complex programs for later use. But in interactive mode, it is useful for testing small pieces of code or for exploring the language. Python Programming Fundamentals. Part 1. In this video, we are going to discuss about Python syntax and character set, tokens, concept of an object, variables and data types, identity of the variable or object, type of the variable or object, values of the variable or object and practical implementation. So, let's dive in and get started. Now, let's learn about the Python syntax. What is a Python syntax? Python syntax refers to a set of rules that defines how users and the system should write and interpret a Python program. So, before that you should understand about the variables and data types. In Python programming language, data types are inbuilt. Whatever values we assign to the variables, the data types of the variable will be the same as the data type of the value. Hence, it is said that Python supports dynamic typing. Now, let's discuss about the basic elements of Python. Python character set. Character set is a set of valid characters recognized by Python. A character represents any letter, digit, or any other symbol. The Python language uses the ASCII character set, which is a subset of the Unicode character set. Letters. Uppercase A to Z, lowercase a to Z, digits, 0 to 9. Special symbols. Addition, subtraction, division, multiplication, backslash, exponentiation, parentheses, integer division, and so on. White spaces include blank space, tabs, carriage return, new line, form feed. Other characters, all other 256 ASCII and Unicode characters. The next basic element of Python is tokens. A token is the smallest individual unit of a program that has meaning. Python programs are made up of various types of tokens, which includes identifiers, keywords, literals, operators, and delimiters. Let's learn one by one. Let's learn about the first token, identifier. Identifiers are the names given to any variables, constant, functions, or modules, classes in a program. Some of the rules for defining identifiers are given here. First character of an identifier should start with a character or an underscore but not with a digit. No special characters are allowed except underscore. Reserved words, keywords, cannot be used as an identifier name, for example, reserved words like print function. Space is not allowed. Upper and lower case are treated differently. Examples of valid identifiers are ABC, X24Y, California _123, swap, name, etc. Examples of invalid identifiers are 12-digit, here. First character of an identifier should start with a character, but it starts with 1, it's a digit. So, it is invalid identifier. Roll number, here space should not be allowed, so, it is invalid identifier, name $, no special characters are allowed. It's invalid. Pin code, here no space allowed. So it's invalid. The next token in Python is the keyword. Keyword is the reserved words of Python that have a special fixed meaning for the interpreter. No keyword can be used as an identifier, as keywords have specific meaning for the interpreter. For example, if, else, while, for, def and class. The next token in Python is the literals. A fixed numeric or non-numeric values that are directly used in a program is called a literal. Such as numbers, strings, Boolean values, or other data that represents values to be stored in variables. They are also known as constants. Here is the list of types of literals and examples. String literals, A equals XYZ, B equals Mississippi, etc. Numeric literals, A equals 5, P equals 2,500, etc. Floating literals, salary equals 30,000.00, area equals 2.5, etc. Boolean literals, value equals true, value 2 equals false, etc. Collection literals, list 1 equals 1, 2, 3, 4, 5, tuple 1 equals 10, 20, 30, 40, 50, etc. The next token in Python is the operators. A symbol or a word used to perform operations on data and returns the result. Example, arithmetic operators, addition, subtraction, multiplication, division, comparison operators, equal to, not equal to, less than, greater than, and logical operators, and, or, not. The next token in Python is the delimiters. The symbols used as separators of values or to enclose some values. For example, parentheses, braces, lists, commas, semicolon, and colon. Python uses whitespace to separate tokens, which means that spaces, tabs, and line breaks are all used to delimit tokens in a program. This makes Python code easy to read and write, and also helps to ensure that the code is structured correctly. Here you can see an example for identifying the tokens in Python script. Observe the following script and enlist all the tokens used in it. For each token, write its category to x equals 68, y equals 12, z equals x/y, print x, y, z r, x, y, z. Here, x, y and z are identifier or variable. Print is a keyword. Equal to and slash are delimiters or operators. 68, 12, x, y, z are our literals. Python treats every value or data item, numeric, string or other type, as an object, which means it can be assigned to some variable or can be passed to a function as an argument. In Python, every object has a unique identity, ID, which remains the same for the lifetime of that object. ID is related to the memory address of the object. The function ID returns the identity of an object. For example, x equals 40. ID of x is 1637301104, which is the memory address. Now, y equals 60 minus 20. ID of y is 1637301104, which is the memory address. The memory address of identity of y is same as that of x since both hold the same value, 40. Sometimes we need computers to remember the information we give it and that it calculates during programs. A variable can be thought of as a box that the computer can use to store a value. The value held in that box can change or vary. In Python, variables are used to store values, such as numbers, strings, or other data types. Through a variable we store the value in the memory of a computer. Variable is a named unit of storage. A program manipulates its value. Every variable has a type and this type defines the format and behavior of the variable. Let's see about variables, working with numbers. A variable is a name that refers to a value. You can assign a value to a variable using the equal sign operator. Here's an example: x equals 5. In this example, x is the variable name, and 5 is the value that is being assigned to it. Whenever a variable name occurs in an expression, the interpreter replaces it with the value of that particular variable. A variable is an identifier or placeholder that holds a value. In other words, a variable is a reference to a computer memory location where the value is stored. In Python, every element is termed as an object. Hence, a variable is also an object in Python. Some more examples of variables using numbers in Python. Look at example 1. In interactive mode, here, variable x holds the value 3, variable y holds the value 4, variable z holds the value x plus y, so z equals 7. Now z equals z plus 1. So z equals 8. Now variable x hold the value of y, that is 4. So x equals 4 and y equals 5. Hence, the output will be displayed as x equals 4, y equals 5 and z equals 8 in the same window immediately. But look at example 2. In script mode, here, variable x holds the value 3, variable y holds the value 4, variable z holds the value x plus y, so z equals 7. Now z equals z plus 1. So z equals 8. Now variable x hold the value of y, that is 4. So x equals 4 and y equals 5. Here print function is used to print the values of variables in x, y, and z. Then, for the output to get displayed, we have to save the code with a suitable file name with the extension .py and then run it, run module or press F5. Already, we have learned about how to use interactive mode and script mode in the previous video, Getting Started with Python. You can check it for reference. A Python program can use as many variables as it needs it to. All variables or objects are made up of 3 main components: identity of the variable or object, type of the variable or object, and value of the variable or object. The first main component of a variable is the identity. Identity of a variable refers to the variable's address in the memory, which does not change once it has been created. The address of an object can be checked using the method id of variable or object, which is the syntax or rule. For example, variable x holds the value 10. When we print the identity, that is id of x, the output displays 140652663 for 145296, which is the address of memory location storing value 10. The second main component of a variable is the type, that is data type. In Python, data type refers to the type of value that a variable or an expression represents. A data type in Python can be categorized as numbers, sequences, mappings, and none. Numbers are categorized as integer, Boolean, floating point, and complex numbers. Sequences are categorized as strings, lists, and tuple. Mappings are categorized as dictionary. Let's see the data types in a detailed manner. Number data type stores numerical values. Types of built-in numeric data types are integer, Boolean, floating point, and complex. Now let's see about integer. Integer is termed as int. Integer represents whole numbers without any fractional part. They can be positive or negative and have unlimited size in Python. An integer in Python can be of any length. Let's look at the examples. In example 1, a variable named x is created and assigned the value 6. This means that the value 6 is stored in the variable x. The print function is used to display the value of the variable x on the console. In this case, it will print the value 6 as output. In example 2, a variable named x is created and assigned the value -8. This means that the negative integer -8 is stored in the variable x. The print function is used to display the value of the variable x on the console. In this case, it will print the value -8 as output. In example 3, a variable named z is created and assigned the value 0. This means that the integer 0 is stored in the variable z. The print function is used to display the value of the variable z on the console. In this case, it will print the value 0 as output. In example 4, a variable named b is created and assigned the value 788899096. This means that the integer 788899096 is stored in the variable b. The print function is used to display the value of the variable b on the console. In this case, it will print the value 788899096 as output. In example 5, a variable named y is created and assigned the value -345678890. This means that the negative integer -345678890 is stored in the variable y. The print function is used to display the value of the variable y on the console. In this case, it will print the value -345678890 as output. Here, you have to note that while writing a large integer value, do not use commas to separate digits. Also, integers should not have leading zeros. Range of an integer in Python can be from -214,748,3648 to 214,748,3647, and long integer has unlimited range, subject to available memory. Next number data type includes Boolean data type. Boolean data type is a subtype of integer. It represents one of the two possible values, true or false. Any expression which can be true or false has the data type bool. A Boolean true value is non-zero, non-null, and non-empty. Let's look at the examples. In example 1, a variable named bool_1 is created and assigned the result of the Boolean expression, 62 greater than 100. The expression compares the values 62 and 100, checking if 62 is greater than 100. Since this is not true, the expression evaluates to false, and that value is assigned to the variable bool_1. The print function is used to display the value of the variable bool_1 on the console. In this case, it will print the value false as output. In example 2, a variable named bool_2 is created and assigned the result of the Boolean expression, 124 less than or equal to 224. The expression compares the values 124 and 224, checking if 124 is less than or equal to 224. Since this is true, the expression evaluates to true, and that value is assigned to the variable bool_2. The print function is used to display the value of the variable bool_2 on the console. In this case, it will print the value true as output. Next number data type includes floating point. Floating point numbers denote real numbers or floating point values, that is, numbers with fractional part. Floating point numbers are written in decimal point that separates the integer from the fractional numbers. The fractional part of a floating point number can also be 0. Let's look at the examples. In example 1, a variable named x is created and assigned the value 3.14. This means that the floating point number 3.14 is stored in the variable x. The print function is used to display the value of the variable x on the console. In this case, it will print the value 3.14 as output. In example 2, a variable named a is created and assigned the value 7268.4. This means that the floating point number 7268.4 is stored in the variable a. The print function is used to display the value of the variable a on the console. In this case, it will print the value 7268.4 as output. In example 3, a variable named y is created and assigned the value 0.0. This means that the floating point number 0.0 is stored in the variable y. The print function is used to display the value of the variable y on the console. In this case, it will print the value 0.0 as output. Next number data type includes complex numbers. Complex numbers in Python are made up of pairs of real and imaginary numbers. They take the form x plus y uppercase j or x plus y lowercase j, where x is a float and the real part of the complex number. On the other side is yj, where y is a float and j, or its lowercase indicates the square root of an imaginary number minus 1. This makes y the imaginary part of the complex number. Let's look at the examples. In example 1, a variable named x is created and assigned the complex number 2 plus 5j. The syntax a plus bj represents a complex number, where a is the real part and b is the imaginary part. The print function is used to display the real and imaginary parts of the complex number x on the console. X.real returns the real part of x, and x.imag returns the imaginary part of x. The output of the code will be the real part of is 2.0 and the imaginary part is 5.0. In example 2, a variable named y is created and assigned the complex number for minus 2j. The syntax a plus bj represents a complex number, whereas the real part and b is the imaginary part. The print function is used to display the real and imaginary parts of the complex number y on the console. Y.real returns the real part of y, and y.imag returns the imaginary part of y. The output of the code will be the real part is 4.0 and the imaginary part is minus 2.0. In example 3, a variable named z is created and assigned the result of adding the complex numbers x and y. Both x and y are complex numbers defined earlier in example 1 and example 2. The print function is used to display the value of the variable z on the console. In this case, it will print the result of the addition of complex numbers x and y, which is 6 plus 3j, as output. Complex numbers are not extensively used in Python programming. Next data type is sequences. A sequence is a group of items with a well-defined ordering where each item is indexed by an integer. String is categorized under sequence data type. A string is a sequence of characters that can be a combination of letters, numbers, and special symbols enclosed within quotation marks, single, or double, or triple. These quotes are not part of the string. They only define the starting and ending of the string. A string may have any character, sign, or even space in between them. Now look at the examples. In the first example, a variable named str1 is created and assigned the value hello world. The value is enclosed in double quotation marks, indicating that it is a string literal. The print function is used to display the value of the variable str1 on the console. In this case, it will print the string hello world as output. In the second example, a variable named str2 is created and assigned the value 12,345. The value is enclosed in double quotation marks, indicating that it is a string literal. The print function is used to display the value of the variable str2 on the console. In this case, it will print the string 12345 as output. It's important to note that the value of str2 is a string, even though it consists entirely of numeric characters. In Python, strings are a sequence of characters and can contain alphanumeric and special characters. In the third example, a variable named str3 is created and assigned the value Python 3.9.2. The value is enclosed in single quotation marks, indicating that it is a string literal. The print function is used to display the value of the variable str3 on the console. In this case, it will print the string Python 3.9.2 as output. Here, we can learn about the escape sequence. Python allows us to represent a string containing non-graphic characters as well. Non-graphic characters are those characters which cannot be directly typed from the keyboard, such as backspace, tab spaces, carriage return, etc. These non-graphic sequence is represented by a backslash followed by one or more characters. An escape sequence character is represented as a string with 1 byte of memory and backslash is ignored by the interpreter. Now you can pause the video and read the contents in the tabular form. Next sequence data type is lists. List is a sequence of items separated by commas and the items are enclosed in square brackets. Let's look at the example. The provided Python code demonstrates the creation and printing of a list. Let's analyze each line. In this example, a variable named list1 is created and assigned a list containing multiple values. The list consists of integers, 20, 33, a floating point number, 6.5, and strings, New York, D34. The print function is used to display the value of the variable list1 on the console. In this case, it will print the entire list, 20, 6.5, New York, D34, 33, as output. Next sequence data type is tuple. Tuple is a sequence of items separated by commas and items are enclosed in parentheses. Note that once created, we cannot change the tuple. Let's look at the example. The provided Python code demonstrates the creation and printing of a tuple. In this example, a variable named tup1 is created and assigned a tuple containing multiple values. The tuple consists of integers, 180, strings, sam, p, and a floating point number, 4.5. The print function is used to display the value of the variable tup1 on the console. In this case, it will print the entire tuple, 180, sam, 4.5, p, as output. Next data type is mapping. A mapping object maps immutable values to arbitrary objects. This data type is ordered and mutable. There is currently only one standard mapping type, the dictionary. A dictionary holds data items in key-value pairs and is accessed using keys, which are immutable data type and their values of any data type. Items in a dictionary is enclosed in curly brackets. Dictionaries permit faster access to data. Every key is separated from its value using a colon sign. In order to access any value in the dictionary, we have to specify its key in square brackets. Now look at the example. The provided Python code demonstrates the creation and printing of a dictionary. In this example, a variable named dict is created and assigned a dictionary containing key-value pairs. The keys are strings, name, age, class, and the corresponding values are nishant, 16, and 11. The print function is used to display the value of the variable dict on the console. In this case, it will print the entire dictionary, name, nishant, age, 16, class, 11, as output. Next data type is none data type. None is a built-in constant in Python that represents the absence of a value or the null value. This is a special data type with a single value. It is used to signify the absence of value or condition evaluating to false in a situation. It is represented by none. Python doesn't display anything when we give a command to display the value of a variable containing value as none. None will be displayed by printing the value of the variable containing none using print statement. Now, look at this example. A variable named value1 is created and assigned the value 30. This means that the integer 30 is stored in the variable value1. Next, a variable named value2 is created and assigned the special value none. None is a built-in constant in Python that represents the absence of a value or the null value. The print function is used to display the values of the variables value1 and value2 on the console. The output of the code will be 30 and none. This means that the value 30 will be displayed on the first line of the console when the code is executed, and none will be displayed on the second line. Until now, we have completed the identity of a variable and data types of a variable. Next, we will learn about the values of a variable or object. In Python, you can create variables and assign values to them using the assignment operator =. Look at the example 1. In this example, a variable named mathematics and assigns it the value 98. Print function outputs the value of the variable mathematics as 98. Here you have to note that in an assignment statement, the variable must be on the left side of the assignment =sign operator, otherwise it will generate error. Look at the example 2, 98 equals mathematics. We have reversed the order and attempted to assign a value to the literal 98, which is not permissible. The error message we encountered is, syntax error, cannot assign to literal, occurs because we are trying to assign a value to a literal, which is not allowed in Python. Let's learn about the concept of the L value and R value. The L value represents an object that occupies some identifiable address in memory. The variable which is at the left-hand side of an assignment operator is called the left value or the L value. The variable which is at the right-hand side of an assignment operator is called the right value or the R value. The statement, L value equals R value, is called the assignment statement. When the interpreter encounters an assignment statement, it evaluates the right-hand side expression, R value, and assigns to the left-hand side variable, L value. In example 1, according to the operator precedence, the multiplication, asterisk, is performed before the addition, plus. So, the expression 2 times 2 is evaluated first, resulting in 4. Then, the addition is performed, 8 plus 4, which gives the final result of 12. And assign this value 12 to the variable value 1. Its value will be 12 until it is changed by another assignment statement. In example 2, with two variables x and y, and we type the following assignment statements. X equals 3. Here, variable x is assigned 3 as a value. Next is, y equals 3. Here, variable y is also assigned value 3, so now y shall be pointing to x only. Next, y equals 2. Here, variable y is assigned another value 2. Now the final value of y becomes 2 and that of x remains 3 as assignment operator erases the previous value and assigns new value to the variable y. Thus, it becomes evident that we can use assignment operator for assigning values to a variable along with their reassignment. In Python, we can declare multiple variables in a single statement. It is used to enhance the readability of the program. It can be done in two ways: assigning multiple values to multiple variables and assigning same value to multiple variables. First, we will discuss about the assigning multiple values to multiple variables. var1, var2, var3, varn equals value1, value2, value3, valuein. This statement will declare variables var1, var2, varn with values as value1, value2, valuein respectively. Let's look at the example 1. The variable message is assigned the value meeting, the variable day is assigned the value mon, and the variable time is assigned the value 9. After executing this code, message holds the value meeting, day holds the value mon, time holds the value 9. Please note that the value assigned to time is a string 9, not the numerical value 9. In example 2, the variable x is assigned the value 2, and the variable y is assigned the value 3. After executing this code, x holds the value 2 and y holds the value 3. Second way is to assign same value to multiple variables. var1 equals var2 equals var3 equals varn equals value 1. This statement will declare variables var1, var2 up to varn, all with value as value 1. In example 1, the code totalMarks equals count equals 0 assigns the value 0 to both the variables totalMarks and count simultaneously. In example 2, the variable x is assigned the value 3, y is assigned the value 60, z is assigned the value 54.5, and p is assigned the string value %. After executing this code, x holds the value 3, y holds the value 60, z holds the value 54.5, p holds the string value %. In example 3, the code a equals b equals c equals -5 assigns the value -5 to all three variables a, b, and c in a single line. After executing this code, the variables a, b, and c will have the value -5. In example 4, since a, b, and c have all been assigned the value -5, the expression a plus b plus c will yield -5 plus, -5, plus, -5, which simplifies to -15. Next, we can learn about variable name. Rules are as follows. A variable name must start with an alphabet, capital or small, or an underscore character. A variable name cannot contain spaces. A variable name can contain any number of letters, digits, and underscore. No other characters apart from these are allowed. A Python keyword cannot be used as a variable name. Variable names are case-sensitive, that is, lowercase name and uppercase name are two different variables. You should always choose names for your variables that give an indication of what they are used for. In other words, the name should reflect its functionality. Valid variable names: unit underscore per underscore day, day of week, stud underscore name, father underscore name, total marks, age, amount, A24, invoice underscore now. Invalid variable names. 3D graph, name cannot start with a digit. Role hashtag no. Special symbol, hashtag, is not allowed. First name. Spaces are not allowed in between. D.O.B, dots are not allowed. While. Keyword not allowed. Example 1, write a Python script to input two numbers and find their sum and product. Now, look at the code for line-by-line explanation. The code starts by prompting the user to enter the first number using the input function and displaying the message, enter first number. The user's input is stored in the variable n1. The eval function is then used to evaluate the value of n1. This eval function takes a string as input and interprets it as a Python expression, returning the result. In this case, it converts the user's input, which is initially a string, into a numerical value and assigns it back to the n1 variable. This step ensures that the input is treated as a number rather than a string. Next, the code prompts the user to enter the second number using the input function and displays the message, enter second number. The user's input is stored in the variable n2. Similarly to the previous step, the eval function is used to evaluate the value of n2, converting it from a string to a numerical value and assigning it back to the n2 variable. The code then calculates the sum of n1 and n2 by adding them together and assigns the result to the variable sum. It uses the print function to display the calculated sum to the user, along with the message, sum of the numbers equals. Similarly, the code calculates the product of n1 and n2 by multiplying them together and assigns the result to the variable prod. It uses the print function again to display the calculated product to the user, along with the message, product of the numbers equals. So now look at the output below, enter the first number 50, enter the second number 60. Sum of the numbers 110. Product of the numbers 3000. Example 2, a student has to travel a distance of 450 kilometers by car at a certain average speed. Write a Python script to find the total time taken to cover the distance. Now, look at the code. The code sets the value of the variable distance to 450, representing a distance in some unit kilometers. The code prompts the user to enter the average speed using the input function and displays the message enter average speed. The user's input is converted to a numerical value using the eval function and stored in the variable speed. The code calculates the time taken to travel the given distance by dividing the distance by the speed and assigns the result to the variable time. The code uses the print function to display the value of distance along with the message, distance is. Similarly, it uses the print function to display the calculated value of time along with the message, time taken, and adds the string, hr to indicate that the unit of time is hours. So now look at the output below. Enter average speed 60. Distance is 450. Time taken 7.5 hours. Example 3. Write a Python code to calculate simple interest by inputting the value of principal amount and rate from the user for a time period of 5 years. Now look at the code. The code prompts the user to enter the value of the principal using the input function and displays the message, enter the value of principal. The user's input is converted to a numerical value using the eval function and stored in the variable principal. Similarly, the code prompts the user to enter the annual rate of interest and stores the input in the variable rate after converting it to a numerical value. The variable time is set to a value of 5, representing the time period in years. The code calculates the simple interest by multiplying the principal, rate, and time, and then dividing the result by 100. The calculated simple interest is assigned to the variable simple_int. The code calculates the total amount payable by adding the principal and the simple_int together. The calculated amount payable is assigned to the variable amount. The code uses the print function to display the calculated simple interest along with the message, simple interest equals Rs. Similarly, it uses the print function to display the calculated amount payable along with the message, amount payable equals Rs. Now look at the output. Enter the value of the principal 25,000, enter the annual rate of interest 6.5, simple interest equals 8,125 rupees, amount payable equals 33,125 rupees. Example 4. Write a Python code to convert the time inputted in minutes into hours and remaining minutes. The code prompts the user to enter the time in minutes using the input function and displays the message enter the time in minutes. The user's input is converted to an integer using the int function and stored in the variable time. The code calculates the number of hours by performing integer division on time by 60. This operation discards the remainder and gives the whole number of hours. The calculated number of hours is assigned to the variable hours. The code calculates the remaining minutes by using the modulo operator on time with 60. This operation gives the remainder after dividing time by 60. The calculated remaining minutes are assigned to the variable mints. The code uses the print function to display the calculated number of hours along with the message, hours are. Similarly, it uses the print function to display the calculated remaining minutes along with the message, minutes are. Now look at the output. Enter the time taken in minutes 1630. Hours are 27 and minutes are 10. Python Programming Fundamentals Part 2. In this video, we are going to discuss about the usage of Python data types, mutable and immutable data types, keywords in Python, expressions and operators. So let's dive in and get started. Python has several built-in data types that can be used to store different kinds of information. Here are some of the most common data types. First data type is integer called int is used to represent whole numbers, positive or negative. Next data type is float is used to represent decimal numbers, with a floating point precision. Next data type is boolean also called bool is used to represent true or false values. Next data type is string called str, is used to represent text or a sequence of characters. Next data type is list, used to represent a collection of items, ordered and changeable, meaning it can be modified. Example, if we store the names of students of a class in a list, then it is easy to update the list when some new students join or some leave the course. Next data type is tuple, used to represent a collection of items, ordered and unchangeable, meaning when we do not need any change in the data. Example, names of days in a week. Next data type is set, used to represent a collection of unique items, unordered and unindexed. Next data type is dictionary, used to represent a collection of key-value pairs, unordered and changeable. Dictionaries can be preferred if our data is being constantly modified or we need a fast lookup based on a custom key or we need a logical association between the key-value pair. Example, a mobile phone book is a good application of dictionary. Now, we discuss about the type function. The type function in Python can be used to determine the data type of a particular variable or value. In example 1, x equals 5, assigns the value 5 to the variable x. Next line uses the print function to output the result of the type function applied to the variable x. The type function returns the data type of the object it is called with. So, the output of the print statement is class int. This output indicates that the type of the object stored in the variable x is an integer. In Python, an integer is a whole number without any decimal places. In example 2, y equals 3.14 assigns the value 3.14 to the variable y. Next line uses the print function to output the result of the type function applied to the variable y. The type function returns the data type of the object it is called with. The output of the print statement is class float. This output indicates that the type of the object stored in the variable y is a floating point number. In Python, a floating point number is a numeric type that represents numbers with fractional parts. It is indicated by a decimal point. In example 3, z equals hello assigns the string hello to the variable z. In Python, strings are enclosed in either single quotes or double quotes. Next line uses the print function to output the result of the type function applied to the variable z. The type function returns the data type of the object it is called with. The output of the print statement is class str. This output indicates that the type of the object stored in the variable z is a string. In Python, a string is a sequence of characters enclosed in quotes. In example 4, a equals true assigns the Boolean value true to the variable a. In Python, Boolean values can either be true or false. They represent the two possible states of truth. Next line uses the print function to output the result of the type function applied to the variable a. The type function returns the data type of the object it is called with. The output of the first print statement is class bool. This output indicates that the type of the object stored in the variable a is a Boolean. In Python, Boolean is a built-in data type used to represent logical values. Next statement is b equals false. This line assigns the Boolean value false to the variable b. Next line uses the print function to output the result of the type function applied to the variable b. The output of the second print statement is class bool, indicating that the type of the object stored in the variable b is also a Boolean. Next statement c equals 10 greater than 5, line assigns the result of the expression 10 greater than 5 to the variable c. The expression 10 greater than 5 evaluates to true since 10 is greater than 5. Next line uses the print function to output the result of the type function applied to the variable c. The output of the third print statement is class bool, indicating that the type of the object stored in the variable c is a Boolean. You should note the point that the Boolean argument should have t, capital letter, for true and f, capital letter, for false. Otherwise it will generate an error. In example 5, d equals 3.2 plus 1.5j, assigns the complex number 3.2 plus 1.5j to the variable d. In Python, complex numbers are represented by a real part followed by an imaginary part, where the imaginary part is denoted by the suffix lowercase j or uppercase j. Next line uses the print function to output the result of the type function applied to the variable d. The output of the print statement is class complex. This output indicates that the type of the object stored in the variable d is a complex number. In Python, the complex type is used to represent numbers with both a real and an imaginary part. Now, look at the right side. We can also write the code as print type of 5, so the output is displayed class int. Here we didn't assign any variable, we found the type of the given integer number directly in the print statement. Likewise, we can code for all other data types also. In Python, data types can be classified as either mutable or immutable. A mutable data type is one whose values can be changed after they are created. Mutable data types in Python include lists, dictionary, set, etc. Here's an example that demonstrates the mutability of a list. First line, my_list equals 1, 2, 3, creates a list containing the elements 1, 2, 3, and assigns it to the variable my_list. In Python, lists are ordered, mutable collections of objects enclosed in square brackets. In the second line, my_list of 0 is equal to 4, modifies the value at index 0 of the my_list list. It assigns the value 4 to the first element of the list. Look at the table. In Python, lists are 0 indexed, so index 0 refers to the first element 1. It assigns the value 4 to the first element of the list. Next line of the code uses the print function to output the contents of the my_list list. The output of the print statement is 4, 2, 3. This output indicates that the first element of the my_list list has been modified from 1 to 4, while the other elements remain unchanged. An immutable data type is one whose values cannot be changed after they are created. Any attempt to modify an immutable value will result in a new value being created. Immutable data types in Python include int, float, string, bool, complex, and tuples. Here's an example that demonstrates the immutability of a string. Example 1. s equals hello assigns the string hello to the variable s0 equals h. This line attempts to modify the first character of the string s to uppercase h. However, since strings are immutable, this operation is not allowed. As a result, when you execute the code, it will raise a type error indicating that the string object does not support item assignment. The error message will be similar to type error, str object does not support item assignment. In example 2, s1 equals hello assigns the string hello to the variable s1. Next line, s2 equals s1.upper, calls the upper function on the string s1 and assigns the result to the variable s2. The upper function returns a new string where all the characters are converted to uppercase. Next line, print s1, uses the print function to output the value of s1. The output of the first print statement is hello. This is because the upper function does not modify the original string s1. It creates a new string with uppercase letters and assigns it to s2, leaving s1 unchanged. Next line, print s2, uses the print function to output the value of s2. The output of the second print statement is uppercase hello. This is the result of calling the upper function s1 and storing the uppercase version of the string in s2. Note that once an immutable object loses its binding to its variable, the Python interpreter may delete the object and release the allocated memory to be used for other tasks. This process of automatic memory management is called garbage collection. Let's discuss about the keywords in Python. Keywords in Python are reserved words that have a special meaning in the language. These words cannot be used as variable names, function names, or any other identifiers. For checking or displaying the list of keywords available in Python, we have to write the following two statements. Import keyword, print, keyword.kwlist. You can see, a list of all the keywords in Python are displayed in this picture. These keywords have a specific meaning and purpose in Python. Example, if and else are used for conditional statements, while is used for loops, def is used to define functions, and so on. In Python, an expression is a combination of one or more values, operators, and/or function calls that can be evaluated to produce a result. Expressions can be used to perform a wide variety of calculations and manipulations on data. Here are some examples of simple expressions in Python. X equals 10 is an assignment expression, y equals x plus 5 is an addition expression, and z equals x plus y, asterisk 2 is a complex expression. We have a more complex expression that adds x and y, multiplies the result by 2, and assigns the final value to the variable z. Expressions can also include function calls, which can be used to perform more complex calculations or manipulations on data. In this example, we're using the math.sqrt function to calculate the square root of the variable x and assign the result to the variable y. The math module contains a variety of mathematical functions that can be used in expressions. In Python, expressions can also include conditional statements, loops, and other control structures to perform more complex operations. Overall, expressions are a powerful tool in Python for working with data and performing calculations and manipulations on that data. Type conversion, also known as typecasting, is the process of converting a value from one data type to another. In Python, there are several built-in functions that can be used for type conversion. Here are some common examples of type conversion in Python. First one is int function. The int function can be used to convert a value to an integer data type. In this example, we're converting the floating point value 5.5 to an integer using the int function. The resulting value is 5. Next is the float function. The float function can be used to convert a value to a floating point data type. Now, look at the example. X equals 5, y equals float of x, print, y. In this example, we're converting the integer value 5 to a floating point number using the float function. The resulting value is 5.0. Next is the string function. The str function can be used to convert a value to a string data type. For example, x equals 5, y equals str of x, print, y. In this example, we're converting the integer value 5 to a string using the str function. The resulting value is the string 5, with quotation marks. Next is the bool function. The bool function can be used to convert a value to a Boolean data type. For example, x equals 5, y equals bool of x, print, y. Since x has a value of 5 which is non-zero, the bool function returns true. Therefore, the value of y becomes true. The statement print of y outputs the value of y, which is true, as output. Next is the chr function. The chr function can be used to convert a value into a character data type. For example, x equals chr of 65, print x. In the given code, the statement x equals chr of 65 assigns the character represented by the Unicode value 65 to the variable x. The chr function in Python takes an integer representing a Unicode point and returns the corresponding character. In Unicode, the code point 65 corresponds to the uppercase letter A. Therefore, chr65 returns the character A, which is then assigned to the variable x and prints as output. In Python, operators are special symbols or functions that are used to perform operations on one or more operands. An operand is a value or variable that an operator acts upon. Operators, when applied on operands, form an expression. Same operator can behave differently on different data types. Here are some examples of commonly used operators in Python. First one is the mathematical or arithmetic operators, are used to perform various mathematical operations on numeric data types such as integers and floating point numbers. These operators include addition, which adds values together. In example 1, we first assign the value 10 to the variable x, and then assign the value 3 to the variable y. After that, we use the print function to output the sum of x and y, which is 13, as output. In addition, second example, we are going to learn about concatenating strings. Strings can be added together with the plus operator. To concatenate the string hello world, give the statement using the concatenation operator, plus. Now look at the Python code print, hello plus world, concatenates the two string literals hello and world using the plus operator. In Python, when you use the plus operator with two strings, it performs string concatenation, joining the two strings together. So, the output will be hello world, without spaces. Next arithmetic operator is subtraction. It subtracts the second value from the first value. In example 1 of subtraction, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x, y subtracts the value of y from x, resulting in 7. Finally, the print function outputs the result, 7, to the console. In example 2 of subtraction, we assign the value 30 to the variable x and the value 80 to the variable y. Then, the expression x, y subtracts the value of y from x, resulting in -50. Finally, the print function outputs the result, -50, to the console. Next arithmetic operator is multiplication, which multiplies two values together. In example 1 of multiplication, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x asterisk y multiplies the values of x and y, resulting in 30. Finally, the print function outputs the result, 30, to the console. In example 2 of multiplication, we have string multiplication. Here, the code print, hello asterisk 5, uses the asterisk operator to repeat the string hello 5 times and then prints the result. The string hello is multiplied by 5 using the asterisk operator. This operation results in the string being repeated 5 times, generating hello 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 as output. Next arithmetic operator is division, which divides the first value by the second value. In example 1 of division, the code performs division between x and y using the slash operator and then prints the result. We assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x slash y divides x by y, resulting in 3.3333333333333335. The result is a floating point number because at least one of the operands is a float. In this case, x is an integer and y is an integer, but the division operation automatically promotes the result to a float. Next arithmetic operator is remainder or modulus. It returns the remainder of the division of the first value by the second value. In example 1 of remainder or modulus, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x%y calculates the remainder when x is divided by y, resulting in 1. In this case, 10 divided by 3 equals 3 with a remainder of 1. Finally, the print function outputs the result, 1, to the console. Next arithmetic operator is exponentiation, which raises the first value to the power of the second value. In example 1 of exponentiation, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x, exponentiation y, raises x to the power of y, resulting in 1000, since 10 raised to the power of 3 is 1000, it prints 1000 as output. Next arithmetic operator is integer division or floor division, which performs integer division and returns the largest integer value that is less than or equal to the result. In example 1 of integer division or floor division, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x floor division y performs floor division, which divides x by y and rounds the result down to the nearest whole number. In this case, 10 divided by 3 equals approximately 3.3333333333333335, but since floor division rounds down, the result is 3. Finally, the print function outputs the result, 3, to the console. In example 2 of integer division or floor division, we assign the value 7.0 to the variable x, a floating point number, and the value 2 to the variable y, an integer. Then, the expression x floor division y performs floor division, which divides x by y and rounds the result down to the nearest whole number. In this case, 7.0 divided by 2 equals 3.5, but since floor division rounds down, the result is 3.0, represented as a floating point number. Finally, the print function outputs the result, 3.0, to the console. In example 3 of integer division or floor division, we assign the value -9 to the variable x and the value 2 to the variable y. Then, the expression x floor division y performs floor division, which divides x by y and rounds the result down to the nearest whole number. In this case, -9 divided by 2 equals -4.5, but since floor division rounds down, the result is -5. Finally, the print function outputs the result, -5, to the console. An operator can be termed as unary or binary, depending upon the number of operands it takes. A unary operator takes only one operand and a binary operator takes two operands. In this example, in the expression -5*3 plus 6 minus 1, the first minus sign is a unary minus and the second minus sign is a binary minus. The multiplication and addition operators are binary operators. Arithmetic operators in Python have different precedence levels, which determine the order in which the operations are performed. The precedence of arithmetic operators in Python is as follows, from highest to lowest. First precedence, parentheses can be used to group sub-expressions and override the default order of evaluation. Exponentiation operator has the highest precedence among the arithmetic operators. Multiplication, division, and modulus, these operators have the same precedence and are evaluated left to right. Addition and subtraction, these operators have the same precedence and are evaluated left to right. Here's an example that demonstrates how the order of operations is determined by operator precedence. In the expression, x equals 5 plus 10 asterisk 2 exponentiation 2/4, first, the exponentiation operator is evaluated. In this case, 2 to the power 2 equals 4. Next, the multiplication operator is evaluated. 10 times 4 equals 40. Then, the division operator is evaluated. 40 divided by 4 equals 10.0. Note that when dividing two integers in Python 3, the result is a float. Finally, the addition operator, plus, is evaluated. 5 plus 10.0 equals 15.0. Therefore, the final value of x is 15.0. When you print x, the output will be 15.0. Relational operators, also known as comparison operators, are used to compare two values or variables and return a Boolean value, true or false, based on the comparison. In an expression, comprising both arithmetic and relational operators, the arithmetic operators have higher precedence than relational operators. The syntax is expression 1, comparison operator, expression 2. In Python, the following relational operators are available. Equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. Here are some examples of how these relational operators can be used. Consider variable x and y are assigned the values 5 and 10 respectively for all these 6 Python statements. In the first statement, it compares the values of x and y using the equality operator. Since the value of x is 5 and the value of y is 10, the expression x equals y evaluates to false. This is because x and y have different values. In the second statement, it compares the values of x and y using the not equal to operator. Since the value of x is 5 and the value of y is 10, the expression x not equal to y evaluates to true. This is because x and y have different values, and the not equal to operator returns true when the values are not equal. Therefore, when you print the result, the output will be true. In the third statement, it compares the values of x and y using the less than operator. Since the value of x is 5 and the value of y is 10, the expression x less than y evaluates to true. This is because 5 is less than 10. Therefore, when you print the result, the output will be true. In the fourth statement, it compares the values of x and y using the greater than operator. Since the value of x is 5 and the value of y is 10, the expression x greater than y evaluates to false. This is because 5 is not greater than 10. Therefore, when you print the result, the output will be false. In the fifth statement, it compares the values of x and y using the less than or equal to operator. Since the value of x is 5 and the value of y is 10, the expression x less than or equal to y evaluates to true. This is because 5 is less than or equal to 10. Therefore, when you print the result, the output will be true. In the sixth statement, it compares the values of x and y using the greater than or equal to operator. Since the value of x is 5 and the value of y is 10, the expression x greater than or equal to y evaluates to false. This is because 5 is not greater than or equal to 10. Therefore, when you print the result, the output will be false. Relational operators are applied to strings also. When the relational operators are applied to strings, strings are compared left to right, character by character, based on their ASCII codes, and also called ASCII values. In the ASCII table, each character is assigned a unique numerical value. The lowercase letters have ASCII values ranging from 97 to 122 Z, while the uppercase letters have ASCII values ranging from 65 to 90 Z. In first example, it compares two string literals, lowercase hello and uppercase hello, using the less than operator. When comparing strings, Python uses the ASCII values of the characters. In this case, the ASCII value of lowercase h in hello is greater than the ASCII value of uppercase h in hello. Therefore, lowercase hello is considered greater than uppercase hello in lexicographical order. As a result, the expression hello less than hello evaluates to false. When you print the result, the output will be false. In the second example, it compares two string literals, goodbye and hello, using the less than or equal to operator. When comparing strings in lexicographical order, Python compares the characters from left to right based on their ASCII values. In this case, the first character of goodbye is G, while the first character of hello is H. Since G has a lower ASCII value than H, goodbye is considered less than hello in lexicographical order. Therefore, the expression goodbye less than or equal to hello evaluates to true because goodbye comes before hello in lexicographical order. In the third example, it compares two string literals, hello and hello, using the not equal to operator. In this case, both strings are identical, as they have the same sequence of characters. Therefore, the expression hello not equal to hello evaluates to false. The not equal to operator returns false when two values are equal, and true when they are not equal. Since the strings are equal in this case, the output will be false. In the fourth example, it compares two string literals, hello and hello, using the equal to operator. Since both strings have the same sequence of characters, the expression hello equal to hello evaluates to true. The equal to operator returns true when two values are equal, and false when they are not equal. In this case, the strings are indeed equal, so the output will be true. Logical operators in Python are used to perform logical operations on Boolean values. They are used in control statements and loops to make decisions based on the truth value of expressions. The three logical operators in Python are AND, returns true if both operands are true, and false otherwise. OR, returns true if at least one of the operands is true, and false otherwise. NOT, returns the opposite of the operand's truth value, reverses the state of operand or condition. Here are some examples of using logical operators. In the given example, it assigns the values 5, 10, and 5 to the variables x, y, and z, respectively. In the first print statement, it evaluates the expression x equal to z and y greater than x. The AND operator performs a logical conjunction. It returns true if both operands are true, and false otherwise. In this case, the expression x equal to z evaluates to true because x and z both have a value of 5. The expression y greater than x also evaluates to true because 10 is greater than 5. Since both operands of the AND operator are true, the overall expression x equal to z and y greater than x evaluates to true. In the second print statement, it evaluates the expression x greater than y or x equal to z. The OR operator performs a logical disjunction. It returns true if at least one of the operands is true, and false if both operands are false. In this case, the expression x greater than y evaluates to false because 5 is not greater than 10. The expression x equal to z evaluates to true because x and z both have a value of 5. Since one of the operands of the OR operator, x equal to z, is true, the overall expression x greater than y or x equal to z evaluates to true. Therefore, when you print the result, the output will be true. In the third print statement, it evaluates the expression not x equal to z. The not operator is a logical negation operator. It reverses the truth value of an expression. If the expression is true, not makes it false. If the expression is false, not makes it true. In this case, the expression x equal to z evaluates to true because x and z both have a value of 5. The not operator then negates the truth value of x equal to z. Since x equal to z is true, not x equal to z evaluates to false. Therefore, when you print the result, the output will be false. Logical operators in Python also have different precedence levels, which determine the order in which the operations are evaluated. The precedence of logical operators in Python is as follows, from highest to lowest. Not. The not operator has the highest precedence among the logical operators. and. The and operator is evaluated before the or operator. Or. The or operator is evaluated last. Here's an example that demonstrates how the order of operations is determined by operator precedence. X equals true or false and not true, print X. This expression follows the order of operations, precedence, in Python. The not operator has the highest precedence, so not true evaluates to false. Next, the and operator is evaluated. False and not true evaluates to false because one of the operands, false, is false. Finally, the or operator is evaluated. True or false and not true evaluates to true because one of the operands, true, is true. Therefore, the final value of X is true. When you print X, the output will be true. Shorthand or augmented assignment operators in Python are used to combine an arithmetic or bitwise operation, binary operation, with an assignment in a concise way. Instead of writing X equals X plus Y, for example, you can use the shorthand operator plus equals. These operators modify the value of the variable in place, rather than creating a new variable, and can be used with all of the basic arithmetic and bitwise operators. Here is a list of shorthand operators in Python, along with examples of their usage. First one is, plus equals, adds the right operand to the left operand and assigns the result to the left operand. Example 1. X plus equals 5 is equivalent to X equals X plus 5. Next one is, minus equals, subtracts the right operand from the left operand and assigns the result to the left operand. Example 2. X minus equals 5 is equivalent to X equals X minus 5. Next one is, asterisk equals, multiplies the left operand by the right operand and assigns the result to the left operand. Example 3. X asterisk equals 5 is equivalent to X equals X asterisk 5. Next one is, forward slash equals, divides the left operand by the right operand and assigns the result to the left operand. Example 4. X slash equals 5 is equivalent to X equals X slash 5. Next one is, modulus equals, calculates the modulus of the left operand with the right operand and assigns the result to the left operand. Example 5. X modulus equals 5 is equivalent to X equals X modulus 5. Next one is, exponentiation equals, raises the left operand to the power of the right operand and assigns the result to the left operand. Example 6. X exponentiation equals 5 is equivalent to X equals X exponentiation 5. Next one is, integer division equals, performs integer division on the left operand with the right operand and assigns the result to the left operand. Example 7. X integer division equals 5 is equivalent to X equals X integer division 5. Membership operators in Python are used to test whether a value or a variable is a member of a sequence, such as a string, list, tuple, or set. Python provides two membership operators, in and not in. First, we will see how to use membership operators in strings. First one is, in operator returns true if a character or substring exists in the given string. Second one is, not in operator returns true if a character or substring does not exist in the given string. To use membership operators in strings, it is required that both the operands used should be of string type. Substring in string, substring not in string. In this example, it assigns the string hello, world, to the variable my_string. Then, it uses the in operator with the not operator to check if certain substrings are present or not in my_string. In the first print statement, world not in my_string checks if the substring world is not present in my_string. Since world is indeed present in my_string, the expression evaluates to false. In the second print statement, goodbye not in my_string checks if the substring goodbye is not present in my_string. Since goodbye is not present in my_string, the expression evaluates to true. Therefore, when you print the results, the output will be false for the first print statement, true for the second print statement. Identity operators in Python are used to compare the memory location of two objects. They check whether two objects are the same object or not. Python provides two identity operators, is and is not. First one is operator returns true if the left operand and the right operand refer to the same object in memory. That is, both variables are pointing to the same object. var1 is var2 results to true if id of var1 is equal to id of var2. Second one is not operator returns true if the left operand and the right operand does not refer to the same object in memory. That is, both variables are not pointing to the same object. var1 is not var2 results to true if id of var1 is not equal to id of var2. In example 1, it creates a list 1, 2, 3 and assigns it to the variable x. Then, it assigns x to the variable y. In the first print statement, it checks if x and y refer to the same object using the is operator. Since both x and y refer to the same list object, the expression x is y evaluates to true. In the second part, a new list, 1, 2, 3, is created and assigned to the variable z. The print statement checks if x and z refer to the same object using the is operator. However, even though x and z have the same values, they are separate objects in memory. Hence, the expression x is z evaluates to false. Therefore, when you print the results, the output will be true for the first print statement, false for the second print statement. In example 2, it assigns the strings hello and world to the variables a and b, respectively. Then, it checks if a is not the same object as b using the is not operator. Since a and b are different string objects, the expression a is not b evaluates to true. In the second part, two separate lists, 1, 2, 3, are created and assigned to the variables c and d. The print statement checks if c is not the same object as d using the is not operator. Since c and d are separate list objects even though they have the same values, the expression c is not d evaluates to true. Therefore, when you print the results, the output will be true for the first print statement, true for the second print statement. Python Programming Fundamentals Part 3. In this video, we are going to discuss about the user input, user-defined functions, indentation in Python, rules and conventions for writing Python programs, comments, debugging and practical implementation. So let's dive in and get started. Let's discuss about the user input. While writing a program, we need to fetch some input from the user. The values inputted by the user are fetched and stored in variables. Python provides the following important functions for getting users' input. First function is the input function. In Python, you can get user input from the command line using the input function. The input function reads a line of text from the user and returns it as a string. Here's an example of how to use the input function to get user input. Example 1. Name equals input of enter your name, print, hello, plus name plus exclamation point. In this example, the input function is used to get the user's name from the command line. The user's input is assigned to the name variable, which is then used to print a personalized greeting. When you run this program, it will prompt the user to enter their name, enter your name. The user can then type their name and press enter your name, Alice. The program will then print a greeting that includes the user's name, hello, Alice. On the left-hand corner, you can see how it is practically implemented. You can also use the input function to get numerical input from the user. However, you need to convert the input to an integer or float before using it in mathematical operations. Here's an example. Example 2. Age equals int of input of enter your age. Print, you will be plus str of age plus 1 plus next year. In this example, the input function is used to get the user's age as a string. The int function is then used to convert the user's input to an integer, which is assigned to the age variable. The program then uses the age variable to print a message that includes the user's age plus 1. When you run this program, it will prompt the user to enter their age. Enter your age. The user can then type their age and press enter. Enter your age, 25. The program will then print a message that includes the user's age plus 1. You will be 26 next year. Now check the practical implementation. In Python, eval is a built-in function that is used to evaluate an expression dynamically, which is represented as a string. The function takes a string as an argument and returns the result of evaluating that string as a Python expression. The syntax of the eval function is eval of expression, globals equals none, locals equals none. Here, expression is a string that contains a valid Python expression. Globals and locals are optional dictionaries that specify the global and local namespace, respectively. By default, the eval function uses the current local and global namespace. Here's an example of using the eval function. X equals 10, y equals 20, z equals eval of x plus y. Print z. The eval function is used to evaluate the value of a string. It takes a string as an argument, evaluates the string as a number, and returns the numeric result. In this example, the string x plus y is evaluated using the current global and local namespace. Since x is 10 and y is 20, the result of evaluating x plus y is 30, which is assigned to the variable z. In eval function, note that, if the given argument is not a string, or if it cannot be evaluated as a number, then eval results in an error. Here, x plus y is not given in quotation mark, to be string. So type error is displayed in the console. Type error, eval arg1 must be a string, bytes, or code object. In Python, you can define your own functions to perform specific tasks or calculations. A function is a group of statements that exists within a program for the purpose of performing a specific task. Instead of writing a large program as one long sequence of instructions, it can be written as several small functions, each one performing a specific part of the task. Let's see how to define and call a function in Python. User-defined functions can take one or more inputs, called arguments or parameters, and can return a value or perform some action. A user-defined Python function is created or defined by the def statement followed by the function name and parentheses as shown in the syntax. Def function underscore name of comma underscore separate underscore list underscore of underscore parameters colon. Docstring code block return. Here's a breakdown of each part of the def function syntax. Def, this keyword is used to define a function in Python. Function underscore name, this is the name of the function. Function names should be descriptive and follow the naming conventions of Python. Parameters, these are the input values that are passed to the function when it is called. Parameters are optional and can be one or more. Docstring, this is an optional documentation string that describes the function. It is used to provide information about what the function does, its parameters, and its return value. Code block, this is the actual code that performs the task of the function. It should be indented and start on the line after the function definition. Return, this keyword is used to return a value from the function. It is optional and can be used to return a value or object to the caller. If no return statement is specified, the function returns none by default. Here are some examples of a simple user-defined function. Example 1. Def greet of name colon. Print, hello, plus name plus exclamation point. This function is called greet and takes one argument, which is a name. The function simply prints a greeting that includes the name. To use this function, you can call it with an argument. Greet of Alice. This will print the greeting, hello, Alice. Example 2. You can also define a function that returns a value using the return keyword. Def add of a, b, colon. Return a plus b. This function is called add and takes two arguments, a and b. The function returns the sum of a and b. To use this function, you can call it and assign the result to a variable. Result equals add 3, 5, print, result. This will print the sum of 3 and 5 and displays 8 as output. You can define functions that have default parameter values, allowing you to call them without specifying all the arguments. Here's an example. Def power of base, exponent equals 2 colon. Return base raised to the power of exponent. This function is called power and takes two arguments, base and exponent. The exponent argument has a default value of 2. The function returns the base raised to the power of exponent. To use this function, you can call it with just the base argument. Result equals power of 3. Print, result. This will print the result of raising 3 to the power of 2 as 9. You can also call the function with both the base and exponent arguments. Result equals power of 3, 3. Print, result. This will print the result of raising 3 to the power of 3 as 27. Statements below def begin with 4 spaces. This is called indentation. It is a requirement of Python that the code following a colon must be indented. Practical implementation on user-defined functions. Example 1. Let us define a simple function, which does not return any value, by using the command def func1 and call the function. The output of the function will be, it is interesting to learn Python functions. Now, look at the Python code. The provided Python code defines a function named func1. The function has no parameters, indicated by empty parentheses. Within the function body, there is a single line of code that prints the string it is interesting to learn Python functions to the console using the print function. By calling func1 outside the function definition, the function is executed, and the output it is interesting to learn Python functions will be displayed in the console or output window, indicating the successful execution of the function. Example 2. To write a user-defined function to print a right-angled triangle. Now look at the Python code for line-by-line explanation. The given Python code defines a function called triangle. Inside the function, there are 4 print statements that print a series of asterisk in a triangular pattern. Each print statement represents a row of the triangle, with the number of asterisks increasing by 1 from the previous row. When you call the triangle function, it executes the code inside the function. As a result, the following triangle pattern will be printed. Example 3. To write a Python function to compute area of a rectangle. Now look at the Python code. The provided Python code defines a function called area rectangle that calculates the area of a rectangle. The function takes two parameters, length and breadth, which represent the length and breadth of the rectangle, respectively. Inside the function, the area of the rectangle is calculated by multiplying the length and breadth together, and the result is stored in the area variable. The return statement is used to specify the value that will be returned by the function. In this case, the area variable is returned as the result of the function. Outside the function, the code print area rectangle of 40,20 calls the area rectangle function with the arguments 40 and 20, representing a rectangle with a length of 40 and breadth of 20. The returned area is then printed to the console using the print function. So, when you run the code, it will output 800. In Python, indentation is used to indicate the block of code associated with a particular control statement or function definition. Python uses white space to delimit blocks of code, unlike other programming languages that use curly braces, keywords, or other symbols. Indentation is a key part of the syntax in Python, and incorrect indentation can cause errors or change the meaning of your code. You should be consistent in your indentation style throughout your code, using either spaces or tabs to indent each level. It is a requirement of Python that the code following a colon must be indented. Here's an example of how indentation is used in a function definition. Now look at the first Python code. This Python program is indented correctly. How do you know? In the first Python code, below the def func1 statement, we have to shift the print statement 4 spaces to the right. This is indentation. I have marked the space in yellow color. When you leave indent, that is spacing, in front of the print function, it will give the expected output. Now look at the second Python code. When we write print function right below the def function, without shifting to the right 4 spaces, it will show indentation error. You can see the indentation error, which is marked in red color. The error can be removed by making proper indentation before the print function. At least one indent is required to make your code work successfully. Thus, indentation is shifting of a statement to the right of another statement by adding white space before a statement. While working with Python, the following rules and conventions are to be kept in mind. First rule is the statement termination. The newline character is the most common way of terminating statements in Python, and it is used to indicate the end of a line of code. That is, when you end typing a statement in Python by pressing the Enter key, the statement is considered terminated by default. Second rule is clarity and simplification of expression. Clarity and simplification of expressions in Python can make your code more readable, maintainable, and easier to understand for other developers. Here are some tips to achieve clarity and simplification in Python expressions. Use descriptive variable names. Use meaningful names for your variables to help you and other developers understand the purpose of each variable. Next is, break down complex expressions into smaller ones. Instead of writing a complex expression in a single line, break it down into smaller expressions that are easier to read and understand. This can also help you avoid errors in your code. Next is to use parentheses to clarify order of operations. Use parentheses to clarify the order of operations in complex expressions. This can help prevent confusion and errors in your code. Next is to avoid unnecessary code. Remove any unnecessary code that doesn't add value to your program. This can simplify your code and make it easier to read. Next is to use built-in functions and libraries. Use built-in functions and libraries whenever possible, as they are often more efficient and easier to understand than writing your own code. Next is to use list comprehensions. Use list comprehensions to simplify the creation of lists from other lists or data structures. Next is to use conditional expressions. Use conditional expressions to simplify if-else statements, particularly when the statements are simple. By applying these tips, you can create more clear, concise, and understandable expressions in your Python code. Next rule is simplicity of instructions. Here you have to avoid complex instructions. One instruction per task should be given. Follow standards of a language. Use appropriate comments. Keep the names of the variables short, simple, and meaningful. Next rule is maximum line length. Line length should be of maximum 79 characters. Next rule is lines and indentation. Blocks of code in Python are denoted by line indentation, which is implemented using 4 spaces per indentation level. Next rule is to avoid multiple statements on one line. Although you can type multiple statements using semicolon between 2 statements in a single line, it is not recommended. In Python, comments are used to document code and provide context for other developers. Comments are statements in a script that are used to explain Python code and are ignored by the Python interpreter and do not affect the execution of the program. Let's discuss about the single-line comment. Single-line comment in Python start with the hash symbol and continue until the end of the line. For example, hashtag this is a single-line comment can be written either on the top, right side, or bottom of the statement. Multi-line comments can be created using triple quotes, either single triple quotes or double triple quotes. This is sometimes called a docstring and is typically used to document functions or modules. Look at the example 1, how multi-line comments are used. In addition to describing the purpose and functionality of your code, comments can also be used to temporarily disable code that is not currently needed or to leave reminders for future modifications. Look at example 2. We are temporarily disabling the print hello world code. When writing comments, it is important to keep them concise and to the point. Avoid commenting on obvious code, but do comment on code that may be difficult to understand. Good commenting practices can make your code more readable, maintainable, and easier for other developers to understand. Debugging in Python refers to the process of identifying and fixing errors, bugs, and other issues in your code. Debugging is an essential part of the software development process, as it allows you to find and correct problems before they cause issues for users or other parts of your program. Errors in Python are classified into 3 types: syntax error, runtime error, and logical error. Let's discuss one by one in detail. A syntax error in Python is an error that occurs when the interpreter is unable to parse your code due to a mistake in the syntax. In other words, the grammatical rules of a programming language. Syntax errors are common when writing Python code, especially if you're new to the language. Examples of syntax errors in Python include leaving out a symbol, such as colon, comma, or forgetting to close a parenthesis or a quote. Next is misspelling a keyword. Using an incorrect keyword, such as typing print instead of print. Next is incorrect indentation. Forgetting to indent code within a block, such as within a loop or a function. When a syntax error occurs, Python will raise a syntax error exception and provide information about the specific error, including the line number and a description of the problem. The error message can help you locate and correct the issue in your code. Example of syntax error. Now, look at the Python code. For just printing class 11. Here we started with single quotes and ended with double quotes. Hence the output received syntax error, unterminated string literal. Next error is the runtime error. A runtime error in Python, or any programming language, is an error that occurs while a program is running. These errors are often referred to as exceptions in Python. When a runtime error occurs, it means that the program has encountered a problem that it cannot handle, and the program will be terminated. A number of built-in exceptions are defined in the Python library for runtime error. Zero division error, name error, type error, value error, and index error. We discuss about the types of runtime error. First one is the zero division error. Zero division error occurs when a program tries to divide a number by 0. Now look at the example 1 Python code. The code print 10/0 will indeed raise a zero division error in Python. This error occurs when you try to divide a number by 0, which is mathematically undefined. Next runtime error is the name error. Now look at the example 2 Python code. When 10 is assigned to variable a, it gets printed as output 10. But unknown variable b gets printed, name error is displayed. Next runtime error is the type error. This occurs when a program tries to use a variable or value of the wrong type. Now look at example 1 Python code. In the first print statement, 2 strings are concatenated, joined together, to form 22 as output. But in the second print statement, a string and a number is concatenated, which results in type error. Now look at example 2 Python code. We cannot add list and a tuple together. Type error occurs. Remember, lists are enclosed in square brackets and tuples in parentheses. Next runtime error is the value error. This occurs when a program tries to use a variable or value that is outside the expected range. Now look at example 1. In the first print statement, the float value 27.45 is converted into integer value as 27. In the second print statement, a string is converted to integer value, results in value error. Next runtime error is the index error. This occurs when a program tries to access an element in a list or other data structure that does not exist. Now look at example 2. To access an element in a list, L1 of 3 results in 44. How did we get 44? Now, look at the index table on the left side. Index starts from 0. So index 0 equals 11, index 1 is equal to 22, index 2 is equal to 33, and index 3 is equal to 44. So L1 of 3 is equal to 44. Now look at the second print statement, L1 of 7 results in index error. Since index 7 is out of range, we have values only until index 3. So the second print statement, L1 of 7 results in index error. Next error is the logical error. In Python, logical errors are errors that occur when the code does not do what it is intended to do, even though it may still run without any syntax or runtime errors. These errors are also known as bugs, semantic errors, and are often caused by mistakes in the logic of the code. Here are some common examples of logical errors in Python. Off by one errors. These occur when the code accesses elements of a data structure, such as a list or array, with an incorrect index or range. For example, if you have a list with 10 elements, but you try to access the 11th element, you will get an off by one error. Next one is infinite loops. These occur when the code gets stuck in a loop that never ends. This can happen when the loop condition is not properly defined or when the loop does not terminate when it should. Next one is incorrect conditionals. These occur when the code uses incorrect conditional statements, such as if, elif, and else, or the conditionals are not evaluated correctly. For example, if you use the wrong comparison operator, example, using single equals instead of double equals equals in an if statement, you may not get the expected results. Next one is mixed up variables. These occur when the code uses variables incorrectly or assigns values to the wrong variables. For example, if you have two variables with similar names, you may accidentally use the wrong variable in your code. Next one is incorrect function calls. These occur when the code calls functions with incorrect parameters or calls the wrong functions altogether. This can result in unexpected behavior and errors. In this example of logical error, we are finding the average of the two numbers. Now look at the code. Two floating point numbers are inputted from the user and stored in variable x and y respectively. Now, in the third line, the order of operations in arithmetic, division is evaluated before addition. The program will not give the right answer. This is known as logical error. To rectify this problem, we will simply add parentheses, z equals open parentheses x plus y close parentheses /2. Conditional looping constructs, Part 1. In this video, we are going to discuss about the types of statements in Python, program control flow, uses of indentation, conditional statements, if statement, if-else statement, if-elif-else statement, nested if-elif-else statement and practical implementation. So let's dive in and get started. In the previous videos, we learned that Python executes one statement after another in a program following a sequential way. All these statements are executed by the Central Processing Unit, CPU. We will now focus on the logic unit which makes a computer think, so we need to write the code. In real-life scenario, let's take an example of traffic light control. The lights cycle through different colors, red, green, and yellow, based on predefined timing rules. The loop continues indefinitely, ensuring smooth traffic. When designing programs, there are often points where a decision must be made. This decision is known as selection and is implemented in programming using if statements. Selection is a decision or question. At some point, a program may need to ask a question because it has reached a step where one or more options are available. Depending on the answer given, the program will follow a certain step and ignore the others. Selection allows there to be more than one path through a program. In this second example, in the roller coaster entrance, if-else condition is used here. If front row, queue here, else if all other rows queue here. Here, we will discuss about the statements in Python. A statement is a logical instruction which is executed while running a program. Statements are the instructions given to the computer to perform any kind of action. A statement is a line of code that performs a specific action or task. It is the smallest unit of code that can be executed by the interpreter. A statement in Python can be an assignment statement, a function call, a loop statement, a conditional statement, or any other valid Python expression. Statements are categorized into three types: empty statement, simple statement, compound statement. Let's learn one by one in detail. An empty statement in Python is a statement that does nothing. Empty statements are used when the syntax of the language requires a statement to be present, but you don't want to execute any code. The pass keyword in Python is used to represent an empty statement. The pass statement does nothing and is used as a placeholder when a statement is required syntactically, but you don't want to execute any code. It is a null operation. Syntax is for condition_1: pass. Let's see an example. In a for loop, you might use pass to indicate that there is no code to be executed in the loop body. In this example, this code creates a loop that will iterate I through the numbers 0 to 9, but it doesn't execute any code within the loop body. It's a way to structure a loop when you want to define the loop structure but postpone writing the actual code that should be executed within the loop. In Python, a simple statement is a statement that performs a single action or command. It usually consists of a single line of code and ends with a new line character. Any single executable statement is a simple statement in Python. For example, name equals input of enter your name. Print name. This is a simple statement, just inputting a name and printing the name. Some examples of simple statements include assignment statements, assigning a value to a variable, such as x equals 10. Expression statements, evaluating an expression, such as x equals 2 plus 3. Function call statements, calling a function with arguments, such as print, hello, world. Import statements, importing a module or package, such as import math. Return statements, returning a value from a function, such as return x asterisk y. Simple statements can be combined to form more complex statements and control structures, such as loops and conditionals. In Python, a compound statement is a statement that consists of one or more simple statements, grouped together with a block of code. The block of code is defined by indentation, which is typically for spaces or one tab. A compound statement represents a group of statements executed as a unit. Compound statements are used to create control structures such as loops, conditionals, functions, and classes. Syntax is compound statement header, multiple simple statements or compound statements indented at same level. Here, the header line starts with the keyword and ends at colon. The body consists of more than one simple Python statement or compound statement. Here is an example of a function definition. Def greet, name, print, hello, plus name plus exclamation point. This compound statement defines a function called greet that takes a parameter name. The block of code within the function will execute when the function is called. Let's discuss about the program control flow. The order of execution of the statements in a program is known as flow of control. Flow of control means to determine the next statement to be executed. The control and flow of a program can be classified into three categories: sequential statements, selection or conditional statements, iterative or looping statements. Let's learn one by one in detail. In Python, sequential statements refer to a sequence of statements that are executed one after the other in the order they are written, in a sequential order or linear fashion. Sequential statements are simple statements or compound statements that are executed sequentially in the order they appear in the code. This picture includes the default flow of statement and is the simplest one. Statement 1 will be executed first, followed by statement 2 and then statement 3. Here's an example of sequential statements in Python. In this example, the sequence of statements are assigning the value 5 to the variable x, assigning the value 3 to the variable y, adding the values of x and y and storing the result in the variable z, printing the value of a z to the console. The statements are executed one after the other in the order they appear in the code. Sequential statements are the default way of executing code in Python, unless control structures such as loops or conditionals are used to modify the sequence of execution. In Python, selection or conditional statements are used to control the flow of execution based on a certain condition. They allow the program to choose or decide between two or more possible paths of execution based on the value of a condition. In conditional statement, if-else statement is used. In this picture, body of if statement will be executed if test condition evaluates to true, otherwise body of else will be executed. These are also called decision constructs. Let's see an example with if-else statement. In if-else statement, this statement executes one block of code if a condition is true, and another block of code if the condition is false. Look at the example. X equals 3, if x greater than 5 : print, x is greater than 5, else : print, x is less than or equal to 5. In this example, the code inside the if block is not executed because the condition x greater than 5 is false. Instead, the code inside the else block is executed. In Python, iterative or looping statements are used to execute a block of code repeatedly. They allow the program to perform the same task multiple times, without the need to repeat the code manually. The iteration construct means repetition of statements depending upon a condition test. The statements will be executed till the condition is true. As soon as the condition becomes false, the repetition stops. In this picture, the body of the loop will be executed until test expression evaluates to true. For example, while loop executes a block of code repeatedly while a condition is true. X equals 1, while x less than equal to 5 : print, x equals x plus 1. In this example, the code inside the loop is executed 5 times because the condition x less than equal to 5 is true. The value of x is incremented by 1 on each iteration of the loop, ensuring that the condition eventually becomes false. In Python, indentation is used to indicate blocks of code that are part of a larger structure, such as a loop, conditional statement, function, or class. Indentation is a mandatory aspect of the Python syntax and is used to group statements together into a single block. Indentation is adding white space before a statement. Leaving white space, spaces and tabs, at the beginning of a statement is called indentation. In Python, the same level of indentation associates statements into a single block of code. The interpreter checks indentation levels very strictly and throws up syntax errors if indentation is not correct, that is, indentation error. In this picture, the group of statements belongs to a particular block of code. Decision-making or conditional statements are used to control the flow of execution of a program depending upon the condition. There are 4 types of conditional statements in Python. If statement, if else statement, if else statement, nested if else statement. In Python, the if statement is the easiest method for making a decision and has a similar syntax as other programming languages. If the condition is true, then the indented statement gets executed. The indented statement implies that its execution is dependent on the header. There is no limit on the number of statements that can appear under an if block. If is a keyword, followed by a condition and ended with colon. We can use the condition with bracket also, but it is not mandatory. A statement or statements, block of code, are indented, usually 4 spaces, inside the if statement and are executed only if the condition evaluates to true, otherwise the control skips the block of statements inside if statement and only statement 2 will be executed. Let's see an example for if statement. A Python program to check if a number is positive. In this program, the user is prompted to enter a number. The program uses an if statement to check if the number is greater than 0. If the condition is true, it means the number is positive, and the program prints the number is positive. There is no else clause, so if the number is 0 or negative, no message will be printed. This example focuses on a simple concept and provides a straightforward output for positive numbers. Now check the output. The inputted value 78 is a positive number. Next conditional statement is if, else statement. The syntax is if condition colon, statement, s, else colon, statements. The condition is an expression that evaluates to either true or false. If the condition is true, then the code block under if statement will be executed, otherwise, the code block under else statement will be executed. Let's see an example for if else statement. Determining a sign of a number, if it's positive or negative. In this Python program, the if statement checks if the value of number is greater than 0. If it is, the program prints the number is positive to the console. If the condition is false, it goes to the else part, that is, the number is negative, the program prints the number is negative. In this program, the number is assigned as -5 and hence it prints, the number is negative. Example 2 of if-else statement. Write a Python code to find whether a given number is odd or even. Now look at the Python code on the left side. First line of code prompts the user to enter a number and stores it in the variable num. The int function is used to convert the user input into an integer since the input function returns a string by default. Next code block uses an if statement to check if the number stored in num is even or odd. The mod operator is the modulus operator, which returns the remainder of the division between num and 2. If the remainder is 0, it means the number is divisible evenly by 2 and therefore is even. If the condition num mod 2 equal to 0 evaluates to true, the code block inside the if statement is executed. In this case, it prints a message indicating that the number is even. If the condition num mod 2 equal to 0 evaluates to false, the code block inside the else statement is executed. In this case, it prints a message indicating that the number is odd. So, based on the value of num, the program determines whether it is even or odd and displays the appropriate message to the user. The outputs of checking both even and odd are displayed in the program. Let's see another example for if-else statement. To find absolute value of a number in Python. First line prompts the user to enter a number and stores it in the variable n. The int function is used to convert the user input into an integer. Next code block uses an if statement to check if the number n is greater than 0. If it is, it means the number is positive. In that case, it prints a message followed by the value of n, which represents the absolute value of the number. If the condition n greater than 0 evaluates to false, it means the number is either negative or 0. In this case, the code block inside the else statement is executed, printing a message followed by the negation of n, that is, the positive representation of the number. So, regardless of whether the input number is positive, negative, or 0, the code calculates and displays its absolute value accordingly. Here the absolute value of -75 is 75. Let's see another example for if-else statement. Program to check the divisibility of a number. Now look at the code. The code allows the user to enter 2 numbers, a numerator n and a denominator d. This code block uses an if statement to check if the numerator n is evenly divisible by the denominator d. The condition n mod d equal to 0 checks if the remainder of dividing n by d is equal to 0. If it is, it means that n is divisible by d. If the condition is true, the program prints a message indicating that n is divisible by d. If the condition is false, it means n is not divisible by d, and the program prints a message reflecting that. Note that the str function is used to convert the numbers n and d to strings before concatenating them with the other parts of the message. The \n is a new line character used to create a line break before printing the message. Now, check the output displayed below. Number 35 is divisible by 7 but number 25 is not divisible by 2. The if-elif-else statement in Python is used when you have more than 2 conditions to check. It allows you to execute different code blocks based on multiple conditions. The basic syntax for if-elif-else statement is if condition 1 : statements, elif condition 2 : statements, elif condition 3 : statements, else : statements. In if-elif-else statement, each condition is checked in order. If the first is false, the rest is checked and so on. If one of them is true, the corresponding branch executes, and the statement ends. Here else is optional. Number of elif is dependent on the number of conditions. Let's see an example for if-elif-else statement. Python program to find whether a number is positive, 0 or negative. First line asks the user to enter a number and stores it in the variable num. The input function is used to take user input, and the int function is used to convert the input into an integer since input returns a string by default. If num is greater than 0, this is the start of an if statement. It checks if the value of num is greater than 0. Print num is positive if the condition in the preceding if statement is true, that is, num is greater than 0, this line is executed. It prints the value of num followed by the string is positive to the console. Elif num equal to 0. If the condition in the if statement, num greater than 0, is false, the code moves to this line and checks if num is equal to 0. Print num is 0 if the condition in the preceding elif statement is true, that is, num is equal to 0, this line is executed. It prints the value of num followed by the string is 0 to the console. Now let's see the else part. If none of the preceding conditions are true, the code execution reaches this line, implying that num must be less than 0. Print num is negative in the else block, this line is executed. It prints the value of num followed by the string is negative to the console. You can check the output displayed here. Let's see another example for if-elif-else statement. Program to accept salary from the user and calculate the tax payable. First line prompts the user to enter the salary of a person and stores it in the variable salary. The input function is used to take user input, and the int function is used to convert the input into an integer. If salary less than equal to 50,000. This is the start of an if statement. It checks if the value of salary is less than or equal to 50,000. Tax equals 0.05 * salary. If the condition in the preceding if statement is true, that is, salary is less than or equal to 50,000, this line calculates the tax amount by multiplying 0.055% with the salary value and assigns it to the variable tax. Elif salary less than equal to 60,000. If the condition in the preceding if statement is false, the code moves to this line and checks if salary is less than or equal to 60,000. Tax equals 0.07 * salary. If the condition in the preceding elif statement is true, that is, salary is less than or equal to 60,000, this line calculates the tax amount by multiplying 0.077% with the salary value and assigns it to the variable tax. Elif salary less than equal to 70,000. If the condition in the preceding elif statement is false, the code moves to this line and checks if salary is less than or equal to 70,000. Tax equals 0.08 * salary. If the condition in the preceding elif statement is true, that is, salary is less than or equal to 70,000, this line calculates the tax amount by multiplying 0.088% with the salary value and assigns it to the variable tax. Now we look into the else part. If none of the preceding conditions are true, the code execution reaches this line, implying that salary must be greater than 70,000. Tax equals 0.10 * salary. In the else block, this line is executed. It calculates the tax amount by multiplying 0.10% with the salary value and assigns it to the variable tax. Finally, this line prints the original salary value and the calculated tax amount to the console. Check the output displayed here. Let's see another example for if-elif-else statement. Grade calculator. To determine your grade based on score. In this Python program, the input function is used to prompt the user to enter their score. The int function is used to convert the input into an integer so that it can be compared with the numerical conditions in the if-elif-else statements. The program uses a nested if-elif-else statement to assign a grade based on the score. Here's how the logic works. If the score is greater than or equal to 90, the grade is set to A. If the score is between 80 and 89, inclusive, the grade is set to B. If the score is between 70 and 79, inclusive, the grade is set to C. If the score is between 60 and 69, inclusive, the grade is set to D. If none of the above conditions are met, the grade is set to F. Finally, the program prints the grade corresponding to the score. In this output, score is 92 and grade is A. Next conditional statement is the nested if-else statement. A nested if-else statement in Python is a structure where you can place one if-else statement inside another if-else statement. This structure is used when you have more complex conditions that require multiple levels of checks. The syntax is if condition 1 : statements, if condition 2 : statements, elif condition 3 : statements, else : statements, elif condition 4 : statements, else : statements. Any number of these statements can be nested inside one another. Indentation is the only way to figure out the level of nesting. Let's see an example for nested if-else statement. Divisibility checker, to check if a number is divisible by 2 and/or 3 inch. In this Python program, the input function is used to prompt the user to enter a number. The int function is used to convert the input into an integer so that it can be used in the calculations and conditions of the program. The program uses nested if-else statements to check the divisibility of the number by 2 and 3. If the number is divisible by 2 and 3, it prints the number is divisible by both 2 and 3. If the number is divisible by 2 but not by 3, it prints the number is divisible by 2 but not by 3. If the number is divisible by 3 but not by 2, it prints the number is divisible by 3 but not by 2. If the number is not divisible by either 2 or 3, it prints the number is not divisible by either 2 or 3. Let's check the output for this program. If number is 24, the output will be, the number is divisible by both 2 and 3. But when the number is 27, the output will be, the number is divisible by 3 but not by 2. Conditional looping constructs, part 2. In this video, we are going to discuss about the iteration, for loop, range function, while loop, and practical implementation. So let's dive in and get started. In our day-to-day life, we repeat tasks. Like brushing teeth, getting ready to school, paying the electricity bill, etc. Here's an example of whack-a-mole game. Pop up a new mole, hit the mole, increase score, pop up a new mole, hit the mole, increase score. This kind of repetition is called iteration. So, iteration is the process of repeating steps. In Python, iteration is the process of repeating a set of instructions or a code block multiple times until a certain condition is met. Why is iteration important? Iteration is a fundamental concept in programming that allows you to perform repetitive tasks without having to manually repeat the code each time. Now let's see an example. Write a Python program to print first 10 natural numbers. Look at the Python code. We are printing 5 times to get the output. What would you do if you were asked to print 1 lakh natural numbers? Writing 1 lakh print statement would be tedious and not the right way. So, writing a program having a loop is a better solution here. Now see the pseudocode on the right side. Step 1. Take a variable count and set its value to 1. Step 2. Print the value to count. Step 3. Check the condition, count less than equal to 1 lakh. Step 4. Increment the variable, count plus equals 1. Step 5. Repeat the steps 2 to 4 as long as count has a value equal to 1 lakh. Let's discuss about the types of loops. Python provides 2 main types of iteration: for loop and while loop. For loops are called definite loops because statements are executed for a definite number of times. While loops are called indefinite loops because statements are executed until a logical condition remains true. Let's discuss one by one in detail. Let's learn about the for loop. The for loop statement is used to iterate or repeat over a range of values or a sequence, such as a list, tuple, or string. The basic syntax of a for loop is for variable in sequence : statements in body of loop, else : statements. In each iteration of the loop, the variable takes on the next value in the sequence, and the code block inside the loop is executed. Here, variable is a variable that takes a new value from the range each time loop is executed. Sequence may be a list, string, tuple. Else statement will be executed after all the iterations of for loop, if provided. Let's see some examples for loop. Now look at the first Python code. Here, sequence can be a string. Strings are characters or text written within quotation marks. This code uses a for loop to iterate over each character in the string welcome. Here's how it works. The loop begins by initializing the variable letter with the first character of the string welcome, which is W. The loop body executes, which in this case is a single line of code, print, letter. The print, letter, statement outputs the value of letter to the console. After executing the code inside the loop body, the loop moves to the next iteration. In each iteration, the value of letter is updated to the next character in the string. The loop continues this process until it reaches the end of the string welcome. Now you can check the output displayed on the console. Each character in the string welcome is printed on a separate line, resulting in the desired output. Now look at the second example. Here, sequence can be a tuple. Tuples are enclosed in parentheses. This code uses a for loop to iterate over each element in the tuple count. Here's how it works. The tuple count is defined with the values 10, 20, 30, 40, 50. The loop begins by initializing the variable c with the first element of the tuple, which is 10. The loop body executes, which in this case is a single line of code, print c. The print c statement outputs the value of c to the console. After executing the code inside the loop body, the loop moves to the next iteration. In each iteration, the value of c is updated to the next element in the tuple. The loop continues this process until it reaches the end of the tuple count. Now look at the output on the console. Each element in the tuple count 10, 20, 30, 40, 50 are printed on a separate line, resulting in the desired output. Now look at the third example. Here, sequence can be a list. Lists are enclosed in square brackets. This code uses a for loop to iterate over each element in the list numbers. Here's how it works. The list numbers is defined with the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The loop begins by initializing the variable n with the first element of the list, which is 1. The loop body executes, which includes an if statement to check if the current number n is even. The condition n mod 2 equal to 0 checks if n is divisible by 2 with no remainder, which indicates an even number. If the condition is true, that is, n is even, the code inside the if block is executed. The code inside the if block includes the print statement, which outputs the current number n along with the message is an even number. After executing the code inside the loop body, the loop moves to the next iteration. In each iteration, the value of n is updated to the next element in the list. The loop continues this process until it reaches the end of the list numbers. Here are some key points to remember for loop. The for loop in Python is used to iterate values from range of values, strings, lists, tuples, or dictionary. Else statement is optional and will be executed after all the iterations of for loop are over. Repeated execution of a set of statements is called iteration. The loop variable contains the highest value of the list after for loop is over. Value of for loop variable cannot be defined beforehand. Let's see an example for loop. Now, look at the Python code. Python program to demonstrate for loop. The for loop is used to traverse over each character, ch, in the string hello and gets printed on separate line. Once the for loop iterations gets over, the else part gets executed, which outputs the message coming out of the loop to the console. Finally, the program exits. We shall now discuss about the range function. The range function in Python is a built-in function that generates a sequence of integers, typically used in for loops. The syntax is range of start, stop, step. Can you repeat? Range of start, stop, step. Here, start is an optional parameter. An integer number specifying at which position to start. Default value is 0. Stop is a required parameter. An integer number specifying at which position to stop. Stop value is not included. Step is an optional parameter, an integer number specifying the incrementation. Default value is 1. Here, you have to note that range function is often used in for loops. The arguments of range function must be integers. The step parameter can be positive or negative other than 0. Here, we are going to learn about Python range of stop. That is, when the user call range with only one argument. Now look at example 1. Range of 5 generates a sequence of integers from 0 to 4. Let's see how it works. Remember the syntax of range. Range of start, stop, step. In this range, only one argument 5 is given. Here, start and step value are optional parameters, only stop value is the required parameter. So, if only one argument is given, definitely it is the stop value. In this example, the stop value is 5. Here, start value is default value 0. And step value is default value 1. So range 5 generates a sequence of integers from 0 to 4 that is 0, 1, 2, 3, 4. In this case, range 5 generates the numbers 0, 1, 2, 3, and 4. It is often used in loops to iterate a specific number of times. You can see in this Python code how range is used in for loops. Always remember, when the user call range with one argument, the user will get a series of numbers that starts at 0 and includes every whole number up to, but not including, the number that the user has provided as the stop. Here, we are going to learn about Python range of start and stop. That is, when the user call range with two arguments. When the user call range with two arguments, the user gets to decide not only where the series of numbers stops but also where it starts, so the user don't have to start at 0 all the time. Users can use range to generate a series of numbers from x to y using range of x, y. In this example, range 0, 5 generates a sequence of integers from 0 to 4. Let's see how it works. Remember the syntax of range function. Range of start, stop, step. Here, the start value is given 0. Stop value is 5. 5 is not included as we have to stop in it. And step value is not given and hence we take the step value as default value 1. Finally, range of 0, 5 generates a sequence of integers from 0, 1, 2, 3, 4. Here, we can see an example using Python range of start, stop, that is, when the user call range with two arguments. Example 3, write a Python program to print the natural number from 2 to 15 using range function. Here, in range of 2, 15, the start value is 2, stop value is 15. So in 15, we have to stop and 15 is not included. Step value is not given and hence step value is default value 1. In this Python code, the for loop is used to iterate over the values in the range from 2 to 14. The loop variable I takes on the values from 2 up to 14, not including 15, as it stops at 15. Range 2, 15 creates a sequence of numbers starting from 2 and ending at 14. The second argument is exclusive, so it stops at 14. During each iteration of the loop, the current value of I is printed using the print function. The end equals blank space parameter of the print function specifies that a space should be printed after each number instead of the default new line character. This causes the numbers to be printed on the same line, separated by spaces. After the loop finishes executing, the program ends. When you run this program, it will output the numbers from 2 to 14, inclusive, on a single line, separated by spaces, as 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here, we are going to learn about Python range of start, stop, and step. That is, when the user call range with three arguments. When the user call range with three arguments, the user can choose not only where the series of numbers will start and stop, but also how big the difference will be between one number and the next. If the user doesn't provide a step, then range will automatically behave as if the step value is default value 1. In this example, range of 0, 10, 2, the start value is 0. Stop value is 10. So, 10 is not included. Step value is 2. So as the step value is positive we have a forward jump. Here, we jump 2 steps forward each time, starting from 0 and ending till 8. Here 10 is not included, as it is stop value. So range of 0, 10, 2 generates the values 0, 2, 4, 6, 8. Here, we are going to learn about Python range of start, stop, and step. That is, when the user call range with three arguments. When the user call range with three arguments, the user can choose not only where the series of numbers will start and stop, but also how big the difference will be between one number and the next. If the user doesn't provide a step, then range will automatically behave as if the step value is default value 1. In this example, range of 0, -9, -1, the start value is 0. Stop value is -9. So, -9 is not included. Now, the step value is -1. So as the step value is negative, we have a backward jump. Here, we jump one step backward each time, starting from 0 and ending till -8. As the stop values, -9 is not included. So range of 0, -9, -1 generates the values 0, -1, -2, -3, -4, -5, -6, -7, -8. Key points of start value in range function. If start value is not given, the default value is 0. Key points of step value in range function. If step value is positive, move in forward direction. If step value is negative, move in backward direction. If step value is not given, the default value is 1. Key points of stop value in range function. Stop value will not be included. Let's see another example. Write a Python program to generate the table of a number using for loop. Here you have to note that the range of 1, 11 used in this program will generate values as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I is loop control variable and will be assigned each generated value, for which the body of for loop will be executed. Now look at the Python code. This code prints the table of a given number. Here's how it works. The code prompts the user to enter a number using the input function and converts the input into an integer using int function. The entered number is stored in the variable num. The for loop iterates over the range of values from 1 to 10 exclusive, using range 1, 11. In each iteration, the loop body executes, which includes a print statement to display the multiplication table. The print statement prints the value of num, the iteration variable I, the multiplication symbol x, and the result of multiplying num by I. After executing the code inside the loop body, the loop moves to the next iteration. This process continues until the loop completes all iterations. For example, if the user enters the number 5, the output will be. The code prints the multiplication table of the entered number 5 from 1 to 10. Now let's learn about the next conditional statement, while. While statement is used to execute a code block repeatedly as long as a certain condition is true. Look at the picture. If test expression is true, the body of the loop is executed. Again, the control condition of the loop is tested and the loop continues as long as the condition remains true. When the test outcome of this condition becomes false, the loop is not entered again and the control is transferred to the statement immediately following the body of the loop. The 4 elements of a while loop in Python are initialization expressions. It initializes the loop control variable and it is given outside the while loop before the beginning of the loop. Next one is the test expression. If its truth value is true, then the loop body gets executed, otherwise not. Next one is the body of the loop. It is the set of statements that are executed repeatedly in loop. Last one is the update expression. It updates the value of loop control variable and it is given inside the while loop. The syntax of the while loop is initialization. While test expression : body of while loop. Code block to execute while the condition is true. Update expressions. In while loop else statement is optional. Here, initialization. It initializes the loop control variable and it is given outside the while loop before the beginning of the loop, while is a reserved word. Test underscore expression is the condition to be checked for true or false value. Body of while consists of single or multiple statements. Update expressions, it updates the value of loop control variable and it is given inside the while loop. In this example, we are using while loop to output the values from 1 to 5. Here, in step 1, you have to initialize the loop control variable named count equal to 1 and it is given outside the while loop before the beginning of the loop. In step 2, while loop is used to check the condition if count is less than equal to number 5. If it is true, step 3, that is body of the loop, executes. That is, it prints the value. Finally, in step 4, the update expression updates the value of loop control variable count equal to count plus 1 and it is given inside the while loop. Thus the output is displayed as 1, 2, 3, 4, 5. Here is an example of using a while loop in Python to calculate the factorial of a number. The factorial function says to multiply all whole numbers from our chosen number down to 1. The factorial of any number is that number times the factorial of that number minus 1. Now look at the Python code. The user is prompted to enter a number using the input function, and the value is stored in the variable num as an integer. The variable factorial is initialized to 1. This variable will store the calculated factorial. The while loop is used to calculate the factorial. As long as the value of num is greater than 0, the loop will continue executing. Inside the loop, the current value of num is multiplied with the factorial variable, and the result is stored back in the factorial variable. This is equivalent to factorial equals factorial asterisk num. After multiplying, the value of num is decremented by 1 using num equal to num minus 1. The loop continues until num becomes 0. Finally, outside the loop, the program prints the calculated factorial value using the print function. So, when you run this program and enter a number 5, it will calculate the factorial of number 5 and displays the result as 120. Key points of while loop. The loop control variable must be updated inside the loop to avoid endless, infinite loop. In Python, the body of the while loop is determined through indentation, leaving 4 spaces. Body starts with indentation and the first unindented line marks the end of the loop. Python interprets any non-zero value as true. None and 0 are interpreted as false. At least one statement must be present in the body of the loop. Else is executed when test condition evaluates to false and is optional. Conditional looping constructs, part 3. In this video, we are going to discuss about the infinite loop, nested loops, jump statements, break statement, continue statement, pass statement, and practical implementation. So let's dive in and get started. Now we will discuss about the using of else statement with for and while loops. You should know that Python supports an else statement to be associated with a loop statement. For loop. If the else statement is used with a for loop, the else statement is executed where the loop has exhausted iterating the list. Next is while loop. If the else statement is used with a while loop, the else statement is executed when the condition becomes false. Let's discuss about the infinite loop. An infinite loop in Python is a loop that continues to execute indefinitely because its condition never becomes false or because there is no condition at all. This can cause your program to crash or become unresponsive, so it's important to avoid creating infinite loops. Let's see an example. The statement, while true: print, this loop will never end. This loop will continue to print this loop will never end, forever, because the condition true is always true. You can look at the Python code on the right side, where the print statement continues to print, this loop will never end, forever. The infinite loop can be terminated manually by pressing Ctrl+C from the keyboard to provide an external interruption for the program, a direct way to terminate the whole loop which would go on forever. Now, look at the Python code. The remaining output lines after Ctrl+C have been eliminated by a returning command as keyboard interrupt. How can we stop the infinite loop with the Python code? To stop the infinite loop, you can use the break statement. While true: print, this loop will never end, break. Now, look at the Python code. In this modified version of the loop, the break statement is executed after the first iteration, which terminates the loop and prevents it from executing indefinitely. Now, look at another example of an infinite loop. This infinite loop is using a while loop with a condition that never becomes false. I equals 0, while I less than 5, print I. In this example, I is initialized to 0 and the loop condition is I less than 5. However, the value of I never changes within the loop, so the condition is always true and the loop will execute indefinitely. To fix this, you can modify the loop to change the value of I. Now the Python code is modified as I equals 0, while I less than 5, print I plus equals 1. In this modified version of the loop, I is incremented by 1 in each iteration, eventually causing the condition I less than 5 to become false and the loop to terminate. We are going to discuss about the nested loops. Now look at the syntax for a nested for loop. Nested loops in Python refer to a situation where one loop is present inside another loop. So, the inner loop is present inside the outer loop. The inner loop is executed a fixed number of times for every single iteration of the outer loop. Look at the indentation of the outer loop. Nested loops are used when you need to perform a task repeatedly, and that task requires you to perform another task multiple times. In a nested for loop, we can place for loop inside another for loop. Consider an example. For I in range of 3. For j in range of 4. Print I and j. This Python code demonstrates the use of nested loops and the print function. Let's break it down step by step. Now look at step 1 below. Step 1. We have to find the range of 3. Range of start, stop, step. Start value equals default value 0. Stop value equals 3, 3 is not included. Step value equals default value 1. So, range of 3 equals 0. 1, 2. Now look at step 2. Step 2. We have to find the range of 4. Range of start, stop, step. Start value equals default value 0. Stop value equals 4, 4 is not included. Step value equals default value 1. So, range of 4 equals 0. 1, 2, 3. Now look at the Python code. The outer loop for I in range of 3 iterates over the values from 0, 1, 2. This means that the loop body will execute 3 times, with I taking the values 0, 1, and 2. The inner loop for j in range of 4 iterates over the values from 0, 1, 2, 3. For each iteration of the outer loop, the inner loop will execute 4 times, with j taking the values 0, 1, 2, and 3. Now, look at the right side. Let's see how it works. When outer loop I equals 0, the inner loop executes j equals 0, 1, 2, 3. Next, when outer loop I equals 1, the inner loop executes j equals 0, 1, 2, 3. Next, when outer loop I equals 2, the inner loop executes j equals 0, 1, 2, 3. Now see how print statement works. Now, look at the Python print statement. The print function is called within the nested loops. It displays a formatted string that contains the current values of I and j. The f before the string indicates an f string, which allows you to embed expressions inside curly braces to be evaluated and formatted within the string. Now, look at the output, how it's displayed, and also check how the print statement can be written. Let's see another example. Write a Python code to create a number pattern using nested for loops. I have written the Python code on the left side in blue color with line 1, line 2, line 3, line 4. You have to follow with those lines along with me with the working part. Come on, let's see how it works. In line 1, for I in range of 1, 4 is the outer loop. Here range of 1, 4 equals 1, 2, 3. Now let's look at the first iteration. In line 1, the outer loop I equals 1. In line 2, the inner loop j equals range of 1, I plus 1 equals range of 1, 1 plus 1 equals range of 1, 2. So the range of 1, 2 is 1. Here start value is 1 and stop value 2 is not included. In line 3, it prints the value of j equals 1, followed by a space. In line 4, then a new line is printed. After the inner loop completes, the print statement without any arguments is executed, which prints a new line character. This moves the cursor to the next line. So the output will be 1. Now look at the second iteration. In line 1, the outer loop I equals 2. In line 2, the inner loop j equals range of 1, I plus 1 equals range of 1, 2 plus 1 equals range of 1, 3 equals 1, 2. In line 3, it prints the value of j equals 1, 2, followed by a space. In line 4. Then a new line is printed. So the output here will be 1 on first line, then 1, 2 on the second line. Now let's see the third iteration. In the third iteration, in line 1, the outer loop I equals 3. In line 2, the inner loop j equals range of 1, I plus 1 equals range of 1, 3 plus 1 equals range of 1, 4 equals 1, 2, 3. In line 3, it prints the value of j equals 1, 2, 3, followed by a space. In line 4, then a new line is printed. The final output would be 1 on first line, 1, 2 on second line and 1, 2, 3 on third line. Now, pause the video and work out on your own. This is the Python code to create a number pattern using nested for loops, which we worked out just now. Check the output displayed. Now we will discuss about the nested while loop. In a nested while loop, a while loop is defined inside another while loop. Now look at the syntax. The outer while loop starts with a condition expression. This expression is evaluated before entering the loop. If the expression evaluates to true, the loop is executed. If the expression is false, the loop is skipped, and the program continues to the next statement after the loop. Inside the outer while loop, there is an inner while loop. This inner loop also has a condition expression that is evaluated before each iteration. If the expression evaluates to true, the inner loop statements are executed. If the expression is false, the inner loop is skipped, and the program continues to the statements after the inner loop. Within the inner loop, there is a block of statements that is executed as long as the inner loop's condition expression remains true. After the inner loop finishes executing, that is, the condition expression becomes false, the program proceeds to the statements following the inner loop. Finally, the program executes statement 2 after both loops have completed their iterations. The nature of statement 2 depends on the context of your code. Let's see an example for nested while loop. Now look at the Python code. The variable I is initialized with a value of 0. The outer while loop while I less than 3 is executed as long as the condition I less than 3 is true. This means the loop will run 3 times since I starts at 0 in increments by 1 in each iteration. Inside the outer loop, the variable j is initialized with a value of 0. The inner while loop while j less than 4 is executed as long as the condition j less than 4 is true. This means the inner loop will run 4 times since j starts at 0 in increments by 1 in each iteration. Inside the inner loop, the print statement is executed. It uses f-string formatting to print the values of I and j. The output will be in the format I colon the value of I, j colon the value of j, where I and j are replaced with the current values of I and j respectively. After printing the current values of I and j, the inner loop continues until j becomes greater than or equal to 4, at which point the inner loop is exited. The variable j is incremented by 1 using the statement j plus equals 1. The inner loop starts again, and the process repeats until j becomes greater than or equal to 4, at which point the inner loop is exited. After the inner loop finishes, the outer loop proceeds to the next iteration. The variable I is incremented by 1 using the statement I plus equals 1. The outer loop continues to run until I becomes greater than or equal to 3, at which point the loop is exited. Finally, after both loops have completed, the program continues to the statements following the loops. Overall, this code generates the following output as shown on the console. Let's recall the key points of the nested loops. Nested loop is one loop inside another loop. Once the condition of outer loop is true, the control is transferred to the inner loop. First the inner loop is terminated and then the outer loop terminates. The inner loop must have a different name for its loop counter variable so that it will not conflict with the outer loop. Now, let's discuss about the jump statements. In Python, a jump statement is a keyword that allows you to control the flow of your program's execution by jumping to a specific line of code or section of your program. As the name suggests, a jump statement is used to break the normal flow of the program and jump onto a specific line of code in the program if the specific condition is true. In simple words, it transfers the execution control of the program to another statement if a specific condition associated becomes true. There are 3 types of jump statements in Python: break statement, continue statement, and pass statement. Let's discuss about the break statement. The break statement is used to terminate a loop, for loop, while loop, prematurely, that means the loop is terminated or exited before it naturally reaches its end. When a break statement is encountered inside a loop, the loop is immediately terminated, and the program control moves to the next statement after the loop. As the name suggests, a break statement is used to break or stop a flow control. This is generally used in a loop. A break statement is used in a loop in such a way that when a particular condition becomes true, the break statement is executed and we come out of the loop immediately at that moment. Let's see the syntax. Syntax is break. Now let's learn about the break statement in for loop. The for loop iterates over the sequence, executing the code inside the loop body for each element. The break statement provides a way to prematurely exit the loop if a certain condition is met. Let's see an example. For I in range of 1,6 if I equal to 4, break. Print I. Let's see how it works. Range of 1,6 gives the values 1, 2, 3, 4, 5. In the first iteration, variable I is assigned the value 1. The if statement is evaluated, but since the condition I equal to 4 is false, the break statement is not executed. The print I statement is executed, resulting in the output 1. In the second iteration, variable I is assigned the value 2. The if statement is evaluated, but since the condition I equal to 4 is false, the break statement is not executed. The print I statement is executed, resulting in the output 2. In the third iteration, variable I is assigned the value 3. The if statement is evaluated, but since the condition I equal to 4 is false, the break statement is not executed. The print I statement is executed, resulting in the output 3. In the fourth iteration, variable I is assigned the value 4. The if statement is evaluated, but since the condition I equal to 4 is true, the break statement is executed. And the loop is terminated. So, the output of the code will be 1, 2, 3. Let's see another example of break statement inside for loop. Now look at the Python code. The loop iterates over each character in the string computer, and in each iteration, the current character is assigned to the variable val. The if val equal to character p condition checks if the current character, val, is equal to p. If the condition is satisfied, that is, the val is equal to p, the break statement is executed. This immediately terminates the loop, and the program continues with the code after the loop. If the condition is not satisfied, that is, val is not equal to p, the print val statement is executed, which prints the current character, val. Once the loop completes or is terminated by the break statement, the code continues executing. In this case, the line print over is executed, which simply prints the string over. Now, let's go through the loop step by step. The first character is C. Since it is not equal to p, it is printed. The second character is O. It is also printed. The third character is M. It is printed as well. The fourth character is P. The condition val equal to P is satisfied, so the break statement is executed, and the loop is terminated. After terminating the loop, over is printed. So, the output of the code will be COM over. Let's discuss about the break in while loop. Now look at the syntax. While loop continues executing its codes as long as the test expression remains true, but it can be prematurely terminated using the break statement when a specific condition is met. Let's see an example. Here's an example that demonstrates the use of the break statement in a while loop. Now look at the Python code and how it works. First iteration. Initially, count is 0, and the while loop is entered. While count less than 5, count is equal to 0. So, 0 less than 5 it is true, so it goes to the next line. Next line prints count is 0. In the next line, count is increment by 1. So count equals 0 plus 1, that is count equals 1. The next line checks the condition if count equal to 3. So count is now 1. So check if 1 is equal to 3. It's false. So the next line break is not executed and the while loop continues. Now second iteration starts. While count less than 5, count is equal to 1. So, is 1 less than 5? It is true, so it goes to the next line. Next line prints count as 1. In the next line, count is increment by 1. So count equals 1 plus 1, that is count equals 2. The next line checks the condition if count equal to 3. So count is now 2. So check if 2 is equal to 3. It's false. So the next line break is not executed and the while loop continues. Now third iteration starts. While count less than 5, count is equal to 2. So, is 2 less than 5? It is true, so it goes to the next line. Next line prints count as 2. In the next line, count is increment by 1. So count equals 2 plus 1, that is count equals 3. The next line checks the condition if count equal to 3. So count is now 3. So check if 3 is equal to 3. It's true. Now the next line break is executed, terminating the loop. Then finally, the line print, loop is complete, is then executed, which prints the message loop is complete. The output of the code will be, count 0, count 1, count 2, loop is complete. Here in this Python code, you have to note that the loop runs 3 times, when count is 0, 1, and 2, before being terminated by the break statement. Now let's discuss about the continue statement in Python. The continue statement is used to skip the current iteration of a loop and move to the next iteration. When a continue statement is encountered inside a loop, the current iteration is skipped, and the loop immediately jumps to the next iteration. Syntax is continue. Now, we will discuss about the continue statement in for loop. Look at the syntax. A sequence is iterated over, and certain actions are taken based on a condition using the if statement. The continue statement is used to skip the remaining code in the current iteration if the condition is met. Let's see an example and how it works. Range of 1, 6 generates values 1, 2, 3, 4, 5. In the first iteration, variable I is assigned the value 1. The if statement is evaluated, but since the condition I equal to 3 is false, the continue statement is not executed. The print I statement is executed, resulting in the output 1. In the second iteration, variable I is assigned the value 2. The if statement is evaluated, and again, the condition I equal to 3 is false, so the continue statement is not executed. The print I statement is executed, resulting in the output 2. In the third iteration, variable I is assigned the value 3. The if statement is evaluated, and this time, the condition I equal to 3 is true. The continue statement is encountered, causing the current iteration to end immediately. The print I statement is skipped. The loop proceeds to the next iteration. In the fourth iteration, variable I is assigned the value 4. The if statement is evaluated, and as before, the condition I equal to 3 is false, so the continue statement is not executed. The print I statement is executed, resulting in the output 4. In the fifth iteration, variable I is assigned the value 5. The if statement is evaluated, and once again, the condition I equal to 3 is false, so the continue statement is not executed. The print I statement is executed, resulting in the output 5. After the loop finishes iterating over all the values in the range, there are no more iterations to process. Therefore, the loop terminates. So the output displayed are 1, 2, 4, 5. Now let's discuss about the continue statement in while loop in Python. Now, look at the syntax. The while loop repeatedly executes the code inside it as long as the test underscore expression is true. The if statement with the continue statement provides a way to skip the remaining code inside the loop based on a certain condition. Let's see an example and how it works. First iteration. The count variable is initialized to 0. The while loop is entered, and the test underscore expression, count less than 5, is evaluated. Since the initial value of count is 0, the condition is true, and the loop begins. Inside the loop, count is increment by 1, count plus equals 1. Count equals 0 plus 1, that is 1. The if statement checks if count is equal to 3. Count equals 1. 1 equal to 3 is false. So the print statement is executed, displaying the current value of count equal to 1. Second iteration. While count less than 5. Count equals 1. So 1 less than 5 is true. It goes to the next line to increment count by 1. So count becomes 2. The if statement checks if count is equal to 3. Count equals 2. Now, 2 equal to 3 is false. So the print statement is executed, displaying the current value of count equal to 2. Third iteration. While count less than 5. Count equals 2. So 2 less than 5 is true. It goes to the next line to increment count by 1. So count becomes 3. The if statement checks if count is equal to 3. Count equals 3. Now, 3 equal to 3 is true. The continue statement is executed, which jumps back to the start of the while loop without executing the subsequent code. In this case, when count is 3, the print statement is skipped. Fourth iteration. While count less than 5. Count equals 3. So 3 less than 5 is true. It goes to the next line to increment count by 1. So count becomes 4. The if statement checks if count is equal to 4. Count equals 4. Now, 4 equal to 3 is false. So the print statement is executed, displaying the current value of count equal to 4. Fifth iteration. While count less than 5. Count equals 4. So 4 less than 5 is true. It goes to the next line to increment count by 1. So count becomes 5. The if statement checks if count is equal to 5. Count equals 5. Now, 5 equal to 3 is false. So the print statement is executed, displaying the current value of count equal to 5. Now the test expression in the while loop count less than 5 becomes false and hence the loop is exited. After the loop, the code outside the loop is executed and loop finished is printed. When you run this code, the output will be current count 1, current count 2, current count 4, current count 5. Loop finished. As you can see, when count is equal to 3, the continue statement is triggered, and the code inside the if block is skipped for that iteration. In Python, the pass statement is a null statement, which means it does nothing when executed. It is used as a placeholder or a do-nothing statement in situations where a statement is required syntactically, but no action is needed or desired. The syntax is pass. Let's see an example. In a for loop, you might use pass to indicate that there is no code to be executed in the loop body, for I in range of 10. Pass. This code creates a loop that iterates 10 times, from 0 to 9. Each iteration assigns the current value to the variable I. However, the loop does nothing else because the pass statement is used as a placeholder for future code. The pass statement means do nothing and it is useful when you want to create a loop or a function but you don't have any code to execute yet. No output gets displayed. Now let's look at another example. Character filtering. In this example, we have taken a string banana and a pass statement every time a is encountered. Therefore, in output the a is omitted. Now look at the Python code for each line-by-line explanation. The code starts with a for loop that iterates over each character in the string banana. In each iteration, the current character is assigned to the variable I. Inside the for loop, there is an if statement that checks if the current character I is equal to a. If the condition I is equal to a is true, the pass statement is executed. Pass is a placeholder statement that does nothing and allows the code to continue to the next iteration without taking any action. If the condition I equal to a is false, which means the current character is not equal to a, the code executes the indented block of code below the else statement. In this case, the indented block of code simply contains a print statement that outputs the current character I. The loop continues to the next iteration until all characters in the string have been processed. So the output will be BNN. Let's recall the key points of jump statement. Break statement. The break statement terminates the loop containing it. If break statement is inside a nested loop, loop inside another loop, break will terminate the innermost loop. Continue statement. The continue statement is used to skip the rest of the code inside a loop for current iteration only. Loop does not terminate but continues on with the next iteration. Pass statement. We use the pass statement to construct a body that does nothing. Strings in Python, Part 1. In this video, we are going to discuss about what are strings, creating strings, indexing in a string, traversing a string and practical implementation. So let's dive in and get started. Let's learn a new concept: strings in Python. In Python, strings are a sequence of characters enclosed in either single quotes or double quotes. This sequence of Unicode characters may include a letter, a number, special character, white space, or a backslash. Python treats single quotes the same as double quotes. Triple quotes are typically used for strings that span multiple times. Strings are used to represent textual data and are one of the fundamental data types in Python. Strings are immutable, which means once created, their contents cannot be changed. Strings are used widely in many different applications, such as storing and manipulating text data, representing names, addresses, and other types of data that can be represented as text. Let's see an example. Name equals Sally and bytes. In this example, we have a string with the name Sally and bytes and space in between, enclosed inside single quotes, thus representing a string value assigned to the variable name. Like other integer variables, strings are also declared in the same manner using the assignment operator, equal to. Let's learn how to create strings. Creating strings is as simple as assigning a value in a variable. For example, when the code is executed, the string hello world is assigned to the variable str. Afterwards, you can use the variable str to manipulate or access the stored string value in your program. For example, you could print the value of str using printf str to display hello world as output. Strings in Python can be created using single quotes, double quotes, triple quotes. Now, you can see some examples using single quotes, double quotes, and triple quotes in strings. Now, look at the first example of the Python code, strings using single quotes. The process of creating a string using single quotes and printing its value in Python. Now see line 1 of the first example. str1 equals, welcome to Sally N bytes. This line assigns the string welcome to Sally N bytes in single quotes to the variable str1. The string is enclosed in parentheses, which are not necessary in this case since a single pair of quotes is sufficient to represent a string. Now look at line 2 of example 1, print, creating a string with single quotes. This line uses the print function to display the message creating a string with single quote. The print function is used to output text or values to the console. Now look at the third line of example 1, print, str1. This line uses the print function again, but this time it prints the value stored in the variable str1. Since str1 contains the string welcome to Sally N bytes, that string will be displayed as the output. You can check it on the console. Now, look at example 2, it creates a string using double quotes. You can see how double quotes are used in strings and printed on the console. Remember, Python treats single quotes the same as the double quotes. Text can be enclosed within single or double quotes, both represent a string. Now, look at example 3, creating a string using triple quotes. Triple quotes are used to represent multiline strings and docstrings. You can see how triple quotes are used in multiline strings and printed on the console. Let's learn about empty strings. In Python, an empty string is represented by two quotation marks with nothing between them, like this, open quotes and close quotes with no characters inside it. It is a string literal with a length of 0, meaning it contains no characters. Here are a few examples of working with empty strings in Python. In example 1, an empty string is assigned to the variable empty underscore string using a pair of double quotation marks. The len function is then used to determine the length of the string, which, in this case, is 0. The length of a string refers to the number of characters it contains. So the output is 0. In example 2, the equal to comparison operator is used to check if the empty underscore string variable is equal to another empty string. Since both strings are empty and have a length of 0, the comparison evaluates to true. This is because both strings contain no characters, so they are considered equivalent. So the output will be true. Let's see how to use \character in string. Let's see an example. Example 1. In this code, a string is assigned to the variable a. The string is enclosed in double quotation marks and contains the text "This is Sam's car." The backslash before the single apostrophe is an escape character that allows the apostrophe to be included within the string without prematurely terminating it. This escape sequence \character tells Python to treat the following single quote as part of the string rather than as a delimiter. When the print function is called with the variable a as the argument, it outputs the string "This is Sam's car." The output appears exactly as it was defined in the code, with the single apostrophe properly included within the printed string. Now come down to the next. Using single quotes as the enclosing quotes. Example 2. In this code, a string is assigned to the variable b. The string is enclosed in double quotation marks and contains the text "Write an article on AI briefly." The single quotes around the word AI are regular single quotation marks, not the backtick character or apostrophe used in the previous example. When the print function is called with the variable b as the argument, it outputs the string "Write an article on AI briefly." The output appears exactly as it was defined in the code, with the single quotes around AI properly included within the printed string. If the string contains double quotes, we can use single quotes to represent the string and vice versa so that we don't have to escape the quotes. Example 1. In this code, a string is assigned to the variable c. The string is enclosed in single quotation marks and contains the text "Write an article on AI briefly." The double quotes around AI are regular double quotation marks, not backticks or single quotes. When the print function is called with the variable c as the argument, it outputs the string "Write an article on AI briefly." The output appears exactly as it was defined in the code, with the double quotes around AI properly included within the printed string. Now come down to the next. If there are both single and double quotes in the string, we need to escape the quotes, otherwise it results in a syntactical error. Example 2. The code initially contains a syntax error because the string is enclosed in double quotation marks and it includes double quotation marks within the string without escaping them. To resolve the issue, you can either use single quotation marks to enclose the string or escape the internal double quotation marks. Now, see the correct code. In this updated code, the string is assigned to the variable d and is enclosed in single quotation marks to avoid conflict with the internal double quotation marks. The apostrophe within the string is escaped using a backslash to ensure it is interpreted as part of the string rather than as a delimiter. When the print function is called with the variable d as the argument, it outputs the string "she said, I'll call you." The output appears exactly as it was defined in the code, with the internal double quotation marks properly included within the printed string. If the statement is very long, then it can be shifted to multiple lines with the line continuation character backslash, but it shows the result in the same line. Example 1. In this code, we assign a string value to the variable a. The string starts with "here is a line" and continues on the next line with a backslash at the end. This backslash acts as the line continuation character, indicating that the string continues on the next line. The following line, split in 2 lines, is then considered part of the same string. However, note that when you print the variable a, the backslash and the line break are not displayed. It appears as if the string is written on a single line. Python treats the backslash as an escape character in string literals. In this case, it is escaping the line break character, \n, and the resulting string is displayed as if it were written on a single line. Now come down to the next. If you wish to display the output in the next line, then the use of escape sequence \n becomes mandatory. Example 2. In this code, the variable message is assigned a string value. The string contains 3 parts separated by the \n escape sequence, which creates new lines. When you run this code, it will output "hello" in the first line. "Welcome to the world of Python programming" in the second line. "Keep learning and have fun" in the third line. The \n escape sequence is used to indicate the start of a new line in the string. So, when the string is printed, the text after each \n is displayed on the new line. We can also use the escape sequence \t to provide horizontal space in the output. Here is an example. In this code, the \t escape sequence is used to add a horizontal tab between the labels, example, name, age, city, and their corresponding values, example, Emily, 10, London. When you run this code, it will output in this format given below the code. Let's discuss about accessing characters in a string known as indexing. In Python, you can access individual characters in a string using indexing. Each character in a string is assigned an index, starting from 0 for the first character and increasing by 1 for each subsequent character. Now look at the picture. Each character in a string is located in different slots like lockers holding an index value starting from 0 for the first character and increasing by 1 for each subsequent character from left to right. Even space in between text holds an index value. Look at example 1, line 1 contains, message equals hello world. Now see the picture of the character representation in a string. Each character in a string is assigned an index, starting from 0 for the first character, h, and increasing by 1 for each subsequent character. It must be an integer. We cannot use float or other data types for index, as this will result in type error. Now come to line 2 of the Python code. In this code, the variable message contains the string hello world. To access specific characters, we use square brackets after the variable name, providing the index of the character we want to access. I have highlighted the square brackets in red color. In the print statement, message index of 0 accesses the character at index 0, which is the letter h. So the output is h. Now look at line 3 of the Python code. The print statement, message index of 7, accesses the character at index 7, which is the letter o. Now look at line 4. The print statement, message index of 12, accesses the character at index 12. Index 12 is out of range. Trying to access a character out of index range will raise an index error. String index out of range. You check the output here. Now, look at this picture. In string indexing, we can start index value either from the left or from the right. Left or positive index starts from 0 and ends with L-1, where L is the length of the string. Right or negative index starts from -1 to the length of the string. Here, you have to note that L is the length of a string. Length is the number of characters in a string. In this picture, the length of the string, that is the number of characters in the string, is 12. Remember, positive index starts from left, index 0 towards right, known as forward indexing. Negative index starts from right, index -1 towards left, known as backward indexing. Now look at line 5 of the Python code. The print statement, message index of -4, accesses the character at index -4. Now look at the picture. Since it's a negative value, -1 starts from right side from the last character, decrementing by 1 towards the left for each subsequent character. So, -1 starts from exclamatory mark. Index value of r is -4. So the output is r. Now look at line 6 of the Python code. The print statement, message index of -11, accesses the character at index -11. Now look at the picture. Since it's a negative value, -1 starts from right side from the last character, decrementing by 1 towards the left for each subsequent character. So, -1 starts from exclamatory mark. Index value of e is -11. So the output is e. Now, look at example 1. In Python, the type function is used to determine the data type of a given object or value. In this code, the variable message is assigned the string value hello world. When type of message is called, it returns the data type of the object referenced by message. In this case, it returns class str, indicating that the object is of type str, which stands for string. So, the output class str indicates that the variable message is a string object in Python. Now look at example 2. In Python, strings are immutable, which means that you cannot change individual characters within a string directly. Therefore, the code will result in a syntax error. Also, expression cannot contain an assignment operator. Example 3. In Python, the double equals operator is used for equality comparison. It checks whether the value on the left side is equal to the value on the right side and returns a Boolean value of true or false accordingly. In this code, message of 1 accesses the character at index 1 of the string message, which is e. Then, message of 1 equal to e compares this character with the string e. Since the character at index 1 is indeed e, the comparison evaluates to true. Therefore, the output is true. Now look at example 4. In Python, the id function is used to retrieve the unique identifier of an object. It returns a number that represents the memory address of the object. In this code, the variable message is initially assigned the string value hello world. When printf id of message is called, it retrieves and prints the memory address of the hello world string object. However, when you reassign the message variable with a new string value learning strings in Python, a new string object is created with a different memory address. So, the output of the code will be two different memory addresses, representing the two different string objects as shown in the output console. Now let's discuss about traversing a string. Traversing a string means accessing each character one after the other by iterating, repeating, through the elements of a string using either for or while loop. At first, we will learn about iterating through the elements of a string using for loop. Here, each character of the string can be accessed sequentially using for loop. This is done using the indexes and iterating over it results in displaying the elements of a string, one character at a time. Let's look at an example, traversing through string using a for loop. Now, look at the Python code. The variable my_string is assigned the value hello world. It is a string that contains the text hello world. The for loop is used to traverse or iterate over the characters in the string my_string. In each iteration of the loop, the variable char takes on the index value of each character in the string, one at a time. You can see on the left side picture how forward indexing is done. For index value 0, character h is printed within the loop. Next, for index value 1, e is printed and so on till index value 12 exclamation point is printed, that is, until the character of the string ends. Each character of the string is printed on a separate line. As a result, when you run this code, it will print each character of the string hello world on a new line, giving the output as shown on the console. The loop iterates over the string from the first character, h, to the last character, exclamation point, and the print statement is executed for each character, causing it to be displayed on the console. Now, let's see iterating through the elements of a string using while loop. While loop can also be used for string traversal. Each element of the string is accessed one by one and while loop iterates till the end of the inputted string, which can be determined using standard library functions, len function. Let's see an example. Now look at the Python code. In this code, the variable my_string is assigned the value hello world, representing a string containing the text hello world. The variable index is initialized to 0. This variable will be used as an index to access each character of the string. The while loop is employed to iterate over the string until the condition index less than len of my_string becomes false. In this Python code, the length of the string hello world is 13. So, the while loop is employed to iterate over the string until the condition index less than 13 becomes false. The condition checks whether the index is still within the bounds of the string length. Inside the loop, the print my_string of index statement is executed. It prints the character at the current index position of my_string to the console. After printing the character, the index variable is incremented by 1 using index plus equals 1. This ensures that the next iteration of the loop accesses the next character in the string. The loop continues until the index reaches the length of the string, 13. Since the indexing of the string starts from 0, the index will take values from 0 to len of my_string, 13 minus 1, that is 12, so 0 to 12, allowing each character to be printed. As a result, when you run this code, it will output each character of the string hello, world, on a new line, similar to the previous example using a for loop. The while loop accomplishes the same task of iterating through the string and printing each character until the end of the string is reached. Now, we are going to write a Python program to count the number of occurrences of a character in an inputted string. Implementing string traversal. In this program, we directly prompt the user to input a string and a character using the input function and store them in the variables input_string and character, respectively. We then initialize a count variable to keep track of the number of occurrences, starting from 0. Next, we traverse the input_string using a for loop. For each character, C, in the string, we compare it with the target character. If they are equal, we increment the count by 1. After counting the occurrences, we print the result using print number of occurrences, count. Now look at the console. When you run the program, it will ask you to enter a string and a character. Here, we have entered a string. Learning Python is fun. Now, we enter character n to count. After you provide the input, it will count the number of occurrences of character n in the string and display the result 4 on the console. Let's see another example. Write a Python program to input a string from the user and print it in the reverse order without creating a new string. Now, look at the Python code. In this program, the user is prompted to input a string using the input function, and the input is stored in the input_string variable. To print the string in reverse order, we use a for loop with the range function. The loop starts from the last index of the string and stop value at -len of input_string -1, and iterates in reverse order, decrementing the index by 1 in each iteration, -1 as the step value. Now, pause the video and check the range values of start, stop and step values, which I have clearly explained below the program. Now, inside the loop, input_string of index of I accesses the character at the current index, I, and prints it. The end equals blank space argument is used to prevent printing a new line after each character. After the loop completes, we use print without any argument to print a new line, ensuring that subsequent output appears on a new line. When you run the program, it will ask you to enter a string. Here, we have entered hello world. Once you provide the input, it will print the string in reverse order on the same line. So the output will be DLROW blank space OLLEH. Strings in Python, Part 2. In this video, we are going to discuss about string operators, concatenating strings, replicating strings, membership operators, comparison operators, string slicing. Strings are immutable and practical implementation. So let's dive in and get started. We have already learnt about strings in the previous video. Strings are arrays of bytes representing Unicode characters. However, Python does not have a character data type. A single character is simply a string with the length of 1. Square brackets can be used to access the elements of the string. Now, in this video, we are going to discuss about the string operators. In Python, string operators allow you to perform various operations on strings. While Python doesn't have any special string operators specifically dedicated to strings, it provides a set of operators and methods that can be used to manipulate and concatenate strings. Here are some commonly used string operators and methods in Python: concatenation, replication, membership operators, comparison operators, and slicing. Let's see one by one in detail. Now, let's discuss about concatenating strings. We know that we can add 2 integer numbers. But, we can also add 2 strings in Python. Concatenation refers to creating a new string by adding 2 strings. To concatenate means to join. The plus operator joins or concatenates strings written on both sides of the operator and creates a new string. Now, look at example 1. This code will concatenate the strings str1 and str2 using the plus operator and store the result in the result variable. When you run this code, it will output hello world because the plus operator concatenates the 2 strings together, resulting in a new string that combines the contents of str1 and str2. In this output, both are joined together without any space. Now look at example 2. In this Python code, str1 equals hello. This line assigns the string hello to the variable str1. str2 equals world. This line assigns the string world to the variable str2. Result equals str1 plus space character plus str2. This line concatenates the strings stored in str1 and str2, with a space character in between them. The plus operator is used for string concatenation. The resulting string hello world is assigned to the variable result. Print result. This line outputs the value of result, which is hello world, to the console. So, when you run this code, the output will be hello world with a space between both strings. Look at example 3. You cannot add a string and an integer objects. To use plus operator, data types should be the same. Now, look at this Python code. str1 equals 6. This line assigns the integer value 6 to the variable str1. str2 equals computer. This line assigns the string computer to the variable str2. Result equals str1 plus str2. This line attempts to concatenate str1 and str2. However, since str1 is an integer and str2 is a string, Python will raise a type error because concatenation between different data types is not allowed. Print result. Since the error occurs in the previous line, this line will not be executed. You can use concatenation operator plus with numbers and strings separately for performing addition and concatenation operation, respectively. Now, look at example 4. Number 2 plus number 4 equals 6. This is addition. String 2 plus string 4 equals string 24. This is concatenation. Remember, the expression string 2 plus number 4 shall generate an type error, as we cannot add a string and an integer. Let's learn about string concatenation using join method. The join method is a useful way to concatenate multiple strings together. It takes an iterable, such as a list or tuple, of strings and concatenates them using a specified separator. Here's an example of using the join method for string concatenation. Now, look at the code. In this code, we have a list strings containing 3 strings, hello, world, and exclamation point. Remember, lists are enclosed in square brackets. In the second line, we specify the separator as a space character. In the third line, the join method is then called on the separator, using strings as the iterable. The output will be hello space world space exclamatory point. The join method concatenates the strings and strings using the specified separator, resulting in a single string where each element is separated by the specified separator. Note that the join method is called on the separator and not on the strings themselves. This is a common source of confusion. In Python, you can replicate a string by using the multiplication operator, asterisk. This allows you to create a new string by repeating the original string a certain number of times. Here's an example of using string replication. Now, look at the Python code. In this code, original underscore string is the string hello. By multiplying it by the number 3, original underscore string times 3, we create a new string that repeats the original string 3 times. The output will be hello hello hello. The asterisk operator repeats the string original underscore string 3 times, resulting in a new string where the original string is replicated consecutively. You can adjust the number after the asterisk operator to control the number of repetitions. For example, original underscore string asterisk 5 would repeat the string 5 times. Now, look at example 2. In this Python code, the original underscore string is set to the string 5. By multiplying it by 3, original underscore string times 3, we create a new string that repeats the original string 3 times. The asterisk operator repeats the string 5, 3 times, resulting in a new string where the original string is replicated consecutively. In this case, the string 5 is repeated 3 times, resulting in the string 555. Always check if the strings are enclosed in quotation marks. Multiplying the strings 6 and 9 together directly using the asterisk operator will raise a type error in Python. The asterisk operator in this context is used for replicating a string by a numeric value, integer, not for multiplying strings together. You can check the output displayed on the console as type error, can't multiply sequence by non-int of type str. In Python, membership operators are used to check if a particular character exists in the given string or not. The two membership operators in Python are in operator and not in operator. Let's see in detail one by one. Let's discuss about the in operator. The in operator returns true if a character or substring exists in the given string and otherwise it returns false. The syntax is substring in string. To use membership operator in strings, it is required that both the operands used should be of string type. Let's see some examples. Look at example 1. The in operator is used to test whether a value exists within a sequence. In this case, the sequence is the string hello, and the value being tested is the character h. In this case, since the character h is present in hello, the expression evaluates to true. Therefore, when you run the code, it will output true. Look at example 2. The Python code print y in hello checks whether the character y is present in the string hello and then prints the result. In this case, the sequence is the string hello, and the value being tested is the character y. In this case, the character y is not present in hello, so the expression evaluates to false. When you run the code, it will output false. Look at example 3, Python code print he in hello checks whether the substring he is present in the string hello and then prints the result. In this case, the substring he is not present in hello, so the expression evaluates to false. When you run the code, it will output false. Here Python is being case sensitive, checking uppercase and lowercase also. Look at example 4. This Python code checks whether the string variable str1 is present as a substring within the string variable str2. In this case, str1 is butter and str2 is bread and butter. The in operator is used to test whether str1 exists within str2. In this case, since butter is indeed a substring of bread and butter, the expression evaluates to true. Therefore, when you run the code, it will output true. Look at example 5. This Python code checks whether the string variable str1 is present as a substring within the string variable str2. In this case, str1 is jam and str2 is bread and butter. The in operator is used to test whether str1 exists within str2. In this case, since jam is not a substring of bread and butter, the expression evaluates to false. Therefore, when you run the code, it will output false. You can check the outputs on the console. Let's discuss about the not in operator. The not in operator returns true if a character or substring does not exist in the given string, and otherwise it returns false. The syntax is substring not in string. To use membership operator in strings, it is required that both the operands used should be of string type. Let's see some examples. Look at example 1. The expression y not in hello evaluates to true because the character y is indeed not present in the string hello. The print function is then used to display the resulting value, which is true, on the console or output screen. Look at example 2. In this code, the expression h not in hello evaluates to false because the character h is present in the string hello. Therefore, false is displayed when the code is executed with the print function. Look at example 3. In this code, the expression bread not in bread and butter evaluates to false because the substring bread is indeed present in the string bread and butter. Therefore, false is displayed when the code is executed with the print function. Look at example 4. In this code, the expression jam not in bread and butter evaluates to true because the substring jam is not present in the string bread and butter. Therefore, true is displayed when the code is executed with the print function. You can check the outputs displayed on the console. Let's discuss about the comparison operators. Python provides several comparison operators to compare values and determine their relationship. Some commonly used comparison operators in Python are equal to. Checks if the values on both sides are equal. Not equal to. Checks if the values on both sides are not equal. Greater than. Checks if the value on the left side is greater than the value on the right side. Less than. Checks if the value on the left side is less than the value on the right side. Greater than or equal to. Checks if the value on the left side is greater than or equal to the value on the right side. Less than or equal to. Checks if the value on the left side is less than or equal to the value on the right side. Python compares strings using ASCII, or Unicode value of the characters. Unicode values are also called ordinal values. Python starts by comparing the first element from each sequence, character by character comparison. If they are equal, it goes on to the next element, and so on, until it finds elements that differ. Subsequent elements are not considered, even if they are big. Let's see an example. Example 1. In this code, the strings being compared are Mary and Mac. When comparing strings lexicographically, each character's ASCII, or Unicode value is compared from left to right until a difference is found. The first two characters from str1 and str2, M and M, are compared. As they are equal, the second two characters, A and A, are compared. Since they are also equal, the third characters, R and C, are compared. Because R has greater ASCII, or Unicode value than C, str1 is greater than str2. Thus the output displays false on the console. In these Python examples, Python compares using values, called ordinal values. The most common characters and their ordinal values are given in this tabular column. Now, look at the tabular column. Character 0 has the ordinal value 48, character 1 has the ordinal value 49 up to character 9 has the ordinal value 57. Next line, character uppercase A has the ordinal value 65, character uppercase B has the ordinal value of 66 up to character Z has the ordinal value 90. Next line, character lowercase a has the ordinal value 97, character lowercase b has the ordinal value 98 up to character lowercase z has the ordinal value 122. Using these ASCII values, that is, ordinal values, let's try these examples. Now, look at example 1. The Python code print Tim equal to Ty compares two strings, Tim and Ty, to check if they are equal. The double equal to operator is used to compare the two strings for equality. The first two characters T and T are compared. As they are equal, the second two characters I and I are compared. Since they are also equal, the third two characters M and E are compared. Because the ASCII values of M and E are not equal, the output displayed is false. You can check the ASCII values of M and E on the right side in the tabular column. Now, look at example 2. The Python code print free not equal to freedom compares two strings, free and freedom, to check if they are not equal. The entire expression free not equal to freedom evaluates to true because the strings are not equal. Now, look at example 3. The Python code we have to check if arrow is greater than Aaron. The first two characters, A and A, are compared. As they are equal, the second two characters R and R are compared. Since they are also equal, the third two characters R and O are compared. Because the ASCII values of R is greater than ASCII values of O, the output displayed is true. You can check the ASCII values of R and O on the right side in the tabular column. Now, look at example 4. The Python code checks if right is greater than left. The first two characters R and L are compared. Because the ASCII values of R is greater than ASCII values of L, the output displayed is true. The character R in right comes after the character L in left. So, output displayed is true. You can check the ASCII values of R and L on the right side in the tabular column. Now, look at example 5. The Python code checks teeth is less than T. The first two characters T and T are compared. As they are equal, the second two characters E and E are compared. As they are also equal, the third two characters E and E are compared. They are also equal. Hence, it checks for the fourth two characters but string T doesn't have any more characters to check. Hence, the output is false as the result, indicating that the string teeth is not less than the string T. Now, look at example 6. The Python code checks yellow less than equal to fellow. The first two characters Y and F is compared. As the ASCII values of Y is greater than F, the output displayed is false, as the result, indicating that the string yellow is not less than or equal to the string fellow. You can check the ASCII values of Y and F on the right side in the tabular column. Now, look at example 7. The Python code checks ABC is greater than single space character. Here, you have to remember that any non-empty string comes after an empty string, in this case, a space character is the empty string. So, when you run this code, it will output true as the result, indicating that the string ABC is greater than the string single space character. Based on their ASCII values, you can check the ASCII values of A and space character on the right side in the tabular column. In Python, string slicing refers to the technique of extracting a portion or a substring from a string by specifying the starting and ending indices. So what is a slice of a string? A slice of a string is a substring. This extracted substring is termed as slice. Chunk of characters can be extracted from a string using slice operator with two indices in square brackets separated by colon. The basic syntax for string slicing in Python is string name open square brackets, start colon, stop colon, step, close square brackets. Here stop is excluded. Here's what each part of the slicing syntax means. String underscore name. The original string from which you want to extract a substring. Next is start. The index representing the start position of the substring, inclusive. Next is stop. The index representing the end position of the substring, exclusive. Next is step. It is optional. The step or increment value for selecting characters. It determines how many characters to skip while slicing. If step value is positive, move in forward direction. If step value is negative, move in backward direction. Let's see an example. Look at example 1. A string variable named string is defined with the value hello, world. The code substring 1 equals string of 7 : extracts a substring from the original string hello, world. Now look at the picture. The index value of the string hello world is marked, starting from 0 and ending till the end of the string, that is index value 12 for exclamatory point. Now let's see how string of 7 : works. Now, look at the bottom for the syntax of string slicing. Remember the syntax of string slicing. String underscore name of start : stop : step. Here, start value is 7. Stop value is not given, so we have to take the default value till end of the string. Here end of the string is index value 12 and holds the character exclamatory point. Step value is also not given, so we have to take the default value as 1. As the step value is positive 1, we have to move in forward direction, that is forward indexing. So finally, we get the output as WORLD exclamatory point, starting from 7th position, till the end of the string. Let's see another example. Look at example 2. In this Python code, a string variable named string is defined with the value hello, world. The next line of code creates a new variable named substring2 and assigns it a value obtained by slicing the string variable. Slicing is a way to extract a portion of a string based on its indices. In this case, the indices used are 0:4, which means the substring will start from index 0 and go up to, but not including, index 4. Look at the syntax of string slicing at the bottom. Syntax is string underscore name of start: stop: step. Here, in string of 0:4, the start value is 0, the stop value is 4. We have to stop at 4. So 4 is not included. So, stop value is 3. Step value is not given, but the default value is 1. As the step value is positive 1, we have to move in forward direction, that is forward indexing. So finally, we get the output as HELL, starting from 0 and ending in 3rd position. You can check the output on the console. Let's see an example. Look at example 3. In this Python code, a string variable named string is defined with the value hello, world. The next line of code creates a new variable named substring3 and assigns it a value obtained by slicing the string variable. The slicing expression used here is string of : 2. Now look at the syntax of string slicing at the bottom. The syntax is string underscore name of start: stop: step. In string of : 2, the start value is the default value 0. The stop value is not given. So default value till end of the string. Here, step value equals 2. As the step value is positive, we jump 2 steps forward each time, starting from 0 until the end of the string, which means every second character of the original string will be included in the resulting substring. Therefore, the output will be HLO space character, OL exclamatory point. You can check the output on the console. Note that when you omit the start index, it defaults to 0, and when you omit the end index, it considers all characters till the end of the string. Let's see another example. Look at example 4. In this Python code, a string variable named string is defined with the value hello, world. The next line of code creates a new variable named reversed underscore string and assigns it a value obtained by slicing the string variable. The slicing expression used here is : -1. When using the : -1 notation in a slicing expression, it indicates a step value of -1, which means the string will be reversed. The slicing starts from the end of the string and goes backwards, including every character. Now look at the syntax of string slicing at the bottom. The syntax is string underscore name of start: stop: step. In string of : -1, the start value is not given, so default value is -1, as step value is negative. So it starts from the end of the string. That is, it starts from exclamatory point. Stop value is not given. This means that the slicing operation will continue until the beginning of the string. So until index -13, which holds the character H. Step value is -1. As step value is negative, jump 1 step in backward direction. Therefore, the output will be exclamatory point DLROW space character, OLLEH. This is because the slicing operation reverses the original string and includes all the characters in reverse order. Let's see another example. Look at example 5. Write a Python program to input name and print the pattern as given below using string slicing. If name Python, output should be P, PY, PYT, PYTH, PYTHO, PYTHON pattern. Now, look at the screen to see 4 boxes here. Now come on, look at box number 1. This is the Python code. In line 1, it prompts the user to enter a name and store it in the variable name using the input function. In line 2, it uses a for loop to iterate over a range from 0 to the length of the name, inclusive, using the loop variable I. Inside the loop, extract a substring from the name using the slicing operation name of 0:I, which includes characters from index 0 up to, but not including, index I. In line 3, it prints the extracted substring using the print function. The loop iterates, incrementing I by 1 in each iteration, resulting in a growing substring length. The loop terminates when I reaches the length of the name, ensuring the final iteration prints the entire name as the last substring. Let's see in a detailed manner so that you can understand well. Now look at box number 2. The syntax of range function is range of start, stop, step. In this Python code, range of 0, len of name plus 1, the start value is 0. Stop value is len of name plus 1, that is, len of Python plus 1 is equal to 6 plus 1 is equal to 7. 7 is not included. So, stop value is 6. Step value equals 1. Now look at box number 3. The syntax of string slicing is string underscore name of start colon stop colon step. In this Python code, name of 0 I, the start value is 0, stop value is I value is 7. 7 not included. So, 6. Step value is the default value 1. Now look at box number 4. Iteration of the for loop for the name Python. User input, Python iteration 1, I is 0. Slicing operation. Name of 0 I implies name of 0 0, it is an empty slice. Output is an empty line. Iteration 2. I is 1. Slicing operation. Name of 0 I implies name of 0 1, this includes the first character. So, output is P. Iteration 3. I is 2. Slicing operation. Name of 0 I implies name of 0 2. This includes the first two characters. Output is PY. Iteration 4. I is 3. Slicing operation. Name of 0 I implies name of 0 3. This includes the first three characters. Output is PYT. Iteration 5. I is 4. Slicing operation. Name of 0 I implies name of 0 4. This includes the first four characters. Output is PYTH. Iteration 6. I is 5. Slicing operation. Name of 0 I implies name 0 5, includes the first 5 characters. Output is PYTHO. Iteration 7. I is 6. Slicing operation. Name of 0 I implies name of 0 6. This includes the entire name. Output is PYTHON. The loop iterates a total of 7 times, each time increasing the value of I by 1. With each iteration, a substring of the name is extracted using string slicing and printed on a separate line. The substring grows in length from the first character to the entire name, resulting in the desired pattern. Let's see how it is practically implemented. Now look at the output. User enters the name as Python. In the first iteration, an empty line is implemented. In the second iteration, it includes the first character, P. In the third iteration, it includes the first two characters, PY. In the fourth iteration, it includes the first three characters, PYT. In the fifth iteration, it includes the first four characters, PYTH. In the sixth iteration, it includes the first 5 characters, PYTHO. In the seventh iteration, it includes the entire name, PYTHON. In Python, strings are immutable, which means that once a string is created, it cannot be changed or modified. Immutable objects cannot be altered after they are created. When you perform operations on a string, such as concatenation or slicing, it doesn't modify the original string but instead creates a new string with the desired changes or subset of characters. Now, let's look at a simple example showing strings are immutable, that is, once created, it cannot be changed or modified. Now look at the Python code. Line 1 assigns the string Jim to the variable name _1. The variable name _1 now holds the value Jim. Name _1 of 0 equals T. This line attempts to modify the first character of name _1 by assigning the value T to name _1 of 0. However, this will raise a type error because strings in Python are immutable, which means you cannot directly modify individual characters in a string. In the line, print of name _1, since the previous line raised a type error, this line will not be executed. If we run this code with the attempted modification name _1 of 0 equals T, we would encounter a type error indicating that strings are immutable and cannot be modified in this manner. Strings in Python, Part 3. In this video, we are going to discuss about string methods and built-in functions and practical implementation. So let's dive in and get started. Let's discuss about string methods and built-in functions. Python provides a wide range of built-in functions and methods that are specifically designed to work with strings. These functions and methods allow you to perform various operations on strings, such as manipulating their content, searching for specific patterns, extracting substrings, and more. Built-in functions or string manipulation functions are predefined in Python programming language and are readily available for use. Syntax is string.object.functionName. Let's understand all the string methods and built-in functions one by one. Let's learn about the built-in function, len function. This method returns the length of the string. The length of the string means the number of characters the string holds. The syntax is len. Let's look at example 1. In this code, the len function is used to determine the length of the string, Salian bytes, which contains 14 characters, including spaces. The length of the string is then printed to the console using the print function. Always remember, the length of the string starts or counted from natural number 1 and also includes spaces or other special symbols in the count. Now, look at example 2. In this code, the len function is used to determine the length of the string. This is Sam's car, which contains 18 characters. The string includes spaces, letters, punctuation marks. Here, you have to note that / character with the single quotes are counted as one character. The length of the string is then printed to the console using the print function. Let's see the third example. This code print of len of true will raise a type error because the len function cannot be directly applied to a Boolean value like true. The len function is typically used to determine the length of iterable objects, such as strings, lists, tuples, or dictionaries. Since true is not an iterable object, trying to apply len directly to it will result in a type error. A sequence is a container with ordered items. Lists, tuples, and strings are 3 of the basic built-in sequences in Python. You can find the length of a sequence by calling len function. In example 4, len function is used in lists. The lists, Tuesday, Thursday and Friday are enclosed in square brackets. So, output of len of working _ days is 3. In example 5, len function is used in tuples. Tuples, 3.30 and -0.1 are enclosed in parentheses. Output of len of values is 2. Example 6. Another built-in data type that you'll use often is the dictionary. In a dictionary, each item consists of a key-value pair. When you use a dictionary as an argument for len, the function returns the number of items in the dictionary. In example 6, len function is used in dictionaries. Output of len of age is 3. Dictionary are enclosed in curly braces. The function len always returns an integer as it's counting the number of items in the object that you pass to it. The function returns 0 if the argument is an empty sequence. Let's see some examples. In examples 7, 8, 9 and 10, you can find the length of an empty dictionary, empty string, an empty list, and an empty tuple. The function returns 0 in each case. In example 11, this range of numbers includes the integers from 1 to 19 with increments of 2. The length of a range object can be determined from the start, stop, and step values. Let's learn about the built-in function, capitalize function. This method returns the exact copy of the string with the first letter in uppercase. Syntax is str.capitalize. Here str is the string. Str denotes the string that is needed to be capitalized. Note that Python capitalize function does not contain any parameters. Let's see an example. In example 1, the capitalize method in Python converts the first character of a string to uppercase and leaves the rest of the characters unchanged. In this case, G is converted to uppercase G, and the rest of the string remains the same. You can check the output on the console. Now look at example 2. One important thing to note is that if the string has its first character as capital letter, in this case, the function will return the original string only. So, in string good morning, the first letter is already capitalized. So the output returns the original string only. You can check the output on the console. Next built-in function is the split function. This method breaks up a string at the specified separator and returns a list of substrings. Syntax is str.split of separator, max split. The split method takes a maximum of 2 parameters. One of the parameter is the separator and the other parameter is the max split. Here, the separator parameter is optional. The separator is a delimiter. The string splits at the specified separator. If the separator is not specified, any white space, that is space, new line, string is a separator. The next parameter max split is also optional. The max split defines the maximum number of splits. The default value of max split is -1, which means no limit on the number of splits. Let's see example 1. String split, with parameters provided. Look at the Python code. The code str2 equals str1.split of exclamatory mark splits the string str1 into a list of substrings based on the exclamation mark. Each substring is separated wherever the exclamation mark is encountered. The split method in Python is used to split a string into a list of substrings based on a specified delimiter. In this case, the exclamation mark is used as the delimiter. The resulting list str2 contains 2 elements, welcome and to our Salian bytes tutorial, which are the substrings obtained after splitting the original string at the exclamation mark. So you can see, the output displayed on the console as two substrings, welcome is one substring and to our Sally and Bytes tutorial is another substring. Let's see another example. String split with no parameters provided. Now, look at the Python code. The code str2 equals str1.split of space character splits the string str1 into a list of substrings based on the space character. Each substring is separated wherever a space is encountered. The split method in Python is used to split a string into a list of substrings based on a specified delimiter. In this case, the space character is used as the delimiter. The resulting list str2 contains 6 elements, welcome to our Sally and Bytes and tutorial, which are the substrings obtained after splitting the original string at the spaces. Python string replace is an built-in function. This function replaces all the occurrences of the old string with the new string. It is used to replace a specified phrase or string with another phrase or string and returns the result after replacement. This method does not modify the original string. This method basically returns a copy of a string where all occurrences of its substring are replaced by some other substring. It replaces the old substring with the new substring and returns the copy of the string. One thing to remember is that it does not modify the original string. This method comes under the category of class str. There are 3 parameters of replace function. Old value. It is a mandatory attribute used to specify the substring that is needed to be searched. New value. It is a mandatory attribute that is used to specify the value we need to replace. Count. It is an optional parameter and is a number that is used to specify how many occurrences of the old value you want to replace. Let's see example 1. In this code, the replace method is called on the string str. It takes 2 arguments. The substring to be replaced, beginners, and the replacement substring, intermediate. The replace method scans the string and replaces all occurrences of the first argument with the second argument. In this case, it replaces the substring beginners with intermediate. So the output prints the modified string as Python learning for intermediate. Let's see example 2. Python string replace function using count parameter. When we use count parameter, then it is used to specify how many occurrences of the old value you want to replace. In this code, the replace method is called on the string str. It takes 3 arguments, the substring to be replaced, beginners, the replacement substring, intermediate, and the maximum number of replacements to perform, 2 in this case. The replace method scans the string and replaces the first 2 occurrences of the first argument with the second argument. The third argument limits the number of replacements to 2. Finally, the modified string, replace string, is printed, which shows the original string with the first 2 occurrences of beginners replaced with intermediate. You can check the output on the console. Python string find is an inbuilt function. This function is used to search the first occurrence of the substring in the given string. If you are finding a substring that exists inside a string, then this function returns the index of the first occurrence of the string. If the substring does not exist in a string, then the function returns -1. The syntax is str.find of sub, start, end. Here, sub is the substring which needs to be searched in the given string. Start is starting position where substring is to be checked within the string. End is the end position, which is the index of the last value for specified range. Let's see an example. Example 1. In this code, the find method is called on the string word. It takes 1 argument, which is the substring you want to search for, global in this case. In this example, since the substring global is found at the beginning of the string, the find method returns the index 0. Example 2. In this code, the find method is called on the string word. It takes 1 argument, which is the substring you want to search for, global in this case. In this example, since the lowercase substring global is not found within the string global warming, the find method returns -1, indicating that the substring is not present in the string. Example 3. This code searches for the first occurrence of the character L starting from index 4 in the string global warming using the find method. The find method is called on the string word. It takes 2 arguments. The substring or character you want to search for, L in this case, and the starting index from which the search should begin, for in this case. Now, look at the picture. Starting from index 4, the first occurrence of the character L is found at index 5. Hence, the find method returns the index 5. Example 4. This code is using the find method to search for the substring AR in the string global warming, starting from index 4. In this case, the substring AR is found starting from index 8 in the word global warming. Therefore, the value of result is 8. Example 5. This code is using the find method to search for the character M in the substring of the string global warming that is between the indices 11 and 13, exclusive. In this case, the substring between indices 11 and 13 exclusive, the character m is not present in this substring, so the find method returns -1. Python's string index method is used to return the index of a substring if it is found inside a string. In case if the substring is not there inside the string, then this method raises an exception. This method basically returns the index of the first occurrence of the value we are searching in a string. In the case of non-existence of substring inside a string, value error exception is raised. The syntax is str.index of substring, start, end. Here, substring is a required parameter and is used to specify the value which is to be searched. Start is an optional parameter and is used to specify where the search starts. Its default value is 0. End is an optional parameter used to specify where to end the search. The default value is to the end of the string. Let's see an example. Example 1. The index method in Python is used to find the index of a substring within a given string. It takes two optional arguments that specify the start and end indices for the search. In this case, the index method is called on the string str1 and is passed the arguments n, 3, and 12. This means that it will search for the first occurrence of the letter n within the substring of str1 starting at index 3 and ending at index 12, exclusive. The output indicates that the first occurrence of the letter n within the specified substring range is at index 4. Let's see another example. Example 2. This is an example of value not existing inside the string. In this code, the index method is called on the string str1 and is passed the argument z, indicating that we want to find the index of the letter z within the string. However, since the letter z is not present in the string str1, a value error will be raised. This error occurs because the index method cannot find the specified substring within the string. When you run the given code, the output will be value error, substring not found. Now it's time to see the difference between find function and index function. Both these methods are same, but there is a major difference in case if the substring does not exist in the string. If we use the Python find method, then it will return -1. On the other hand, if we are using the Python index, then it will raise value error exception. Python string is appla returns true if a given string consists of alphabets only. String is alpha is an inbuilt method for string handling. It returns true only if all characters of a string are alphabets, both uppercase and lowercase, only. One thing to note is white space is not considered as an alphabet, thus if there is a white space in string, then this method returns false for that string. The syntax is str.isAlpha. You have to note that, from the syntax it is clear that this method does not take any parameters. If any parameter will be passed, then it will raise an error. Now, look at example 1. The variable, string1, holds the string, welcome to Sally and bytes, without any spaces. The isalpha method in Python is used to check if a string consists only of alphabetic characters. In this case, the string1 contains alphabetic characters, so the isalpha method will return true. You can check the output on the console. Now, look at example 2. The variable, string2, holds the string, welcome to Sally and bytes, with spaces. The isalpha method in Python is used to check if a string consists only of alphabetic characters. In this case, the string2 contains spaces, which are non-alphabetic characters. Therefore, the isalpha method will return false. You can check the output on the console. Now, look at example 3. The variable, string3, holds the string, welcome to Sally and bytes, with special characters and spaces. The isalpha method in Python is used to check if a string consists only of alphabetic characters. In this case, the string3 contains special characters, dots and exclamation marks, as well as spaces, which are non-alphabetic characters. Therefore, the isalpha method will return false. You can check the output on the console. The isalpha method returns true if all the characters are alphanumeric, that is, alphabet letters uppercase A to Z, lowercase a to Z, and numbers 0 to 9. No special characters are allowed. This method also doesn't take any parameters. The syntax is str.isAlnum. Let's see some examples. Example 1. The variable my_string1 holds the string Sally and bytes 123 without spaces. The isAlnum method in Python is used to check if a string consists only of alphanumeric characters. In this case, the string my_string1 contains both alphabetic characters and numbers, so the isAlnum method will return true. You can check the output on the console. Now, look at example 2. The variable, my_string2 holds the string Sally and bytes at 123 with special characters and spaces. The isAlnum method in Python is used to check if a string consists only of alphanumeric characters. In this case, the string my_string2 contains spaces, as well as a special character, @, which are non-alphanumeric characters. Therefore, the is_alma method will return false. You can check the output on the console. The isDigit function returns true if the string contains only digits, otherwise false. The syntax is str.isDigit. Let's see some examples. Example 1. The variable str1 holds the string 1, 2, 3, 4, 5. The isDigit method in Python is used to check if a string consists only of digits. In this case, the string str1 contains only digits, so the isDigit method will return true. You can check the output on the console. Example 2. The variable str2 holds the string A123 space B456. The isDigit method in Python is used to check if a string consists only of digits. In this case, the string str2 contains letters A and B, as well as spaces, which are non-digit characters. Therefore, the isDigit method will return false. You can check the output on the console. The title function returns the string with the first letter of every word in the string in uppercase and rest in lowercase. This method mainly returns a copy of string whose first letter is in uppercase and rest all letters are in lowercase, then the whole string is known as title cased string. The syntax is str.title. Let's see some examples. In example 1. The variable str holds the string. This is the best place to learn coding. The title method in Python is used to convert a string into title case, where the first character of each word is capitalized and the rest of the characters are in lowercase. In this case, the string str is converted to title case using the title method. So the output will be. Now look at the output 1 on the console. The title method capitalizes the first character of each word in the string, while the remaining characters are converted to lowercase. Let's see example 2. In this case, the string str1, 34, cross street is converted to title case using the title method. Now look at output 2 on the console. In this case, the number 34 foot is not affected by the title method, and only the first character C in cross and S in street are capitalized. Let's see example 3. In this case, the string str2, Sally and bytes is converted to title case using the title method. Now look at output 3 on the console. The output shows the string str2 in title case, where S and B are capitalized, and the rest of the characters are in lowercase. The count method searches the specified substring in the string and returns the number of occurrences of that substring in the given string. This method mainly returns an integer that specifies the count of the occurrence of a substring in a string. The syntax is str.count of substring, start, end. Here, substring is a mandatory parameter used to specify the string whose count is to be found. Start is an optional parameter used to specify the starting index of the string from where our search starts. If we do not give start index, then searching starts from index 0. End is an optional parameter used to specify the ending index of the string where the search ends. If we do not give the end index, the searching ends at the length of the string. Let's see some examples. Example 1. The count method in Python returns the number of occurrences of a substring within a given string. In this case, we are counting the number of occurrences of the substring every in the string str1, which is we will work hard every day, every week and every year until the job is done. The substring every appears 3 times in the string. So the output is 3. In example 2. In this case, we are searching for the substring every within the string str2, but only considering the portion of the string from index 23 to index 35, the substring every appears once. Therefore, the count method returns 1 as the output. String lower method is used to return a copy of a specified string where all case-based characters turned into lowercase. The main aim of this function is to convert the string into lowercase. The syntax is str.lower. Let's see some examples. The lower method in Python converts all uppercase characters in a string to lowercase. In the first example, the string workhard is converted to workhard with all lowercase letters. In the second example, the string workhard is already in lowercase, so it remains unchanged. In the third example, the string workhard is converted to workhard with all lowercase letters. You can check the output on the console. In is lower method. If all case-based characters, letters, of a string are in lowercase, then this method returns true, otherwise returns false. The syntax is str.isLower. Let's see some examples. The isLower method in Python is used to check if all characters in a string are lowercase. In the first example, the string computer science consists of all lowercase characters, so str.isLower returns true. In the second example, the string computer science contains uppercase characters, so str.isLower returns false because not all characters are lowercase. String upper is used to return a copy of a specified string where all case-based characters are in uppercase. The main aim of this function is to convert the string into uppercase. The syntax is str.upper. Let's see some examples. The upper method in Python converts all lowercase characters in a string to uppercase. In the first example, the string learn Python is converted to learn Python with all uppercase letters. In the second example, the string learn Python is already in uppercase, so it remains unchanged. You can check the output on the console. In is upper method. If all case-based characters, letters, of a string are in uppercase, then this method returns true, otherwise returns false. The syntax is str.isUpper. Let's see some examples. The isUpper method in Python is used to check if all characters in a string are uppercase. In the first example, the string welcome consists of all uppercase characters, so str.isUpper returns true. In the second example, the string welcome contains lowercase characters, so str.isUpper returns false because not all characters are uppercase. Python string lstrip function returns the string after removing the spaces from left of the string. The syntax is str.lstrip or str.lstrip of characters. Here, chars is optional, a string specifying the set of characters to be removed from the left. All combinations of characters in the chars argument are removed from the left of the string until left character of the string mismatches. Let's see some examples. The lstrip method in Python is used to remove leading characters from a string. It removes any white space or specific characters specified in the argument from the left, beginning, of the string. In the first example, the string is global warming. The lstrip method removes the leading white space characters, resulting in the output global warming. In the second example, the string is global warming, and the argument passed to lstrip is glo. It removes the characters g, l, and o from the left of the string, resulting in the output ball warming. In the third example, the string is global warming, and the argument passed to lstrip is olg. In this case, it removes the characters o, l, and g from the left of the string. After removing these characters, the resulting string is ball warming, which is the output. You can check the output on the console. Python string strip function removes all the trailing white spaces from the right of the string. The syntax is str.rstrip or str.rstrip of characters. Here, chars is optional, a string specifying the set of characters to be removed from the right. All combinations of characters in the chars argument are removed from the right of the string until right character of the string mismatches. Let's see some example. The rstrip method in Python is used to remove trailing characters from a string. It removes any white space or specific characters specified in the argument from the right end of the string. In the first example, the string is global warming. The rstrip method removes the trailing white space characters, resulting in the output global warming. Let's see example 2. In this case, the string is computers, and the argument passed to rstrip function is rs. In this case, it removes the characters r and s from the right of the string. After removing these characters, the resulting string is compute, which is the output. You can check the output on the console. Python string strip function returns the string after removing the spaces both on the left and right of the string. The syntax is str.strip. Let's see an example. The strip method in Python is used to remove leading and trailing white space from a string. In this code, str1.strip will remove any leading and trailing spaces from the string str1, computer science with Python. You can see the output on the console. Let's see a Python program to accept a string and print the string after capitalizing every other letter in the string. Now, look at the code. This code prompts the user to enter a string, then it performs an alternative capitalization on the string. Line 1. This line prompts the user to enter a string and stores it in the variable str1. Line 2. Length equals len of str1. This line calculates the length of the string str1 and stores it in the variable length. Line 3. This line prints the original string entered by the user. Line 4. str2 equals space character. This line initializes an empty string str2. Line 5. 4, a, in range of 0, length, 2. This line starts a loop that iterates over the indices of str1 with a step size of 2. It means the loop will consider every other character in the string. Now, let's see. Inside the loop. Line 6, str2 plus equals str1 of a. This line adds the current character at index of from str1 to str2. Now, condition is checked in line 7. If a is less than length minus 1, then go to line 8. str2 plus equals str1 of a plus 1.upper. This line checks if the current index, a, is less than the length minus 1. If it is, it means there is a character available at index, a, plus 1. In that case, the character at index a plus 1 is capitalized using the upper method, and the capitalized character is added to str2. Line 9. This line prints the resulting string after the alternative capitalization. You can check the output on the console. Now, pause the video and work out on your own. Let's see a Python program that reads a line and prints its frequency chart like number of uppercase letters, number of lowercase letters, number of alphabets and number of digits. Let's see the Python code. Line 1. The input function is used to prompt the user to enter a line of text. The input is stored in the variable line. In line 2 and 3, for variables are initialized to keep track of the counts. Lower count and upper count for counting lowercase and uppercase letters, digicount for counting digits, and alpha count for counting alphabets. Line 4. The for loop iterates over each character in the line. Line 5. Inside the loop, the first if statement checks if the current character, a, is a lowercase letter using the isLower method. If it is, the lower count is incremented by 1. Line 7. The next elif statement checks if the current character, a, is an uppercase letter using the isUpper method. If it is, the upper count is incremented by 1. Line 9. The following elif statement checks if the current character, a, is a digit using the isDigit method. If it is, the digit count is incremented by 1. Line 11. The final if statement checks if the current character, a, is an alphabet either lowercase or uppercase using the isAlpha method. If it is, the alpha count is incremented by 1. After the loop completes, the code prints the counts using the print function. The variables upper count, lower count, alpha count, and digicount are used to display the respective counts. You can check the output on the console. Pause the video and work it by your own. Python string is space function returns true if the string contains only white space characters, otherwise returns false. The syntax is str.space. Let's see an example. Example 1. The isSpace method in Python is used to check if a string contains only white space characters. In this case, the string str1 contains only a single whitespace character, so str1.isSpace returns true. Example 2. In this case, the string str2 starts with whitespace characters but also contains the non-whitespace character c. Therefore, str2.isSpace returns false. You can check the output on the console. Python string isTitle function doesn't take any arguments. It returns true if the string is properly title-cased, else returns false if the string is not a title-cased string or an empty string. The syntax is str.isTitle. Let's see some examples. Example 1. In this case, the string we learn Python follows the title case format as each word starts with an uppercase letter. So output is true. Example 2. In this case, the string we learn Python does not follow the title case format as the second word learned starts with a lowercase letter. So the output is false. Example 3. In this case, the string Python does not follow the title case format as all characters are in uppercase. So output is false. Example 4. In this case, the string this is the hashtag symbol follows the title case format as each word starts with an uppercase letter and the other characters are lowercase. So the output is true. You can check the output on the console. Python string join function returns a string in which the string elements have been joined by a string separator. The syntax is str.join of sequence. In sequence, join function takes an argument which is of sequence data type, capable of returning its element one at a time. This method returns a string which is the concatenation of each element of the string and the string separator between each element of the string. Let's see some examples. Example 1. The join method is used to concatenate the elements of an iterable object, such as a string, with a specified separator. In example 1, str1 is a string containing the characters ABCD. The join method is called on the separator string s, which is asterisk, and the str1 string is passed as the argument. The method concatenates each character in str1 with the separator asterisk in between them, resulting in the output. You can check the output, how it is displayed. A asterisk B asterisk C asterisk D. Example 2. str2 is a tuple containing 3 elements, AI, data science, and computer graphics. The join method is called on the separator string s, which is vertical bar symbol, and the str2 tuple is passed as the argument. The method concatenates each element of the tuple with the separator vertical bar symbol in between them, resulting in the output. You can check the output, how it is displayed. AI, vertical bar, data science, vertical bar, computer graphics. Python string swapcase function converts and returns all uppercase characters into lowercase and vice versa of the given string. It does not take any argument. The syntax is str.swapcase. Let's see some examples. Example 1. The swapcase method is used to convert the uppercase characters in a string to lowercase and vice versa. In the first example, str1 is set to Python programming. The swapcase method is called on str1, resulting in the output string where the uppercase p is converted to lowercase p, and the lowercase letters are converted to uppercase and so on. You can check the output, how it is displayed. In the second example, str1 is set to Python. The swapcase method is called on str1, resulting in the output string where all the uppercase characters are converted to lowercase. Since str1 contains only uppercase letters, the output is lowercase letters, Python. You can check the output, how it is displayed. Python string partition, separator, function is used to split the given string using the specified separator and returns a tuple with 3 parts. Substring before the separator, separator itself, a substring after the separator. The syntax is str.partition of separator. Separator argument is required to separate a string. If the separator is not found, it returns the string itself followed by 2 empty strings within parentheses as tuple. Let's see some examples. Example 1. The partition method splits a string into 3 parts based on the first occurrence of a specified separator. In example 1, the separator is work. The method finds the first occurrence of work in str1 and splits the string into 3 parts, hard, work, and leads to success. These parts are returned as a tuple. Remember, tuples are enclosed in parentheses. Look at the output, how it is displayed. In example 2, the partition method is called with the separator, a. It finds the first occurrence of a in str2 and splits the string into 3 parts, I, a, and am a coding lover. These parts are returned as a tuple. Remember, tuples are enclosed in parentheses. Look at the output, how it is displayed. In example 3, the partition method is called with the empty separator, which is a space character. Since str2 does not contain any space characters, the method cannot find a separator. As a result, the entire string str2 is returned as the first element of the tuple, and the second and third elements are empty strings, which are displayed in the output. Python string ends with function returns true, if the given string ends with the specified substring else returns false. The syntax is str.ends with. Let's see some examples. Example 1. The ends with method is used to check if a string ends with a specified suffix. In example 1, str1 is set to data scientist, and the ends with method is called with the suffix scientist. Since str1 ends with the suffix scientist, the method returns true. Now look at example 2. In this example, the ends with method is called with the suffix data. Since str1 does not end with the suffix data, the method returns false. You can check the output displayed on the console. Python string starts with function returns true, if the given string starts with the specified substring, else returns false. The syntax is str.starts with. Let's see some examples. Example 1. The starts with method is used to check if a string starts with a specified prefix. In example 1, str1 is set to software engineer, and the starts with method is called with the prefix software. Since str1 starts with the prefix software, the method returns true. Example 2. In the second example, the starts with method is called with the prefix engineer. Since str1 does not start with the prefix engineer, the method returns false. You can check the output on the console. In internal storage or memory of the computer, the characters are stored in integer value. A specific value is used for a given character and it is based on ASCII code. Python provides 2 functions for character encoding: ORD function and CHR function. First, we will learn about the ORD function on the left side of this screen. In ORD function, it returns the ASCII or Unicode or ordinal of the character. Let's see some examples. In the first example, CH is set to uppercase, B, and the ORD function is called with CH as the argument. The output is 66, which is the Unicode code point for the character uppercase, B. In the second example, CH is set to lowercase, m, and the ORD function is called with CH as the argument. The output is 109, which is the Unicode code point for the character lowercase, m. In the third example, CH is set to 0, and the ORD function is called with CH as the argument. The output is 48, which is the Unicode code point for the character 0. In the fourth example, CH is set to 9, and the ORD function is called with CH as the argument. The output is 57, which is the Unicode code point for the character 9. You can check the output displayed below. Now, look at the right side of the screen. We will learn about CHR function. The CHR function is used to convert an integer representing a Unicode code point into the corresponding character. Let's see some examples. In the first example, ord is set to 66, which represents the Unicode code point for the character uppercase B. The chr function is called with ord as the argument, resulting in the output uppercase B. In the second example, ord is set to 109, which represents the Unicode code point for the character lowercase m. The chr function is called with ord as the argument, resulting in the output lowercase m. In the third example, ord is set to 48, which represents the Unicode code point for the character 0. The chr function is called with ord as the argument, resulting in the output 0. In fourth example, ord is set to 57, which represents the Unicode code point for the character 9. The chr function is called with ord as the argument, resulting in the output 9. You can check the output displayed below. Lists in Python, Part 1. In this video, we are going to discuss about introduction to lists, creating list, accessing list elements, indexing, traversing a list, aliasing, comparing lists, and practical implementation. So let's dive in and get started. Suppose you are planning to visit the nearby store to purchase your daily needs. What is the first thing you'd do? Yes, you'd probably write down a shopping list. Python also has a built-in data structure called list that's very similar to your shopping list. So let's go ahead and learn more about Python lists and see how they're analogous to our shopping list. A list is a collection of values or an ordered sequence of values or items. The items in a list can be of any type such as string, integers, float, objects, or even a list. The values that make up a list are called its elements. It's quite natural to write down items on a shopping list one below the other. For Python to recognize our list, we have to enclose all list items within square brackets, with the items separated by commas. Lists allow duplicate values as well. The element of the list can be accessed by its index. Did you notice that bread is the third item in the list, but is it indexed too? Well, this is because of zero indexing. In Python, index is essentially an offset from the beginning of the list. This is why the first element is at index 0, no offset, the second element is at index 1, and so on. In general, if the list has n elements, the last element is at index of n-1. Just the way that we can always modify our shopping list by reordering items, do things like replacing bread with our favorite chocolate, for example, we can do the same with Python lists. For this reason, lists are mutable. That is, values in the list can be modified, which means that Python will not create a new list when you make changes to an element of a list. Elements of the list need not be of the same type. List is a sequence data type like strings. We can learn one by one in detail. Let's see how to create a list. Lists can be created by putting comma-shaped values or items within square brackets. Square brackets indicate start and end of the list, consisting of elements separated by a comma. The syntax is list name equals square brackets. This construct is termed as a list display construct. Square brackets contain the set of values or elements constituting the list with a blank or no values, or we can say an empty list. The items in a list can be of any type such as string, integers, float, objects, or even a list. Let's see an example. Shopping_list equals open square brackets, apples, pens, bread, notepad, brushes, paint, close square brackets. In this example, we have a list of shopping list having 6 items, apples, pens, bread, notepad, brushes, and paint, separated by commas and enclosed in square brackets. Let's see some examples of creating different types of lists. Example 1. This line creates a list called list1 that contains integers. The numbers 10, 20, 30, 40, and 50 are elements of the list, printed and displayed on the console. Example 2. This line creates a list called list2 that contains strings. The letters A, E, I, O, and U are elements of the list, printed and displayed on the console. Example 3. This line creates a list called list3 that contains elements of different data types. The string Python, the integer 650, the float 27.4, the integer -680, the Boolean value true, and the Boolean value false are elements of the list, printed and displayed on the console. Example 4. This line creates an empty list called list4 with no elements. Since list4 is empty, it will display square brackets in the console. Example 5. This line creates a list called list5 that contains elements, including another list. The integers 2, 4, 6, and 8 are elements of list 5, and the list 3, 5 is nested inside list 5 as an element, printed and displayed on the console. You can check the output displayed on the console. Remember, lists are enclosed in square brackets, and hence the output here are all enclosed within square brackets. The list method in Python takes sequence types and converts a given record or tuple or string into list. We can create a list from an existing sequence using this built-in function list function. Let's see some example. Example 1. Creating a list from an existing sequence. List1 equals list function, creates an empty list using the built-in list function. The list function with no arguments creates an empty list. The empty list is assigned to the variable list1. Since list1 is empty, it will display empty square brackets in the console. You can check the output in the console. Example 2. Creating a list from a sequence, string. This code creates a list called list2 from a sequence, in this case, a string. The string animation is passed as an argument to the list function, which converts each character of the string into individual elements of the list. The resulting list is assigned to the variable list2. Finally, it prints the contents of list2. When executed, it will display animation in the console. Each character of the string becomes a separate element in the list. You can check the output in the console. Example 3. Creating a list through user input using list method. In this code, list of input of enter the values prompts the user to enter values and converts the input into a list. The input function is used to receive user input, which is then passed as an argument to the list function. The list function converts the input string into a list, where each character becomes an individual element. The resulting list is assigned to the variable list3. Then finally, it line prints the contents of list3. You can check the output in the console. Here, enter the values, we have entered hello world. So the output displayed is that each character of the string hello world becomes a separate element in the list along with spaces. Here, let's learn how to create a list from an existing list. You can create a new list from an already existing list. Let's see some examples. Example 1. This code creates a list called list1 with elements 10, 20, 30, 40, 50. The second line, list2 equals list1 of colon, creates a copy of list1 by using the slice operator colon. The slice operator with no start or end indices creates a new list that contains all the elements from the original list. The resulting list is assigned to the variable list2. Finally, the contents of list2. When executed, it will display 10, 20, 30, 40, 50 in the console. Since list2 is a copy of list1, it contains the same elements. Any modifications made to list2 will not affect list1, and vice versa. Example 2. This code creates a list called list1 with elements 10, 20, 30, 40, 50. In the second line, list2 equals list1 of 1 colon 4, creates a new list list2 by using the slice operator 1 colon 4 on list1. The slice operator selects a portion of the list from the index 1, inclusive, to the index 4, exclusive. It extracts elements at indices 1, 2, and 3 from list1 and creates a new list with those elements. The resulting list is assigned to the variable list2. Finally, it prints the contents of list2. When executed, it will display 20, 30, 40 in the console. The elements in list2 are the values that were selected by the slice operator from list1. Example 3. This code creates a list called list1 with elements 10, 20, 30, 40, 50. In the second line, list2 equals list1 assigns list1 to list2. However, instead of creating a new list, list2 now refers to the same list object as list1. This means that both list1 and list2 point to the same memory location where the list is stored. Finally, it prints the contents of list2. Since list2 is referencing the same list as list1, it will display 10, 20, 30, 40, 50 in the console. Now, let's learn about accessing list elements indexing. Lists consists of any collection of items which are stored according to the index. Like strings, any items in a list can be accessed by using the slice operator, square brackets, by specifying the index value. List indices start from 0 and go to the length -1. The list values can be a positive or negative integer value or an expression which evaluates to an integer value. You can access the elements from a list either moving from left to right, positive indexing, or from right to left known as the negative indexing. Now look at this picture, which shows the positive and negative indices in a list. Positive index move from left to right, which starts from 0 and go to the length -1. Negative index move from right to left, which starts from -1, -2, and so on. Each given element, 10, 20, 30 up to 100, can be accessed through their indexes enclosed inside square brackets. Let's see some examples. Example 1. In this code, a list named list1 is defined with 10 elements, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. The print function is used to display the entire list on the console. You can check the output displayed as 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 in square brackets as it is a list. Example 2. This line of code accesses the first element of the list using the index 0. In Python, indexing starts from 0, so the element at index 0 is 10. You can check the above picture for reference. Therefore, when this code is executed, it will output 10 as shown in the console. Example 3. This line of code accesses the sixth element of the list using the index 5. The element at index 5 is 60, which is displayed as output. Example 4. Here, the negative index -4 is used to access the fourth element from the end of the list. In this case, the fourth element from the end is 70. You can check the above picture for reference. Thus, the output will be 70 displayed on the console. Example 5. In this line, the negative index -8 is used to access the eighth element from the end of the list. The eighth element from the end is 30. You can check the above picture for reference. Thus, the output will be 30 displayed on the console. Example 6. The code attempts to access the element at index 12, which is beyond the range of valid indices for this list. Since the list only has 10 elements, it will raise an index error exception when executed. It's important to remember that the valid indices for a list with n elements range from 0 to n-1. Accessing indices outside this range will result in an error. Let's see another example. Example 1. In this code, a list named list1 is defined with the elements s, t, o, r, a, g, e. The print function is used to display the entire list on the console. When executed, it will output as s, t, o, r, a, g east with square brackets as it is a list. Example 2. This line accesses the fourth element of the list using the index 3. Since indexing starts from 0, the fourth element corresponds to the letter r. Therefore, when this code is executed, it will output r. You can check the picture for reference. Example 3. Here, the negative index -6 is used to access the sixth element from the end of the list. The sixth element from the end corresponds to the letter t. Thus, the output will be t. You can check the above picture for reference. Example 4. The code attempts to access the element at index 10, but the list only contains 7 elements. Since the index is out of range, it will raise an index error exception when executed. It's important to note that the valid indices for a list with n elements range from 0 to n-1. Trying to access indices outside this range will result in an error. Let's learn about traversing a list. It's quite common to read through our shopping list to check if we've purchased all that we need. This is called traversing through the list. Traversing a list means accessing each element of a list. This can be done by using either for or while looping statement. Let's see the 3 ways how traversing can be done. First way is to use an in operator inside for loop. Example 1. In the first line, a list named list1 is defined with the elements c, o, m, p, u, t, e, r. Each element represents a character. In the second line, we use for loop. This for loop iterates over each element in list1 and assigns it to the variable I for each iteration. In the first iteration, variable I will be assigned the first element, that is, c, then the second element, o, and in this way each letter is accessed and displayed on the console. Each element is displayed on a new line till all the elements are traversed and displayed. Here, in operator using for loop iterates each element of a list in sequence. Example 2. Write a Python program to find the sum of all elements in a list. In line 1, a list named list1 is defined with 5 elements, 10, 20, 30, 40, and 50. In the second line, a variable named sum is also initialized to 0. In the third line, the for loop iterates over each element in list1. On each iteration, the value of I represents the current element. In line 4, the statement sum equals sum plus I adds the value of I to the sum variable, effectively accumulating the sum of all elements in list1. Finally, the print function to display the elements in list1 and the calculated sum. The sum of the list 10, 20, 30, 40, and 50 is 150. You can check the output in the console. The second way to traverse a list is to use range function. It checks for the given set of values mentioned as argument to the range function. This function can be used for accessing individual elements of a list, using indexes of elements only, along with the len method which gives length of the list and specifies how many times for loop will iterate. Let's see an example. Example 1. Write a Python program to count the total number of elements in a list. Now, look at the code. In line 1, a list named list1 is defined with the elements s, y, s, t, e, m. In line 2, the len function is then used to calculate the total number of elements, or characters, in list1, and the result is stored in the variable n. In line 3, the for loop iterates over the range of numbers from 0 to n-1. On each iteration, the value of I represents the current index. In line 4, the print function is used to display the character at index I in list 1. By iterating through the indices, each character is printed on a separate line, followed by the total number of characters, which is 6 in this case. The third way to traverse a list is to use while loop. The list elements or items in Python can also be iterated or accessed using a while loop. Firstly, the len function is used to determine the length of the list, then the while loop starts from index 0 and is iterated through the list items by referring to their indexes. Unlike a for loop, it is a must to increase the index by 1 after each iteration. Let's see an example. Accessing the elements of a list using while loop. Now, look at the Python code. In line 1, a list named list1 is defined with 4 elements. In line 2, an integer variable named index is initialized with the value 0. In line 3, the while loop iterates as long as the value of index is less than the length of list1. The condition index less than len of list1 ensures that the loop runs until all elements in list1 are processed. Within the loop, print of list1 of index is executed to display the element at the current index position in list1. After printing, index is incremented by 1 using index plus equals 1 to move to the next index for the next iteration. The loop continues until the condition index less than len of list1 becomes false, which happens when index reaches the length of list1. Here, length of list1 is 4. Each element in list1 will be printed on a new line, in the order they appear in the list. The while loop iterates over the indices of the list, printing the corresponding elements until it reaches the end. The output displayed, each element on a new line are AI, computer science, data science and information technology. You can check the output on the console. An alias is a second name for a piece of data. In Python, aliasing happens whenever one variable's value is assigned to another variable, because variables are just names that store references to values. Let's see an example. Let us create a list named fruits containing names of 5 fruits as string types. Fruits equals apple, mango, grapes, strawberry, and banana. The elements of fruits list in memory are represented according to their index values. Now look at the first picture. Since the list index always starts with 0, so apple is stored at index value 0, mango at index 1, grapes at index 2, strawberry at index 3 and banana at index 4. Now we will assign it to create a temporary list of the already created list, fruits, by giving the statement as temporary equals fruits. Now look at picture 2. Now, we have 2 lists having the same set of values. In other words, temporary is an alias, alternate, name for fruits list as assignment with an equal to operator does not make a copy, instead makes both these lists referring to the same location. We can modify the contents of these lines by referring to its individual index value. Look at these examples. In line 1, a list named fruits is created containing names of 5 fruits as string types. Fruits equals apple, mango, grapes, strawberry, and banana, and it is printed. You can see the output displayed in a list as apple, mango, grapes, strawberry, and banana. Now look at the next line. Here, we are assigning it to create a temporary list of the already created list, fruits, by giving the statement as temporary equals fruits. Now, temporary list is an alias for the list fruits. The next line says that index value 0 of temporary list holds the string peach. So, when printed, now, look at the second output, it displays as peach, mango, grapes, strawberry, and banana. Again, when fruits list is printed, the output would be, now look at the third output, peach, mango, grapes, strawberry, and banana, as both these lists, fruits and temporary lists, are referring to the same location. Thus modifications made in the temporary list are reflected in the fruits, original list as well, since the same list is having 2 different names. So, we can say that changes with one alias get reflected in the other alias. The lists can be modified and represented with 2 values at one index position. It can also be represented in 2-dimensional manner. Now, look at the Python code. In line 1, the fruits code variable is a tuple containing nested lists. Each nested list represents a fruit and its code. Each nested list consists of 2 elements, the fruit name, a string, and the code, an integer. In the second line of the Python code, to access and print the second element of the fruits code list, you can use indexing with a number 1, since indexing starts from 0 in Python. Look at the first picture above. See the red marking. Indexing starts from 0. So, the output for fruit code of index 1 displays list containing string mango and code 55, which I have marked in light blue oval shape. In the third line of the Python code, to print the fruit name and its code separately, you can access the individual elements of the tuple using indexing. Now, look at the second picture. See the blue marking. The fruit name is the first element, index 0, of the tuple, and the code is the second element, index 1, of the tuple. So fruit code index 1 of index 0 is mango. I have marked in red oval shape, and fruit code index 1 of index 1 is 55, which I have marked in green oval shape. So the output displayed is mango and 55 printed separately. You can check the output on the console. Python allows us to compare two lists. Each element is individually compared in lexicographical or alphabetical or dictionary order. We can apply all the relational operators greater than, less than, double equal to, not equal to, and so on, to compare two lists if they are of comparable types, otherwise Python flashes an error. Let's see an example. In line 1, two lists L1 and L2 are given with values 10, 20, 30. In the second line, list L1 is compared with list L2. Both are equal and hence displayed true. But see the next example, list L3, which is a nested list. Here when L1 is compared to list L3, it's not equal and returns false. The second statement evaluates to false because L3 is a nested list and L1 is a simple list. Thus, on comparison, it generates false because both lists are different. Next, we will see how Python compares two lists by checking element by element comparison. If the corresponding elements are equal, it goes on to the next element and so on, until it finds the element that differs. Now, look at the tabular column below. Example 1. On comparing the first element, it yields true, as the first element 1 is less than 4, it generates true and hence the output becomes true. Example 2. On comparing the first element, it yields true, but on comparing the second element 2 is less than 5, it generates true and hence the output becomes true. Example 3. On comparing the first and second elements, it yields true, but on comparing the third element 3 is greater than 0, it generates true and hence the output becomes true. Example 4. On comparing the first, second, and third elements, it yields true, but on comparing the fourth element 4, which is not less than 2, it generates false and hence the output becomes false. Therefore, for comparing two lists, Python internally compares individual elements of two lists, applying all the comparison rules. Let's see some examples. 5 lists L1, L2, L3, L4, and L5 are displayed with values of different data type. Now come to line 6. Print of L1 equal to L2. This comparison checks if the elements in both lists L1 and L2 are exactly the same. In this case, L1 contains the elements 10, 20, and L2 also contains the elements 10, 20. Since the elements are the same, the comparison returns true. Now, come to the next line 7, print of L1 equal to L3. This comparison also checks if the elements in both lists L1 and L3 are the same. However, in this case, L3 contains the elements 10, 20, which are strings, enclosed in quotation marks, whereas L1 contains the elements 10, 20, which are integers. Since the types are different, the comparison returns false. Now, come to line 8, print of L1 greater than L2. The comparison greater than checks if one list is greater than another based on lexicographical order. In this case, L1 and L2 have the same elements, 10, 20. Since they are identical, the comparison returns false because neither list is greater than the other. Now, come to line 9, print of L4 greater than L1. Similar to the previous comparison, greater than checks if one list is greater than another. L4 contains the elements 10, 0, 20.0, while L1 contains 10, 20. The comparison is performed element-wise. The first elements are equal, 10 equal to 10, but the second element differs, 0 versus 20. In this case, 0 is less than 20, so the comparison returns false. Now come to line 10. Print of L4 equal to L1. This comparison checks if the elements in L4 and L1 are the same. However, the elements in the two lists differ. L4 contains 10, 0, 20.0, whereas L1 contains 10, 20. Since the elements are not the same, the comparison returns false. Now come to line 11, print of L1 less than L5. The comparison less than checks if one list is less than another based on lexicographical order. L1 contains 10, 20, while L5 contains 10, 20, 30. The comparison is performed element-wise. The first two elements are the same, 10 equal to 10 and 20 equal to 20, but there is an additional element, 30, in L5. Since L1 is shorter than L5, the comparison returns true because L1 is considered less than L5 in lexicographical order. Let's see another example. Write a Python program to find at least one common element amongst the two inputted lists. Now look at the Python code. Line 1 and line 2. The code starts by defining two lists, L1 and L2, which contain some integer values. Line 3 and line 4. The first print statement simply displays the elements in L1, while the second print statement displays the elements in L2. Line 5. The code then enters a nested loop structure with the first loop iterating over each element x in L1, and the second loop iterating over each element y in L2. Line 6 and line 7 inside the nested loops, an if statement checks if x is equal to y. Line 8. If they are equal, it means a common element has been found between the two lists, so it executes the print statement that displays the common element. Now, check the output. The elements in list 1 are 150, 200, 250, 300. The elements in list 2 are 175, 275, 300, 375. Now the common element in both list is 300. Lists in Python, Part 2. In this video, we are going to discuss about operations on lists, concatenation, replication or repetition, membership testing, indexing, slicing, nested lists, copying lists and practical implementation. So let's dive in and get started. In Python, there are several built-in list operations available for manipulating and working with lists. Here are some commonly used list operations: concatenation, replication, membership testing, indexing and slicing. Let's see one by one in detail. Let's learn about the concatenation of lists. Concatenation or joining is a process in which multiple sequences or lists can be combined together with the help of certain operators. Python allows combining or adding of two lists using plus concatenation operator, addition operator. We can add two lists using this operator. Let's see some examples. Example 1. Adding two strings using the plus operator. In this example, we have a list L1 initially containing two strings, computing and technology. Using the plus operator, we concatenate the list L1 with another list containing a single string research. The plus operator concatenates the two lists together, resulting in a new list L1 with three elements: computing, technology, and research. The updated list is then printed, resulting in computing, technology, research. Now look at the second example. Adding two lists. In this example, we have two separate lists: become, computer, and scientist. Using the plus operator, we concatenate the two lists together. The plus operator combines the elements of both lists, resulting in a new list L1 with three elements: become, computer, and scientist. The concatenated list is then printed, resulting in become, computer, scientist. Example 3. In this example, we have two numeric lists, L1 with elements 10, 20, 30, 40, and L2 with elements 50, 60, 70, 80. Using the plus operator, we concatenate the two lists together. The plus operator combines the elements of both lists, resulting in a new list L3 with 8 elements: 10, 20, 30, 40, 50, 60, 70, 80. The concatenated list is then printed, resulting in 10, 20, 30, 40, 50, 60, 70, 80. In all three examples, the plus operator is used to concatenate lists or strings, resulting in a new combined list or string. The plus operator, when used with lists, requires both the operands to be of list types, otherwise it will result in type error. Let's see some examples. Example 1. Look at the Python code. The code attempts to concatenate the list L1 with the integer value 20. However, this operation is not supported because you cannot directly concatenate a list with an integer in Python. It would result in a type error. Example 2. Here, the code attempts to concatenate the list L1 with the string Python. However, this operation is not supported because you cannot directly concatenate a list with a string in Python. It would result in a type error. Thus, we conclude that the plus operator, when used with lists, requires both the operands to be of list types. In Python, you can replicate a list by using the multiplication operator, asterisk. The asterisk operator allows you to repeat the elements of a list a certain number of times. Let's see some examples. Example 1. In this code, the list L1 is multiplied by 2 using the asterisk operator. This replicates the elements of L1 2 times, resulting in a new list, 5, 10, 15, 5, 10, 15. You can check the output on the console. Example 2. In this code, the string hello is multiplied by 3 using the asterisk operator. This replicates the string 3 times, resulting in the output hello hello hello. You can check the output on the console. Example 3. This code attempts to multiply the lists L1 and L2 together, but this operation is not valid. It will raise a type error because you can only multiply a sequence, for example, list, string, with an integer. You can check the output on the console. Let's learn about membership testing. Membership testing in lists involves checking whether an element is present in a list or not. Python provides the in and not in operators to perform membership testing. Python offers two membership operators to check or validate the membership of a value. It tests for membership in a sequence, such as strings, lists, or tuples. Let's see about the in operator. The in operator is used to check if a character or substring or element exists in a sequence or not. It evaluates to true if it finds the specified element in a sequence otherwise false. Let's see some examples. Example 1. In this example, we are checking whether the character uppercase S is present in the string summer vacation. Since the character uppercase S is indeed in the string, the result is true. Example 2. In this example, we are checking whether the character lowercase s is present in the string summer vacation. However, Python is case-sensitive, so it considers lowercase s and uppercase s as different characters. Since the lowercase s is not present in the string, the result is false. Example 3. In this example, we are checking whether the string vacation is present in the list, summer, vacation. Since the string vacation is indeed in the list, the result is true. Example 4. In this example, we are checking whether the number 50 is present in the list, 50,000, 5,000, 550. Since the number 50 is indeed in the list, the result is true. In all of these examples, membership testing is performed using the in operator, which returns true if the element is present in the sequence and false otherwise. Next, we can see about not in operator. The not in operator returns true if the element does not appear in the list, otherwise returns false. Let's see some examples. Example 1, S equals pen, notepad, paint, brushes. This line of code creates a list S that contains the elements pen, notepad, paint, and brushes. Second line, print of pencil not in S. This line checks if the string pencil is present in the list, S. Since pencil is not in the list, S, the expression pencil not in S evaluates to true. Therefore, the output of this line would be true. Second example, X equals 10, 20, 30, 40. This line creates a list X that contains the elements 10, 20, 30, and 40. The next line, print of 10 not in X. This line checks if the value 10 is present in the list X. Since 10 is present in the list X, the expression 10 not in X evaluates to false. Therefore, the output of this line would be false. You can check the output on the console. In this method, the membership operator in can be used to display the elements of a list through for loop. Let's see an example. Write a Python program to display the names of students who are members of class 11. Now, look at the Python code. The line, students_11 equals Sam, Mary, Mac, Kevin, defines a tuple named students_11 that contains the elements Sam, Mary, Mac, and Kevin. Next line. For namelist in students_11, starts a for loop that iterates over each element in the tuple students_11. On each iteration, the current element is assigned to the variable namelist. The print of namelist prints the value of namelist during each iteration of the loop. In this case, it will print each name in the tuple students_11 on separate lines. You can check the output on the console. Let's discuss about indexing. In order to access the list items, refer to the index number. We use the index operator, square brackets, to access an item in a list. The index must be an integer. Nested lists are accessed using nested indexing. Let's see an example. Shopping_list equals apple, orange, bread, butter, pen, notepad. Now, look at the picture. In Python, indexing starts from 0. In the shopping list, we have 6 items in this particular sequence, and the positive index range is from 0 to 5, from left to right. An index is a number specifying the position of an element in a list. It enables access to individual element in the list. Index of first element in the list is 0, second element in the list is 1, and nth element is n-1. Negative indexes identify positions relative to the end of the list. The index -1 identifies the last element, -2 identifies next to the last element, and so on. Now look at the Python code. Print of shopping_list of 0 will display the output as apple. Print of shopping_list of 3 will display the output as butter. Print of shopping_list of -3 will display the output as butter. Print of shopping_list of -5 will display the output as orange. Slicing is a feature in Python that allows you to extract a portion of a list. It provides a way to create a new list by specifying a range of indices. The general syntax for slicing a list is list of open brackets start : stop : step close brackets, where start is the index where the slice starts, inclusive. If not specified, it defaults to the beginning of the list. Stop is the index where the slice ends, exclusive. If not specified, it defaults to the end of the list. Step is the increment between indices. If not specified, it defaults to 1. Let's see some examples. Let us consider a list or sequence as x equals SOFTWARE. The various slicing operations performed on the sequence is shown on this table. Now look at the table. Example 1. X of 1:4. Now look at the above picture. X of 1:4. Here start value is 1 and stop value is 4 exclusive. So stop value is 3. Step value is not given, so we take the default value 1. Hence, x of 1:4 slices the items 1 to 3. So the output is OFT. Now look at example 2. X of 1:6:2. Now look at the above picture. X of 1:6:2. Here start value is 1, stop value is 6 exclusive, so stop value is 5, step value is 2 given. So items 1, 3 and 5 are sliced. So the output is OTA. Now look at example 3. X of 3:. Now look at the picture. Here start value is 3. Stop value is not given. Hence we take the default value until the end of the string. Step value is also not given, so step value is default value 1. So the items 3 to end is sliced. Hence the output is TWARE. Now, look at example 4. X of 5. Here start value is not given. So default value starts from 0. Stop value is 5 exclusive. So stop value is 4. Step value is not given. So step value is default value 1. So the items 0 to 4 are sliced. Hence the output is SOFTW. Now, look at example 5. X of -1. Now look at the picture. Here the start value is -1. Backward negative indexing, hence it slices the last item. The output is E. Now, look at example 6. X of -3:. Now look at the picture. Here, start value is -3, stop value is not given. So default value is the end of the string. Step value is not given, so default value is 1. So, it slices the last 3 items. Hence the output is ARE. Now, look at example 7. X of -2. Expression represents a slice of the list X from the beginning to the second to last element. Start value is not given, so default value is 0. Stop value is -2 exclusive and hence stop value is -3. It excludes the last 2 elements, R and E. So all except last 2 items are sliced. Hence the output is SOFTWA. Let's see some more examples, how slicing operations are performed. Let us consider a list L1 with the values 20, 10.75, Python, coding, 282.50. Now, the positive indexing and negative indexing are marked for reference. Now, look at the Python code. The first line initializes the list L1 with the values 20, 10.75, Python, coding, 282.50. Example 1. It then prints the list L1 as it is. You can check the output 1 on the console. Now look at example 2. Print of L1 of 3:. This line slices the list L1 from index 3 to the end of the list. It includes the elements coding, 282.50. The output would be coding, 282.50. You can check the output 2 on the console. Now look at example 3. Print of L1 of :3. This line slices the list L1 from the beginning to index 3, exclusive. It includes the elements 20, 10.75, Python. The output would be 20, 10.75, Python. You can check the output 3 on the console. Now look at example 4. Print of L1 :2. This line slices the list L1 from the beginning to the end in steps of 2. It includes every second element in the list. It displays from beginning till end in step of 2. The output would be 20, Python, 200. You can check the output 4 on the console. Now look at example 5. Print of L1 of :2. This line slices the list L1 from the end to the beginning in steps of -2. It includes every second element in the list in reverse order. It displays from end till beginning, reverse order, in step of 2. The output would be 82.50, coding, 10.75. You can check the output 5 on the console. Now look at example 6. Print of L1 of -5:-2. This line slices the list L1 from the -5th index to the -2nd index, exclusive. It displays from -5 index to -2 in reverse order. It includes the elements 10.75 Python coding. The output would be 10.75 Python coding. You can check the output 6 on the console. Now look at example 7. Print of L1 of 5:2 -1. This line slices the list L1 from the 5th index to the 2nd index, exclusive, in reverse order with a step value of -1. It displays from 5th to 2nd position in reverse order with step as -1. It includes the elements 82.50, 200, coding. The output would be 82.50, 200, coding. You can check the output 7 on the console. Now look at example 8. Print of L1 -2 -5 -1. This line slices the list L1 from the -2nd index to the -5th index, exclusive, in reverse order with a step value of -1. It displays from -2 to -5 index position with step value as -1. It includes the elements 200, coding, and Python. The output would be 200, coding, Python. You can check the output 8 on the console. Now look at example 9. Print of L1 of -2 -5 -2. This line slices the list L1 from the -2nd index to the -5th index, exclusive, in reverse order with a step value of -2. It includes every second element in the specified range. It displays from -2 to -5 index position with step value as -2. The output would be 200 Python. You can check the output 9 on the console. The slicing operation is entirely based on indexing. In case the resulting index lies outside the lists, Python raises an indexer. List index out of range. Slice range, start and stop argument is treated as boundary and the result will simply contain all the elements which lie between the boundary. In case the start and stop limits lie outside the boundary, Python still returns the elements that lie between the specified range or boundary without raising any error. Let's see some examples. Example 1. In this line, we are attempting to slice the list L1 from index 2 to index 6. However, the list L1 has a length of 5, which means the valid indices range from 0 to 4. Index 6 is out of bounds and exceeds the length of the list. As a result, we will encounter an index error when trying to access index 6, but Python still returns the elements for the start value that lie between the specified range or boundary without raising any error. So the output will be list containing 33, 44, 55. You can check the output on the console. Example 2. In this line, we are trying to slice the list L1 from index 6 to index 10. Since the list L1 only has a length of 5, both the start and stop limits provided are out of bounds. The starting index of 6 exceeds the maximum valid index of 4, and the stop index of 10 is also beyond the list's length. Both the limits are out of bounds, still Python does not give any error but returns an empty list as no element of list 1 possesses the index that falls in the range of 6 to 10. So the output is empty list. You can check the output on the console. Let's learn about nested lists. Nested lists in Python are lists that contain other lists as elements. Each element within a nested list can be of any data type, including other lists. Let's see some examples. Example 1. List L1 holds the values 10, 20, C, M, a nested list holding the values 6, 7, 8, and 30, 40. The next line print of L1 of 4 retrieves the element at index 4 of the list L1. Now, look at the above picture. I have marked the positive indexing of the list in green color. It starts from index 0. Index 0 holds the value 10, index 1 holds the value 20, index 2 holds the string C, index 3 holds the string M, index 4 holds the nested list containing the element 6, 7, 8, index 5 holds the value 30 and index 6 holds the value 40. The element at index 4 is 6, 7, 8, which is a nested list. So the output displayed is a nested list 6, 7, 8. Example 2. Print of L1 of index 4 of index 1. Accesses the element at index 1 within the nested list at index 4. Look at the above picture. I have marked the nested list indexing with pink color. It starts from index 0. So index 0 holds the value 6, index 1 holds the value 7 and index 2 holds the value 8. The nested list 6, 7, 8 is at index 4 and the element at index 1 within that nested list is 7. Therefore, the output would be 7. Let's see some more examples. In this Python code list L1 holds the values of different data types. L1 equals values 10, 20, 30, string G, nested list holding strings, machine comma language, values 40, 50, 60 another nested list holding strings, artificial, comma intelligence. Now look at example 1. Print of L1 of 4 of 1. To understand this, at first look at the above picture for indexing the list. First, look at the green markings. Indexing starts from 0. So index 0 holds the value 10, index 1 holds the value 20, index 2 holds the value 30, index 3 holds the string G, index 4 holds the nested list, machine, language, index 5 holds the value 40, index 6 holds the value 50, index 7 holds the value 60, index 8 holds another nested list holding strings artificial and intelligence. Now we will look at nested indexing 1 in the picture, which is marked as pink color. Index starts at 0. Index 0 holds the string machine and index 1 holds the string language. Same way for the next nested list, index 0 holds the string artificial and index 1 holds the value intelligence. Now look at the nested list indexing 2, which is marked in blue color. I have written only for laprint of L1 of 4 of 1. And wage. So index starts from 0. Index 0 holds the character L, index 1 holds the character A, and so on. Now, let's come to the Python code. Example 1. Print of L1 of 4 of 1. This statement accesses the element at index 4 of L1, which is machine, language. Then, it further accesses the element at index 1 of that sublist, which is language. Therefore, it will print language. Now look at example 2. Print of L1 of 4 of 1 of 3. Similar to the previous statement, this statement accesses the element at index 4 of L1, which is machine, language. It then accesses the element at index 1 of that sublist, which is language. Finally, it tries to access the character at index 3 of the string language. So the output is G. Now look at example 3. Print of L1 of 4:7. This statement uses slicing to retrieve a sublist from index 4 to index 6 exclusive of L1. The resulting sublist is machine, language, 40, 50. Therefore, it will print machine, language, 40, 50. Now look at example 4. L1 of 4 equals Python. This statement replaces the element at index 4 of L1 with the value Python. The previous value, machine, language, is overwritten, and the new list becomes 10, 20, 30, G, Python, 40, 50, 60, artificial, intelligence. Now look at example 5. Print of L1 of -1. This statement accesses the last element of L1, which is artificial, intelligence. Therefore, it will print artificial, intelligence. Now look at example 6. L1 of 8 of 0 equals natural. This statement modifies the first element of the sublist at index 8 of L1. The previous value artificial is replaced with natural. The updated list becomes 10, 20, 30, G, Python, 40, 50, 60, natural, intelligence. Now look at example 7. Print of len of L1. This statement calculates the length of L1, which is the total number of elements in the list. In this case, it will print 9. Now look at example 8. Print of type of L1. This statement returns the type of L1, which is a list. It will print class list. Let's learn about copying a list. Given a list, the simplest way to make a copy of the list is to assign it to another list. Let's see some examples. Example 1. List 1 holds the elements 10, 20, 30. In the next line, the variable L2 is assigned to L1. However, it's important to note that this assignment does not create a new copy of the list. Instead, both L1 and L2 refer to the same underlying list object. Therefore, modifying the list through one variable will affect both variables. So print of L1 will display the list 10, 20, 30. And print of list L2 will display the list 10, 20, 30 respectively. At this point, both L1 and L2 contain the same elements, 10, 20, and 30. You can check the output on the console. Example 2. Here, we are appending or adding the value 40 to list L1. After appending the value 40 to L1, both L1 and L2 reflect the change since they refer to the same list object. At this point, both L1 and L2 contain the same elements, 10, 20, and 30, 40. You can check the output on the console. We can also create a copy or clone of the list as a distinct object by 3 methods. The first method uses slicing. Method 1. We can slice our original list and store it into a new list variable. The syntax is new list equals old list open brackets colon close brackets. Here is an example. In this case, L2 is assigned a copy of L1 using the slice operator open square brackets colon close square brackets. This creates a new list object with the same elements as L1. Therefore, L2 is an independent copy of L1. Printing L2 will output the elements 20, 40, 60, 80. Modifying L1 will not affect L2 and vice versa. Method 2, we can use the list constructor function list function. The syntax is new list equals list of old list. Let's see an example. In this code, L2 is assigned a new list object created by passing L1 as an argument to the list function. This creates a new list with the same elements as L1. Therefore, L2 is an independent copy of L1. Printing L2 will output the elements 5, 10, 15, 20. Modifying L1 will not affect L2 and vice versa. Method 3, we can use the copy function. The syntax is new list equals list of old list.copy function. Let's see some examples. Example 1. In this code, L1 is initially assigned the list 10, 20, 30, 40. L2 is created as a copy of L1 using the copy method. So L2 also contains the same elements 10, 20, 30, 40. You can check the output displayed as 10, 20, 30, 40. Example 2. L1 of 0 equals 100. Modifying L1 by changing the value at index 0 to 100, using L1 of 0 is equal to 100, results in list 100, 20, 30, 40. You can check the output displayed as list 100, 20, 30, 40. Next line is print of L2. Since L2 is a separate copy, it remains unchanged and still contains the original elements of list 10, 20, 30, 40. Hence the output displays on the console as list 10, 20, 30, 40. Example 3. L2 of 2 equals 300. Modifying L2 by changing the value at index 2 to 300, using L2 of 2 is equal to 300, results in list 10, 20, 300, 40. You can check the output displayed as list 10, 20, 340. Next line, in print of L1, again, L1 remains unchanged and still contains list 100, 20, 30, 40. So the output displays list 100, 20, 30, 40. The copy functions returns a new list stored in a different memory location. It doesn't modify the original list, or the modifications made in the new list will not be reflected to the base list. Lists in Python, Part 3. In this video, we are going to discuss about built-in functions, manipulating lists, updating list, deletion operation, searching list, and practical implementation. So let's dive in and get started. In Python, there are several built-in functions like append, extend, insert, reverse, index, updating list like len, sort, sorted, clear, count, deletion operations like pop, del, and remove, and max and min. All these functions can alter the elements of the list rather than creating a new list, such as adding new elements, changing the elements in a list, and so on. Let's see one by one in detail. Let's learn about the append function. The append function is a built-in method in Python lists that allows you to add an element to the end of an existing list. It doesn't create a new list, rather it modifies the original list. The single element can also be a list. The syntax is list.append of item. Here, the item can be numbers, strings, another list, dictionary, etc. An item to be added at the end of the list, the parameter is mandatory and omitting it can give an error. The method doesn't return any value. Now, look at this picture. The list has already 4 elements. When we append or add the 5th element in the list, it modifies the original list by adding items or elements at the end of the list. Let's see some examples. Look at example 1. L1 equals 2, 4, 6, 8. A list L1 is created with initial elements 2, 4, 6, 8. Print the original list and print L1 prints the message the original list and the contents of L1 respectively. This displays the original list before any elements are appended. You can check the output one on the console as 2, 4, 6, 8. Example 2. L1.append of 10. The append function is used to add the element 10 to the end of L1. This modifies the list in place. Thus the print statement prints the list after appending 10. You can check the output 2 on the console as 2, 4, 6, 8, 10. Example 3. L1.append of computer. The append function is used again, this time to add the string computer to the end of L1. Thus the print statement prints the list after appending the string computer. The output 3 will be 2, 4, 6, 8, 10 computer. Example 4. L1.append of list 3, 5. The append function is used once more, this time to add a new list, 3, 5, as a single element to the end of L1. The print statement prints the final list after appending list 3, 5. So the output will be 2, 4, 6, 8, 10 computer, list containing 3, 5. Let's see an example. Example 1. Write a Python program to find the second largest element in a list number. This Python program finds the second largest element in a list. I have divided this code into 6 parts, using white boxes. Now, look at the box number 1. Here, the user is prompted to enter the number of elements in the list, and the input is stored in the variable n. In the second box, while loop is used to get n inputs from the user and append or add them to the list number. Each input is converted to an integer using int of input function and stored in the variable number 1. The loop continues until I reaches n. In the third box, the original list is printed using for loop to iterate over the elements of number. The end equals empty space parameter is used to print the elements separated by a space instead of a new line. In the fourth box, two variables, m and m2, are initialized to the first two elements of the list number. If the first element is greater than the second element, m and m2 are assigned accordingly. Otherwise, they are assigned the second element and the first element, respectively. In the fifth box, for loop iterates over the elements of number starting from the third element, number of list 2 : If an element x is greater than m2, it is checked if it is also greater than m. If it is, then m2 is assigned x and the original value of m is assigned to m. If x is not greater than m, m2 is assigned x. Finally, in the sixth box, the second largest element, m2, is printed. You can check the output on the right side. User enters 5 elements 35, 74, 82, 49, 50. The second largest element in the list is 74. Now pause the video and work out by your own. Example 2. Write a Python program to add the even numbers in the list when certain numbers are given as input from the user. Now, look at the Python code. Line 1. An empty list L is initialized. Line 2. The user is prompted to enter the total number of values in the list, and the input is stored in the variable n. Next, look into the white box. While loop is used to iterate n times. In each iteration, the user is prompted to enter an element, and it is stored in the variable a. Inside the while loop, if condition is checked. If a is divisible by 2, that is, an even number, it is appended to the list L using the append method. The while loop continues until I reaches n. Finally, the final list L, containing only the even numbers entered by the user, is printed. You can check the output. User has entered 5 elements. 47, 82, 90, 56, and 29. So the even numbers displayed are 82, 90, and 56. The extend method adds one list at the end of another list. All items of a list are added at the end of an already created list. The syntax is list1.extend of list2. Here list1 is the primary list which will be executed. List2 is the list which will be added to list1. Let's see an example. Two lists are defined, L1 with elements 10, 20, 30, and L2 with elements 40, 50. The extend method is called on L1 and passed L2 as an argument. This method modifies L1 by appending the elements of L2 to the end of it. After executing this line, L1 will contain 10, 20, 30, 40, 50. The modified list L1 is printed, resulting in the output 10, 20, 30, 40, 50. Python list insert method inserts a given element or object at a given index in a list using Python. This function takes two arguments: the index where an item or object is to be inserted and the item or element itself. The syntax is list_name.insert of index_number, value. Here, list_name is the name of the list. Index_number is the index where the new value is to be inserted. Value is the new value to be inserted in the list. Let's see an example. Now, look at the Python code. Line 1. The list week_days is defined with the elements Monday, Tuesday, Thursday, and Friday. Line 2. The insert method is called on the week_days list. It takes two arguments, the index at which the new element should be inserted, in this case, 2, and the element to be inserted, Wednesday. This line inserts Wednesday at index 2, shifting the existing elements to the right. After executing this line, the week_days list will be Monday, Tuesday, Wednesday, Thursday, Friday. You can see Wednesday inserted in index 2 on the output. So the output displayed is Monday, Tuesday, Wednesday, Thursday, and Friday. Let's see some examples. Now, look at example 1. Line 1. The list L1 is defined with the elements 100, 200, 300, 400. Line 2. The insert method is called on L1 to insert the value 250 at index 2. This line modifies L1, and after executing this line, L1 will be 100, 200, 250, 300, 400. The modified L1 list is printed, resulting in the output 100, 200, 250, 300, 400. You can check the output 1 on the console. Example 2. The insert method is called again to insert the value 50 at index 0. This line modifies L1, and after executing this line, L1 will be 50, 100, 200, 250, 300, 400. The updated L1 list is printed, resulting in the output 50, 100, 200, 250, 300, 400. You can check the output too on the console. Example 3. The insert method is called once more to insert the value 450 at index 3. This line modifies L1, and after executing this line, L1 will be 50, 100, 200, 450, 250, 300, 400. The final modified L1 list is printed, resulting in the output 50, 100, 200, 450, 250, 300, 400, which is seen in output 3 on the console. Example 1. Write a Python program to read a list of elements. Input an element from the user that has to be inserted in the list. Also, input the position at which it is to be inserted. Apply a built-in function to insert the element at the desired position in the list. Now, look at the Python code. Line 1. An empty list L1 is initialized. The user is prompted to enter the number of elements to be entered in the list, and the input is stored in the variable n. Now, look at the white box. For loop is used to iterate n times. In each iteration, the user is prompted to enter an element, which is converted to an integer using int of input function. The element is then appended to the list L1 using the append method. After this loop, L1 will contain the entered elements. Line 7. The original list L1 is printed. Now look at the second white box. The user is prompted to enter the element to be inserted ELE, and the position at which it should be inserted the POS. The insert method is then called on L1 to insert ELE at index POS. This line modifies L1 by inserting the element at the specified position. Finally, the updated list L1 is printed, showing the new list with the inserted element at the specified position. Now, look at the output. The user has entered 5 elements. 10, 20, 40, 60, 80. The element to be inserted is 30. Position at which it is to be inserted is 2. Now, the new list is 10, 20, 30, 40, 60, 80. The reverse function in Python reverses the order of the elements in a list. This function reverses the item of the list. It replaces a new value in place of an item that already exists in the list, that is, it does not create a new list. The syntax is list.reverse function. There are no parameters. The reverse method does not return any value but reverses the given object from the list. Let's see some examples. Example 1. Now, look at the Python code. Line 1. The list L1 is defined with the elements 5, 10, 15, 20, 25. Line 2. The reverse method is called on L1 to reverse the order of its elements. After executing this line, L1 will be 25, 20, 15, 10, 5. The reversed L1 list is printed, resulting in the output 25, 20, 15, 10, 5, which can be seen on the output 1 on the console. Example 2. The list month is defined with the elements January, February, March, April. The reverse method is called on month to reverse the order of its elements. After executing this line, month will be April, March, February, January. The reversed month list is printed, resulting in the output April, March, February, January, which can be seen on the output 2 in the console. In both cases, the reverse method modifies the list in place and reverses the order of its elements. The index function in Python returns the index of first matched item from the list. It returns the first occurrence of an item for which the index position is to be searched in the list. If the element is not present, value error is generated. The syntax is list.indexOfItem. Let's see some examples. Example 1. Now, look at the Python code. The list L1 is defined with the elements 5, 10, 15, 20, 25. The index method is called on L1 with the argument 15 to find the index of the element 15 in the list. The index method returns the index of the first occurrence of the specified element. In this case, 15 is located at index 2, so the output of this line will be 2. Example 2. The string s is defined as computer. The index method is called on the string s with the argument t to find the index of the first occurrence of the letter t. In the string computer, t is located at index 5, so the output of this line will be 5. Example 3. The list x is defined with the elements in a list, fundamentals, of Python. The index method is called on x with the argument fundamentals to find the index of the first occurrence of the element fundamentals in the list. Since fundamentals is the first element in the list, it is located at index 0, so the output of this line will be 0. In all cases, the index method is used to find the index of a specific element. It returns the index of the first occurrence of the element if it exists in the list or string. Let's learn about updating a list. Lists are mutable. We can assign new value to existing value. We can use assignment operator, =, to change an item or a range of items. The syntax is list of index equal to new value. Let's see some examples. Example 1. Now, look at the Python code. In this code, L1 is a list with elements 10, 20, 30, 40, 50, 60. By accessing L1 of 1 and assigning a new value of 25 to it, we modify the second element of the list. When we print L1, we see the updated list where the second element has been changed from 20 to 25. So the output is 10, 25, 30, 40, 50, 60. Example 2. L1 is again a list with elements 10, 20, 30, 40, 50, 60. By using the slice notation L1 of 1:4, we create a new list L2 that contains elements from index 1, inclusive, up to index 4, exclusive, of L1. Therefore, L2 becomes 20 and 30, 40, and when you print it, you see that list 20 and 30, 40 on the console. Example 3. L1 is a list with elements red, blue, green. By accessing L1 of 2 and assigning a new value of yellow to it, we modify the third element of the list. When we print L1, we see the updated list where the third element has been changed from green to yellow. It's important to keep in mind that Python uses zero-based indexing, meaning the first element of a list has an index of 0, the second element has an index of 1, and so on. Python len function is an inbuilt function in Python. The len function returns the length of the list, that is, the number of elements in a list. It returns the integer value, which indicates the length of an object. Let's see some examples. Example 1. The len function in Python returns the number of elements in a list. In the given code, len of list1 will return 4 because there are 4 elements in list1. Example 2. Similarly, len of list2 will return 6 because list2 has 6 elements. The sort function can be used to sort the list in both ascending and descending order. It can be used to sort lists of integers, floating point numbers, strings, and others. This modifications is done in place, that is, it does not create a new list. The syntax is list.sort function. The sort does not return anything but alters the original list according to the passed parameter. Let's see about sorting list in ascending order. By default, the sort in Python sorts a list in ascending order if we do not provide it with any parameters. Let's see some examples. Example 1. The list 100, 300, 400, 200 is assigned to the variable numbers. The sort method is called on the numbers list, which sorts the elements in ascending order. After sorting, the list prints 100, 200, 300, 400. Example 2. The list 4.11, 5.00, 3.67, 2.28, 1.68 is assigned to the variable decimal number. The sort method is called on the decimal number list, which sorts the elements in ascending order. After sorting, the list prints 1.68, 2.28, 3.67, 4.11, 5.0. Example 3. The list peach, apple, strawberry is assigned to the variable words. The sort method is called on the words list, which sorts the elements alphabetically in ascending order. After sorting, the list prints apple, peach, strawberry. In all three cases, the sort method modifies the original list in place and arranges the elements according to the sorting criteria for the specific data type. Let's learn about the sorting list in descending order. To sort a list in descending order, set the reverse parameter to true of the sort function in Python. The syntax is list1.sort of reverse equals true. Let's see some examples. Example 1. The list 10, 30, 40, 20 is assigned to the variable numbers. The sort of reverse equals true method is called on the numbers list, which sorts the elements in descending order. After sorting, the list prints 40, 30, 20, 10. Example 2. The list 4.01, 5.00, 2.67, 3.28, 1.68 is assigned to the variable decimal number. The sort of reverse equals true method is called on the decimal number list, which sorts the elements in descending order. After sorting, the list prints 5.0, 4.01, 3.28, 2.67, 1.68. Example 3. The list system, analysis, design is assigned to the variable words. The sort of reverse equals true method is called on the words list, which sorts the elements in descending order alphabetically. After sorting, the list prints system, design, analysis. In all three cases, the sort of reverse equals true method modifies the original list in place and arranges the elements in descending order based on the sorting criteria for the specific data type. Python sorted function returns a sorted list from the iterable object. This function also sorts the items of the list like sort function. The syntax is sorted of list, reverse equals true or false. List is the sequence that needs to be sorted. Reverse is optional. If true, then the iterable would be sorted in reverse, descending, order. By default it is set as false. It returns a list with elements in sorted order. Let's see some examples. Look at line 1. Here, a list named X is defined with 4 elements, 20, 60, 10, and 40. Line 2 prints the string original list given, followed by the elements of the list X. It will output original list given, 20, 60, 10, 40. Line 3. This line sorts the elements of the list X in ascending order using the sorted function. The sorted list is then printed. It will output sorted list returned 10, 20, 40, 60. Line 4. Here, the sorted function is used with the reverse equals true argument. This sorts the elements of the list X in descending order. The reversed sorted list is then printed. It will output reverse sort 60, 40, 20, 10. Line 5. This line also uses the sorted function, but with the reverse equals false argument. This sorts the elements of the list X in ascending order, similar to the first print statement. The sorted list is then printed. It will output using reverse equals false, returns the sorted list 10, 20, 40, 60. Hence, the sorted function in Python is used to sort a list in both ascending and descending order. The clear method removes all items from the list. This method doesn't take any parameters. The clear method only empties the given list. It doesn't return any value. The syntax is list.clear function. The clear method doesn't take any parameters. The list clear method doesn't return any value. Let's see some examples. Example 1. Here, the list list1 is defined with 4 elements, 25, 35, 45, and 55. The second line prints the string list before clear, followed by the elements of list1. It will output list before clear 25, 35, 45, 55. Example 2. The clear method is called on list1, which removes all the elements from the list, making it an empty list. The second line prints the string list after clear, followed by the elements of list1, which is now an empty list. It will output list after clear empty list. Python list count method returns the count of how many times a given object occurs in a list using Python. The syntax is list.count of element. Parameters. Element is the item whose count is to be returned. It returns the count of how many times object occurs in the list. Let's see some examples. Example 1. In this example, a list named list1 is defined with several elements. The count method is then called on list1 with the argument p. This method counts the number of occurrences of the specified element, p, in the list and returns the count. In this case, the letter p appears 4 times in list1. Therefore, the output will be 4. Example 2. In this example, a list named list1 is defined with various elements, including sublists and other data types. The first count method call counts the number of times the sublist 1, 2 appears in list1. In this case, the sublist 1, 2 appears 3 times in list1. Therefore, the output will be 3. Example 3. The second count method call counts the number of times the value 100 appears in list1. Since the value 100 is not present in list1, the method returns 0. Therefore, the output will be 0. Python provides operator for deleting or removing an item from a list. We are going to discuss about pop, del, and remove method. First method is the pop method. Python list pop is an inbuilt function in Python that removes and returns the last value from the list or the given index value. The syntax is list.pop of index. Index is optional. The value at index is popped out and removed. If the index is not given, then the last element is popped out and removed. It returns the last value or the given index value from the list. Exception. Raises indexer when the index is out of range. Let's see some examples. Example 1. List1 equals 10, 20, 30, 40. This line initializes a list called list1 with 4 elements, 10, 20, 30, and 40. In the second line, the pop method is called on list1 with no index value provided. Since no index is specified, the pop method by default removes and returns the last element from the list. In this case, the last element is 40. The print statement displays popped element 40. You can check the output on the console. After popping the last element from list 1, the next line prints the remaining elements of list 1. The output will be list after pop method 10, 20, 30. You can check the output when displayed. Now look at example 2. List 2 equals 2, 4, 6, 8, 10. A new list called list 2 is initialized with 5 elements, 2, 4, 6, 8, and 10. In the second line, the pop method is called on list 2 with an index value of 2. This means the element at index 2, which is 6, will be removed and returned. The print statement displays popped element 6. You can check the output 2 on the console. After popping the element at index 2 from list 2, the next line prints the remaining elements of list 2. The output will be list after pop 2 is 2, 4, 8, 10. You can check the output 2 on the console. Example 3. List 1 equals 5, 10, 15, 20. The variable list 1 is reassigned with a new list containing 4 elements, 5, 10, 15, and 20. In the second line, the pop method is called on list 1 with a negative index value of -1. Negative index values count from the end of the list, so -1 refers to the last element. The last element of list 1 is 20, and it will be removed and returned by pop method. The print statement displays popped element 20. After popping the last element from list 1, this line prints the remaining elements of list 1. The output will be list after pop of -1 is 5, 10, 15. You can check the output 3 on the console. Del statement removes the specified element from the list but does not return the deleted value. Let's see some examples. Example 1. L1 equals 10, 20, 30, 40, 50. This line initializes a list called L1 with 5 elements, 10, 20, 30, 40, and 50. The second line, in del L1 of 3, the del statement is used to delete an element from a list based on the provided index. In this case, it deletes the element at index 3, which is 40, from L1. After deletion, the updated L1 list will be printed as 10, 20, 30, 50. You can check the output on the console. Example 2. L2 equals 5, 10, 15, 20. A new list called L2 is initialized with 4 elements, 5, 10, 15, and 20. In the second line, in del L2 of -2, the del statement is used to delete an element from a list based on the provided index. In this case, it deletes the element at index -2, which refers to the second to last element, 15, from L2. After deletion, the updated L2 list will be printed as 5, 10, 20. Example 3. Del with slicing is done here. L3 equals 20, 40, 60, 80. This line initializes a list called L3 with 4 elements, 20, 40, 60, and 80. In the second line, in del L3 of 1:3, the del statement is used to delete a slice of elements from a list. In this case, it deletes the elements at indices 1 and 2, excluding index 3, from L3. After deletion, the updated L3 list will be printed as 20, 80. You can check the output 3 on the console. Example 4. L4 equals 20, 40, 60, 80. The variable L4 is assigned a new list containing 4 elements, 20, 40, 60, and 80. In the second line, in del L4 of 6, the del statement is used to delete an element from a list based on the provided index. In this case, it attempts to delete the element at index 6 from L4. However, since L4 has only 4 elements, indices 0 to 3, index 6 is out of range. Therefore, this line will result in an error. Since an error occurs in the previous line, the program will terminate and won't execute the line print, L4. The remove function is used when we know the element to be deleted, not the index of the element. The syntax is list.remove of element. Here, element is the element to be removed from the list. This method does not return any value but removes the given object from the list. Exception. If the element doesn't exist, it throws value error. Remove method removes the first occurrence of the object from the list. Let's see some examples. Example 1. This line initializes a list called list1 with 7 elements, 5, 10, 25, 15, 20, 25, and 30. In the second line, the remove method is called on list1 to remove the first occurrence of the value 25. Since 25 appears twice in list1, only the first occurrence will be removed. After removal, the updated list1 printed is 5, 10, 15, 20, 25, 30. Example 2. A new list called list2 is initialized with 7 elements, Q, W, E, S, R, T, and Y. In the second line, the remove method is called on list2 to remove the first occurrence of the value S. After removal, the updated list2 printed is Q, W, E, R, T, Y. You can check the output on the console. Example 1. Write a Python program to delete all odd numbers and negative numbers from a given numeric list. Now, look at the code. Line 1. List 1 equals 8, minus 3, 2, minus 4, minus 6, 7, 0, minus 1, 5, 9. This line initializes a list called list1 with 10 elements. Line 2. len1 equals len of list1. The variable len1 is assigned the length of list1, which is the number of elements in the list. Line 3. I equals 0. The variable I is initialized to 0. It will be used as an index to iterate over the elements of list1. Line 4. While I less than len1. This line starts a while loop that continues as long as I is less than len1. Line 5. Inside the while loop, the code checks two conditions using an if-elif structure. First condition. If list1 of I less than 0. This condition checks if the element at index I in list1 is less than 0. If this condition is true, it means the element is negative. So it goes to line 6, del list1 of I. The del statement is used to delete the element at index I from list1. Line 7, len1 equals len1 minus 1. Since an element is removed from the list, the length of list1 is decrement by 1. Line 8, I equals I minus 1. The index I is decrement by 1 to account for the shifted indices after the deletion. Second condition checked in line 9. Elif of list1 of I mod 2 is not equal to 0. This condition checks if the element at index I in list1 is odd. If this condition is true, it means the element is not even. Line 10, del list1 of I. The del statement is used to delete the element at index I from list1. Line 11, len1 equals len1 minus 1. Since an element is removed from the list, the length of list1 is decrement by 1. Line 12. I equals I minus 1. The index I is decrement by 1 to account for the shifted indices after the deletion. Line 13. I equals I plus 1. At the end of each iteration of the while loop, the index I is increment by 1 to move to the next element in list1. Once the while loop finishes, the code moves to the next line outside the loop. Finally, it prints the updated list1 after all the elements that are negative or odd have been removed. The output is 8, 2, 0. Lists can easily be searched for values using the index method that expects a value that is to be searched. The output is the index at which the value is kept. The syntax is list.indexOfElement. Let's see some examples. Example 1. L1 equals 10, 20, SAM, 400, software, 500. This line initializes a list called L1 with 6 elements of different types. In the second line, the index method is called on L1 to find the index of the first occurrence of the value 20. The returned index value is assigned to the variable s. In this case, the value 20 is at index 1, so s will be assigned the value 1. The next line prints the value of s, which is the index of 20 in L1. You can check the output 1 on the console. Example 2. S equals L1.index of software. The index method is called on L1 to find the index of the first occurrence of the value software. The returned index value is assigned to the variable s. In this case, the value software is at index 4, so s will be assigned the value 4. The next line prints the value of s, which is the index of software in L1. You can check the output on the console. Example 3. S equals 500 in L1. This line checks if the value 500 is present in L1 using the in operator. The result of this check, either true or false, is assigned to the variable s. In this case, 500 is present in L1, so s will be assigned the value true. The next line prints the value of s, which indicates whether 500 is present in L1 or not. The output will be true. Check the output on the console. Example 4. S equals L1.index of 600. The index method is called on L1 to find the index of the first occurrence of the value 600. However, 600 is not present in L1, so this line will raise a value error with the message 600 is not in list. Since an error occurs in the previous line, the program will terminate and won't execute the line print of s. Python list max function returns the maximum value present in the list. To use max function, all values in the list must be of the same type. The syntax is max of listname. Here, listname is the name of list in which we have to find the maximum value. It returns the maximum value present in the list. Let's see some examples. Example 1. Look at the Python code. L1 equals 4 minus 4, 8, minus 9, 1. This line initializes a list called L1 with 5 integers. The next line, max value equals max of L1. The max function is called on L1 to find the maximum value in the list. the maximum value is assigned to the variable max value. In this case, the maximum value in L1 is 8, so max value will be assigned the value 8. The next line prints the value of max value, which is the maximum value in L1. The output will be 8 displayed on the console. Example 2. List 1 equals uppercase B, lowercase e, uppercase e. This line initializes a list called list 1 with 4 strings. The second line. Max value equals max of list 1. The max function is called on list 1 to find the maximum value in the list. Since the elements of list 1 are strings, the maximum value is determined based on the ASCII code values, lexicographic order, that is, alphabetical order. In this case, the maximum value in list 1 is lowercase e, which holds the ASCII value 101. Thus, it prints the output as lowercase e, which is displayed on the console. Python min function returns the element with the minimum value from the list. To use the min function, all values in the list must be of the same type. The syntax is min of list name. List name is the name of list in which we have to find the minimum value. It returns the minimum value present in the list. Let's see some examples. Example 1. L1 equals 4 minus 4, 8 minus 9, 1. This line initializes a list called L1 with 5 integers. The second line, min value equals min of L1. The min function is called on L1 to find the minimum value in the list. The minimum value is assigned to the variable min value. In this case, the minimum value in L1 is minus 9, hence, it prints the value of min value as minus 9. You can check the output on the console. Example 2, list 1 equals uppercase B, lowercase e, uppercase e. This line initializes a list called list 1 with 4 strings. In the second line, the min function is called on list 1 to find the minimum value in the list. Since the elements of list 1 are strings, the minimum value is determined based on the ASCII code values, lexicographic order, that is, alphabetical order. In this case, the minimum value in list 1 is $, so it prints the value of min value as $. Example 3, list 1 equals Mac, Mark, Mary, Malvin. This line initializes a list called list 1 with 4 strings. The second line, min value equals min of list 1, the min function is called on list 1 to find the minimum value in the list. Since the elements of list 1 are strings, the minimum value is determined based on the ASCII code values, lexicographic order, that is, alphabetical order. The min function compares the strings element by element until a difference is found. In this case, Mac comes first alphabetically compared to Mark, Mary, and Malvin. Therefore, Mac will be considered the minimum value in the list and prints the value of min value as Mac. Lists in Python, Part 4. In this video, we are going to discuss about sorting, bubble sort, insertion sort, and practical implementation. So let's dive in and get started. Let's discuss about sorting. Sorting is to arrange the list in an ascending or descending order. Sorting algorithms specifies the way to arrange data in a particular order. The importance of sorting lies in the fact that data searching can be optimized to a very high level if data is stored in a sorted manner. Sorting is also used to represent data in more readable formats. There are various sorting techniques that can be used to sort the list in ascending or descending order. Let's discuss about 2 techniques: bubble sort and insertion sort. Let's learn about bubble sort. Bubble sort is one of the simplest sorting techniques where it traverses the whole list by comparing its adjacent elements, sorting them and swapping the elements until the whole list is sorted. In simple words, bubble sort is a simple sorting algorithm that repeatedly steps through a list, compares adjacent elements, and swaps them if they are in the wrong order. The pass through the list is repeated until the list is sorted. How does bubble sort work? Let's see an example. Example 1. Sorting in ascending order using bubble sort. Suppose an array of elements of a list is 75, 30, 95, 80, 10 are given as input by the user. Let us understand the working of bubble sort with the help of the following illustration. The elements in the list are given in this box. In bubble sort algorithm in Python, the first pass refers to the initial iteration over the list that is being sorted. Bubble sort works by repeatedly swapping adjacent elements if they are in the wrong order. In each pass, the largest element bubbles up to its correct position at the end of the list. After the first pass, the largest element will be at the end of the list. During the first pass, the algorithm compares each pair of adjacent elements from the beginning of the list and swaps them if they are in the wrong order. This process continues until it reaches the end of the list. Now, come on, let's look at the first pass on the screen. The first pass refers to the initial iteration over the list that is being sorted. Now look at step 1. Bubble sort starts by comparing the first 2 elements in the list. Here the first element 75 is compared with the second element 30. It will swap since 30 is less than 75. Swap refers to the exchange or interchange of values between two variables or elements. Here values 75 and 30 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 75 is on the second position. So the numbers displayed are 30, 75, 95, 80, 10. Now come to step 2. Now, the second element 75 is compared with the third element 95. Here, no swapping is done, as 75 is less than 95. So, now look at the right side box, the numbers displayed are 30, 75, 95, 80, 10. Now come to step 3. Now the third element, 95, is compared with the fourth element 80. It will swap since 80 is less than 95. Here values 95 and 80 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 95 is on the fourth position. So the numbers displayed are 30, 75, 80, 95, 10. Now come to step 4. Now the fourth element 95 is compared with the fifth element 10. It will swap, since 10 is less than 95. Here values 95 and 10 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 95 is on the last position. So the numbers displayed are 30, 75, 80, 10, 95. The largest element, 95, is settled at its correct place, that is, at the end. I have highlighted 95 in blue color. So the first four elements 30, 75, 80, 10 form the unsorted part while the last element 95 forms the sorted part and will be compared for the next pass. In the bubble sort algorithm in Python, the term second pass refers to the second iteration or traversal of the list during the sorting process. After completing the first pass, the largest element, 95, is in its correct position at the end of the list. However, there may still be other elements 30, 75, 80, 10 out of order. So, a second pass is performed to repeat the process, but this time excluding the last element, 95, since it is already in its correct position. Now, look at step 1 of second pass. Bubble sort starts by comparing the first two elements in the list. Here the first element 30 is compared with the second element 75. Here, no swapping is done, as 30 is less than 75. So, now look at the right side box, the numbers displayed are 30, 75, 80, 10, 95. Now come to step 2. Here the second element 75 is compared with the third element 80. Here also, no swapping is done, as 75 is less than 80. So, now look at the right side box, the numbers displayed are 30, 75, 80, 10, 95. Now come to step 3. Here the third element 80 is compared with the fourth element 10. It will swap since 10 is less than 80. Here values 80 and 10 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 80 is on the second position from the end. So the numbers displayed are 30, 75, 10, 80, 95. The next largest element 80 is settled at its correct place. I have highlighted both 80 and 95 in blue color. So the first three elements 30, 75, 10 form the unsorted part while the last two elements 80 and 95 forms the sorted part and will be compared for the next pass. In the bubble sort algorithm in Python, the term third pass refers to the third iteration or traversal of the list during the sorting process. After completing the second pass, the largest element, 80 and 95, are in its correct position at the end of the list. However, there may still be other elements 30, 75, 10 out of order. So, a third pass is performed to repeat the process, but this time excluding the last two elements, 80 and 95, since both are already in its correct position. Now, look at step 1 of third pass. Bubble sort starts by comparing the first two elements in the list. Here the first element 30 is compared with the second element 75. Here, no swapping is done, as 30 is less than 75. So, now look at the right side box, the numbers displayed are 30, 75, 10, 80, 95. Now come to step 2. Here the second element 75 is compared with the third element 10. It will swap since 10 is less than 75. Here values 75 and 10 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 75 is on the third position from the end. So the numbers displayed are 30, 10, 75, 80, 95. The next largest element, 75, is settled at its correct place. I have highlighted the three numbers 75, 80, and 95 in blue color. So the first two elements 30, 10, form the unsorted part while the last three elements 75, 80, and 95 forms the sorted part and will be compared for the next pass. In the bubble sort algorithm in Python, The term fourth pass refers to the fourth iteration or traversal of the list during the sorting process. After completing the third pass, the largest elements, 75, 80 and 95, are in its correct position at the end of the list. However, there may still be other elements 30 and 10 out of order. So, a fourth pass is performed to repeat the process, but this time excluding the last three elements, 75, 80 and 95, since all these three elements are already in its correct position. Now, look at step 1 of fourth pass. Bubble sort starts by comparing the first two elements in the list. Here the first element 30 is compared with the second element 10. Here, it will swap since 10 is less than 30. So, now look at the right side box, the numbers displayed are 10, 30, 75, 80, 95. The next largest element, 30 is settled at its correct place. I have highlighted the four numbers 30, 75, 80 and 95 in blue color. And finally the list is sorted. Here, the total number of items is 5, so outer loop will be executed n-1 times. That is, 4 times. There will be 4 passes through the list. Let's see the steps of bubble sort. Let's see how it works. Step 1. Get the total number of items or elements in the given list. Step 2. Determine the number of outer passes, n-1, to be done. Its length is list -1. Step 3. Perform inner passes, n-1, times for outer pass 1. Get the first element value and compare it with the second value. If the second value is less than the first value, then swap the positions. Step 4. Repeat step 3 passes until you reach the outer pass, n-1. Get the next element in the list, then repeat the process that was performed in step 3 until all the values have been placed in their correct ascending order. Step 5. Return the result when all passes have been done. Return the results of the sorted list. Step 6. Optimize algorithm. Avoid unnecessary inner passes if the list or adjacent values are already sorted. For example, if the provided list already contains elements that have been sorted in ascending order, then we can break the loop early. Let's see an example for bubble sort. Now, look at the red arrow. In this example, the input list, 5, 2, 9, 1, 6, is passed to the bubble_sort function. The function then performs the bubble sort algorithm on the list. Now, look at the for loop iteration. The outer loop iterates from I equals 0 to n-1, where n is the length of the list. This controls the number of passes performed. In each pass, the inner loop iterates from j equals 0 to n-i-1, comparing adjacent elements and swapping them if they are in the wrong order. After completing the sorting process, the sorted list is returned from the function using return ARR. Finally, the sorted list, 1, 2, 5, 6, 9, is printed as the output. This demonstrates the usage of the bubble sort algorithm to sort a list of numbers in ascending order. Let's see the detailed explanation in the next screen. Let's see the algorithm of bubble sort. Let's see how it works. Step 1. Start with an input list of elements to be sorted. Step 2. Get the length of the list and assign it to the variable n. Step 3. Iterate through the list using an outer loop from index 0 to n-1. Within the outer loop, use an inner loop to iterate from index 0 to n-i-1. Compare the element at the current index with the element at the next index. If the current element is greater than the next element, swap them. Step 4. Return the sorted list. Let's see how it works. First, create an input list of elements, 5, 2, 9, 1, 6. Then, call the bubble_sort function with the input list. The function performs the following iterations. Pass 1. Compare 5 and 2. Swap them. Compare 5 and 9. No swap. Compare 9 and 1. Swap them. Compare 9 and 6. Swap them. The list after pass 1 is 2, 5, 1, 6, 9. Next iteration, pass 2. Compare 2 and 5. No swap. Compare 5 and 1. Swap them. Compare 5 and 6. No swap. The list after pass 2 is 2, 1, 5, 6, 9. Next iteration, pass 3. Compare 2 and 1. Swap them. Compare 2 and 5. No swap. The list after pass 3 is 1, 2, 5, 6, 9. Next iteration, pass 4. Compare 1 and 2. No swap. The list after pass 4 is 1, 2, 5, 6, 9. Now, return the sorted list 1, 2, 5, 6, 9. Let's discuss about insertion sort. An insertion sort is an efficient algorithm for sorting a small number of elements. In insertion pass, for each pass, the correct position for the current element is found by comparing adjacent elements before the current position and sliding larger elements up until an element less than the current element is found. Let's see some examples where insertion sort is used. Example 1. Insertion sort works the same way as sorting a hand of playing cards, that is, starting with an empty left hand and the cards face down on the table. One card at a time is then removed from the table and inserted into the correct position in the left hand. To find the correct position for a card, it is compared with each of the cards already in the hand, from right to left. Example 2. To sort the report card of n number of students according to the roll number. Let's see how insertion sort works. Example 1. Sorting in ascending order using insertion sort. A list containing an array of elements, 55, 30, 10, 82, 45 are given by the user, which is the initial list. Let us understand the working of insertion sort with the help of the following illustration. The insertion sort algorithm works by considering one element at a time and inserting it into its correct position within the already sorted subarray. In insertion sort algorithm in Python, the first pass refers to the initial iteration over the list that is being sorted. Now, come on, let's look at the first pass on the screen. The first pass refers to the initial iteration over the list that is being sorted. Now look at step 1. Here, the key element is 30. Insertion sort starts by comparing the first two elements in the list. Here the first element 55 is compared with the second element 30. It will swap since 30 is less than 55. Swap refers to the exchange or interchange of values between two variables or elements. Here values 55 and 30 are swapped, that is, exchanged. Now you can see on the right side box. Here the greater value 55 is on the second position. So the numbers displayed are 30, 55, 10, 82, 45. As the elements haven't reached the proper position in the sorted manner, the second pass continues. In the insertion sort algorithm in Python, the term second pass refers to the second iteration or traversal of the list during the sorting process. Now, look at step 1 of second pass. Here, the key element is 10. Insertion sort starts by comparing the second and third elements in the list. Here the second element 55 is compared with the third element 10. It will swap, since 10 is less than 55. So, now look at the right side box, the elements displayed are 30, 10, 55, 82, 45. Now come to step 2. As 10 is smaller element than 30, element 10 has not found its right position. Hence, the first element 30 is compared with the second element 10. Here swapping is done, since 10 is less than 30. So, now look at the right side box, the elements displayed are 10, 30, 55, 82, 45. Here, elements 10 and 30 have reached the proper position in the sorted subarray on the left. As the other elements haven't reached the proper position in the sorted manner, the third pass continues. In the insertion sort algorithm in Python, the term third pass refers to the third iteration or traversal of the list during the sorting process. Now, look at step 1 of third pass. Here, the key element is 82. The third element 55 is compared with the fourth element 82. No swapping is done, as 55 is less than 82. So, now look at the right side box, the elements displayed are 10, 30, 55, 82, 45. As the elements 55, 82 and 45 haven't reached the proper position in the sorted manner, the fourth pass continues. In the insertion sort algorithm in Python, the term fourth pass refers to the fourth iteration or traversal of the list during the sorting process. Now, look at step 1 of fourth pass. Here, the key element is 45. The fourth element 82 is compared with the fifth element 45. Here, swapping is done, since 45 is less than 82. So, now look at the right side box, the elements displayed are 10, 30, 55, 45, 82. Now look at step 2. Here the key element is 45. The third element 55 is compared with fourth element 45. It will swap, since 45 is less than 55. So, now look at the right side box, the elements displayed are 10, 30, 45, 55, 82. Now the list is sorted. The total number of items, say n, is 5, so outer loop will be executed n-1 times, that is 4 times. So there will be 4 passes through the list. For each pass, it not only compares adjacent items and swaps, but also slides up each larger element until it gets to the correct location in the sorted part of the array. Let's see the steps for insertion sort. Step 1. If the element is the first one, it is already sorted. Step 2. Move to the next element of the list. Step 3. Compare the current element with all elements in the sorted list. Step 4. If the element in the sorted list is smaller than the current element, iterate to the next element. Otherwise, shift all the greater element in the list by one position towards the right. Step 5. Insert the value at the correct position. Step 6. Repeat until the complete list is sorted. Let's see an example for insertion sort. Now, look at the first white box. The code defines a function insertion_sort that takes an input list ARR and sorts it in ascending order using the insertion sort algorithm. In the insertion_sort function, we iterate through the elements starting from the second element, index 1, to the end of the list. For each element, we assign it to the variable key and set the variable j to the index of the element before it. Now, look at the second white box. We then enter a while loop that compares the element at index j with the key value. If the element at index j is greater than the key, we shift it one position to the right. We continue this process until we find the correct position for the key element or reach the beginning of the list. Finally, we insert the key value at the correct position and move to the next element in the iteration. After the sorting process is complete, the sorted list is returned. Now look at the red arrow. In this example usage, we have a list 8, 3, 1, 5, 2 that we want to sort. We call the insertion_sort function with this list, and the sorted list 1, 2, 3, 5, 8 is printed as the output. Let's see the algorithm and how it works. Step 1. Start with an input list of elements to be sorted. Step 2. Iterate through the list starting from the second element. Assign the current element to the variable key. Set the variable j to the index of the element before the current element. While j is greater than or equal to 0 and the element at index j is greater than the key, shift the element at index j one position to the right. Decrement j by 1. Insert the key at index j plus 1. Step 3. Return the sorted list. Let's see how it works. First, create an input list 8, 3, 1, 5, 2. Then, call the insertion_sort function with the input list. Next, the function iterates through the list as follows. When key equals 3, j equals 0, the list becomes 3, 8, 1, 5, 2. When key equals 1, j equals 1, the list becomes 1, 3, 8, 5, 2. When key equals 5, j equals 2, the list becomes 1, 3, 5, 8, 2. When key equals 2, j equals 3, the list becomes 1, 2, 3, 5, 8. Now, return the sorted list 1, 2, 3, 5, 8. Tuples in Python, Part 1. In this video, we are going to discuss about introduction to tuples, tuple creation, nesting of tuples, accessing and traversing a tuple, and practical implementation. So let's dive in and get started. Let's learn about tuples in Python. What do you mean by the term data structure? A data structure is an efficient way to organize and store data or information. We have learned that lists are data structures that store related data items. Now, we are going to discuss on another Python sequence, tuples. Tuple is a data structure in Python that allows you to store multiple values together as a single entity. It is another sequence data type that is similar to the list. It is an ordered collection of elements. It consists of multiple values in a single variable separated by commas and enclosed within parentheses. Example. Open parentheses, red comma blue comma green close parentheses. The values that make up a tuple are called elements. Tuples allow duplicate values. Tuples are heterogeneous, that means, tuples can contain elements of different data types. For example, a tuple can have a mix of integers, strings, floats, or other data types. The syntax of tuple is, tuple_name or variable name equals open parentheses, value 1 comma value 2 comma up to value n, close parentheses. For example, fruits equals apple, strawberry, grapes. In this example, we have a tuple named fruits, with 3 elements, as apple, strawberry and grapes. The elements in a tuple are addressed using their index value. The index value of tuple starts with 0. The main difference between lists and tuples are lists are enclosed in square brackets and their elements and size can be changed, while tuples are enclosed within parentheses and cannot be updated. Tuples are thought of as read-only lists. Let's see some examples. Example 1. Variable tup1 holds a tuple with elements of different data types, a string, an integer, a float, and another integer and printed. Output is a tuple holding Sally bytes, 20, 40.05, 250. Example 2. Variable tup2 holds an empty tuple is printed. Output is empty tuple. Example 3. Variable tup3 holds, a tuple defined without using parentheses, with 4 integer elements and printed. Output is a tuple holding elements 20, 40, 60, 80. Example 4. A variable tup4 holds, a nested tuple containing 2 tuples as its elements and printed. Output is a nested tuple inside a tuple holding elements 10, 20, 30, 40, 50, 100, 150, 200. Example 5. A variable tup5 holds, a nested tuple with a tuple and a list as its elements and printed. Output is a nested tuple holding a tuple and a list 20, 40, 60, 80, tuples in Python. Example 6. A variable tup6 holds, a tuple containing 2 lists as its elements and printed. Output is tuple holding 2 lists 2, 4, 6, 1, 3, 5. Each tuple is printed to show its contents. Note that each output is enclosed within parentheses as it represents a tuple. Let's learn about singleton tuple. When creating a tuple with a single item in Python, you need to include a trailing comma after the item to differentiate a tuple from a parenthesized expression. Example, my_tuple equals 42. In this example, my_tuple is a tuple with a single item, the integer 42. The trailing comma after the item distinguishes it as a tuple. Without the comma, it would be interpreted as just an integer value. It's important to note that if you don't include the trailing comma, Python will treat the item as the data type itself, rather than a tuple containing that item. Let's see some examples. Example 1. In this example, my_tuple is defined as a tuple with a single item, the integer 42. The trailing comma after the item ensures that it is recognized as a tuple. When printed, the output shows 42, indicating a tuple containing the value 42. Example 2. In this example, my_tuple is assigned a single value, the integer 42. However, since there is no trailing comma, Python interprets it as an integer rather than a tuple. When printed, the output is simply 42, representing the value of the integer itself. You can check the output and find the difference. Tuples are immutable, that is, we cannot change the elements of a tuple in place. We cannot perform insert, update, and delete operations on them. An attempt to modify an element of a tuple yields an error. Let's see some examples. Example 1. In this code, we first define a tuple called my_tuple with 3 elements, 1, 2, and 3. The elements are enclosed in parentheses and separated by commas. This tuple is assigned to the variable my_tuple. Then, we use the print function to display the value of my_tuple on the console. So the output is a tuple holding 1, 2, 3. Example 2. In this example, my_tuple is initially defined as a tuple containing the values 1, 2, and 3. When we attempt to modify the value at index 0 by assigning a new value, 10 in this case, a type error is raised. This error occurs because tuples are immutable, meaning their elements cannot be changed once they are created. The immutability of tuples ensures that their values remain constant throughout their lifetime. If you need to modify a collection of elements, you would typically use a mutable data structure like a list instead. Let's see how to create a tuple. To create a tuple in Python, you can use parentheses, that is, round brackets, and separate the elements with commas. Round brackets indicate the start and end of the tuple. Syntax is tuple_name or variable name equals value 1, value 2, up to value n. Let's see an example of a tuple with mixed data types. A variable tup1 holds the tuple containing a string, integer, and float values and printed. So the output will be a tuple holding the elements pen, 10, 50.0, enclosed within parentheses and separated by commas. Let's see how to create a tuple using built-in function tuple. An empty tuple can be created using tuple function. In this example, the tuple function is used without any arguments to create an empty tuple. The empty_tuple variable is assigned the result of the tuple function, which is an empty tuple. When we print empty_tuple, the output is an empty pair of parentheses, indicating that it is indeed an empty tuple. Note that you can also create an empty tuple using empty parentheses directly, like this, empty_tuple equals empty pair of parentheses. Let's see how to create tuple containing string values using built-in function tuple. Let's see some examples. Example 1. In this example, tup1 is created by passing the string computer to the tuple function with a trailing comma. The tuple function treats the string as an iterable and creates a tuple where each character becomes an element of the tuple. When printf tup1 is executed, it outputs computer, which represents the tuple containing individual characters from the string. The type of tup1 statement returns class tuple, confirming that tup1 is indeed a tuple. Example 2. In this example, tup2 is created by passing a tuple, red, blue, green, directly to the tuple function. The tuple function accepts an iterable as an argument and creates a new tuple with the elements from that iterable. In this case, the original tuple, red, blue, green, is already a tuple, so it is returned as it is. When printf tup2 is executed, it outputs red, blue, green, representing the tuple with 3 elements. The type of tup2 statement returns class tuple, confirming that tup2 is indeed a tuple. Both tup1 and tup2 are tuples, but the way they are created differs. Tup1 is created by passing a string to the tuple function, while tup2 is created by passing a tuple to the tuple function. Let's see how to create a tuple with a single element. To create a tuple with a single element, you have to include the final comma. The final comma after single value is mandatory, otherwise it is not considered as tuple, rather treated as a character or a string or an integer. Example 1. In this example, tup1 is defined as a tuple with a single element, the string bytes. The trailing comma after the string ensures that it is recognized as a tuple. When type of tup1 is executed, it returns class tuple, confirming that tup1 is indeed a tuple. Example 2. In this example, tup2 is assigned the string bytes without the trailing comma. Without the comma, Python interprets it as a string rather than a tuple. Therefore, when type of tup2 is executed, it returns class str, indicating that tup2 is of type string. To create a tuple with a single element, it is important to include the trailing comma, even if there is only one item. This is to differentiate it from other parentheses-based constructs and ensure that it is recognized as a tuple. Let's see how to create tuple by accepting user input using while loop. Example 1. Line 1. Here, you initialize an empty tuple named tup using the tuple function. This creates an empty tuple with no elements. Line 2. This line prompts the user to enter the number of elements they want in the tuple. The input function accepts user input as a string, and int is used to convert it into an integer. Line 3. This line initializes a counter variable I to keep track of the number of elements entered. Line 4. This starts a while loop that will iterate as long as I is less than or equal to n, which represents the desired number of elements. Line 5. Inside the loop, the program prompts the user to enter a number for the tuple. The input function is used to accept user input, and the entered value is assigned to the variable a. Note that the input is treated as a string. The input function always returns a string. Line 6. The entered value, a, is appended to the tuple tup using the plus operator. The comma after a ensures that it is recognized as a tuple with a single element. The result of the concatenation is assigned back to tup, updating the tuple. Line 7. After appending the element to the tuple, the counter I is increment by 1 to move to the next iteration. The loop continues until I reaches n plus 1, meaning the desired number of elements have been entered. Finally, after the loop completes, the program prints a message tuple created and then displays the created tuple by printing the variable tup. Now, look at the output. User enters 3 elements, 20, 40, 60. The tuple created is a tuple holding strings 20, 40, 60. Let's discuss about the nesting of tuples. Nesting of tuples refers to the concept of having tuples as elements within another tuple. In other words, a tuple can contain other tuples as its elements, creating a nested structure. Let's see an example. In this example, tup1 and tup2 are 2 individual tuples. Then, a new tuple tup3 is created with tup1 and tup2 as its elements. So, tup3 becomes a tuple that contains 2 nested tuples. The output shows that tup3 is 1, 2, 3, A, B, C, indicating that tup3 has 2 elements, where each element is a tuple. The first element is the tuple 1, 2, 3, and the second element is the tuple A, B, C. Nesting of tuples allows us to organize and represent complex data structures within a tuple. It provides a way to group related data together and create hierarchical structures. You can access the elements of nested tuples using indexing or slicing, just like with regular tuples. Let's see an example. Write a Python code to create a nested tuple to store roll number, name, and marks of students. Now, look at the Python code. Line 1. In this line, a nested tuple stud is defined, containing student information. Each nested tuple represents the information of a single student, consisting of 3 elements, roll number, name, and marks. Line 2. This line prints the column headers for the student details table, including serial number, roll number, name, and marks. The values are separated by tabs, \t, to align them in a formatted manner. Line 3. This line starts the for loop that iterates over the range of indices from 0 to the length of the stud tuple. This loop will iterate for each nested tuple in stud. Line 4. Inside the loop, this line prints the student details for each nested tuple. I+1 represents the serial number, which is obtained by adding 1 to the loop index I. Stud of I of 0 accesses the roll number of the student in the current nested tuple. Stud of I of 1 accesses the name of the student. Stud of I of 2 accesses the marks of the student. The elements are separated by tabs, \T, to align them in a formatted manner. This output displays the student details in a tabular format, with each student's information on a separate line. The columns include the serial number, roll number, name, and marks. You can check the output on the console. Let's learn about accessing and traversing a tuple. A tuple is a sequence of values which can be of any data type and they are indexed by integer. Accessing elements by index. Individual elements of a tuple can be accessed by using square brackets and the index of the element to be accessed. The index starts from 0 for the first element and goes up to len of tuple -1 for the last element. Accessing elements using negative indexing. Python also supports negative indexing, where -1 refers to the last element, -2 refers to the second last element, and so on. You can look at the picture. A tuple holds elements 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Elements of a tuple can be accessed using an indexing method. The individual elements of a tuple can be accessed through their indexes given in square brackets. Tuple indices start at 0. The tuple index must be a positive or negative integer value or an expression which evaluates to an integer value. Positive value of index means counting forward from beginning of the tuple. And negative value means counting backward from end of the tuple. Let's see some examples. Example 1 on the first white box. Accessing elements by index. You can access individual elements of a tuple using square brackets and the index of the element you want to access. The index starts from 0 for the first element and goes up to len of tuple -1 for the last element. In this example, we access the first element of my_tuple using my_tuple of 0, the output will be 10, and the third element using my_tuple of 2, the output will be 30. Example 2 on the second white box. Python also supports negative indexing, where -1 refers to the last element, -2 refers to the second last element, and so on. This can be useful when you want to access elements from the end of the tuple. In this example, we access the last element of my_tuple using -1, output displayed is 50, and the third last element using -3, the output displayed is 30. Example 3 on the third white box. Traversing elements using a for loop to iterate over the elements of a tuple, you can use the for loop. The loop variable will take each element of the tuple one by one, allowing you to perform operations on them. This loop will iterate over each element of the tuple my_tuple and print them on separate lines. So the output will be 10, 20, 30, 40, 50 on separate lines. Example 4 on the fourth white box. If you know the number of elements in the tuple and want to assign them to separate variables, you can use tuple unpacking. Assigning variables in this way allows you to access individual elements easily. Here, we have unpacked the elements of my_tuple into variables A, B, and C. Now, we can use these variables to access individual elements of the tuple. So the output displayed will be 10, 20, 30. Let's see some more examples. In this code, we have a tuple my_tuple with 5 elements. We use the len function to get the length of the tuple, which is the number of elements in it. In the first part, we use the range function with len of my_tuple to generate a sequence of indices from 0 to len of my_tuple -1. Then, we iterate over these indices using the for loop and print the corresponding element from the tuple. The output displayed will be 10, 20, 30, 40, 50, printed on separate line. In the second part, we use a while loop with an index variable starting from 0. We print the element at the current index and increment the index by 1 in each iteration. The loop continues until the index reaches the length of the tuple. The output displayed will be 10, 20, 30, 40, 50, printed on separate line. Both approaches will traverse the tuple and print each element on a separate line. Tuples in Python, Part 2. In this video, we are going to discuss about tuple operations, tuple slicing, tuple concatenation, tuple replication, membership operator in and not in, comparing tuples, deleting tuples, tuple functions, packing and unpacking tuples, features, advantages and disadvantages of tuples and practical implementation. So let's dive in and get started. In Python, a tuple is an immutable sequence of elements, enclosed in parentheses. Tuples are similar to lists, but unlike lists, tuples cannot be modified once they are created. However, you can perform various operations on tuples to manipulate and access their elements. Here are some common tuple operations in Python. Tuple slicing, tuple concatenation, tuple replication, membership operators. Let's see one by one in detail. Tuple slicing is a technique used to extract a portion of a tuple by specifying a range of indices. It allows you to create a new tuple that contains a subset of elements from the original tuple. A slice of a tuple is basically its subtuple. In Python, tuple slicing is done using the square bracket notation. Here's the syntax for tuple slicing. Tuple underscore name of open square brackets, start, stop, step, close square brackets. Here, start is the starting point. Stop is the stopping point, which is excluded. Step is the step size, also known as stride. Some key points to remember. If start value is not given, slice starts from index 0. If stop value is not given, it will take it to the end. If step value is not given, default value is taken as 1. It includes the first element but excludes the last element. The first value in a tuple is at index 0. You can use the index values in combination with square brackets to access items in a tuple. Now, look at the picture, how tuple slicing is done. Tuple slicing is a technique used to extract a portion of a tuple by specifying a range of indices. It allows you to create a new tuple that contains a subset of elements from the original tuple. In this picture, if we consider the positive index, that is forward indexing, index 3, 4, 5 are sliced and a new tuple with elements 40, 50 and 60 are formed. If we consider the negative index of step 1, that is backward indexing, it means to increment the index every time by -1, meaning it will traverse the list by going backwards. Now look at the negative index. Index -5, -6, -7 are sliced and a new tuple with elements 60, 50 and 40 are formed in backward direction. Let's see some examples. Example 1. A tuple with elements of different data types are given. Now look at the top picture. Here, I have marked the positive indexing and negative indexing for this tuple. In positive indexing means forward direction, look at the green arrow in forward direction and follow with me. Index 0 holds a string apple, index 1 holds the integer value 1, index 2 holds a list holding elements 2, 3, 4. Index 3 holds a nested tuple containing 2 strings banana and orange. Index 4 holds a float value 5.5. Now, let's learn the negative indexing that means backward direction. Look at the red arrow in backward direction and follow with me. Index -1 holds the value 5.5, index -2 holds the nested tuple holding 2 strings banana and orange, index -3 holds the list containing 3 elements 2, 3, and 4, index -4 holds the integer value 1, and index -5 holds the string apple. Now, look at example 1, second line. We use tuple slicing to extract a slice from index 2 to index 3, exclusive. The slice, 2:3, includes the element at index 2 but excludes the element at index 3. Since slicing returns a new tuple, the resulting slice is printed as a tuple containing the list 2, 3, 4. I have given a detailed explanation below. Just pause the video and recall the start, stop and step value, with the above indexing picture of the tuple given. Now we can work out more examples with the same tuple given. Example 1. Here, we extract a slice from index 1 to index 2, exclusive, using tuple slicing. Now, look at the positive indexing in the picture. That is forward direction. The slice, 1:2, includes the element at index 1 but excludes the element at index 2. Thus, the resulting slice is printed as a tuple containing the integer 1. You can check the output on the console. Now, look at example 2. In this example, we utilize negative indices to slice the tuple. Now look at the negative index on the above picture that is backward direction. The slice, -5:-3, starts from the element at the 5th position from the end, inclusive, and ends at the element at the 3rd position from the end, exclusive. Therefore, the resulting slice is printed as a tuple containing the string apple and the integer 1. Now look at example 3. The slice tup1 of -8:-6. In the example, the index given are out of range and result in an empty tuple. Example 4, given below. Print tup1 of -3, -5, -1. The output will be a tuple holding the list 2, 3, 4, and the integer value 1. This will output a slice of the tuple tup1 starting from the index -3 and ending at the index -5, exclusive, with a step of -1. The result will be a new tuple with the elements the list 2, 3, 4, and the integer value 1, printed in reverse order. You can check the above picture for reference. Let's see some mode examples. Example 1. In this step, we use tuple slicing to extract a slice from index 0 to index 10 exclusive, with a step of 2. Now, look at the picture. The slice 0:10:2 includes elements starting from index 0 and up to index 10 exclusive, in steps of 2. Thus, the resulting slice is printed as a tuple containing the element 5 at index 0, element 15 at index 2, element 25 at index 4, element 35 at index 6, and element 45 at index 8. You can check the output on the console. Now look at example 2. Here, we extract a slice from index 1 to index 10 exclusive, with a step of 3. Now look at the second picture. The slice 1:10:3 includes elements starting from index 1 and up to index 10 exclusive, in steps of 3. Therefore, the resulting slice is printed as a tuple containing the element 10 at index 1, element 25 at index 4, and element 40 at index 7. You can check the output on the console. Example 3. In this example, we use tuple slicing with a step of 3 to extract elements from the beginning to the end of the tuple. Now, look at the picture. The slice, 3, includes elements starting from index 0 and up to the end of the tuple in steps of 3. Hence, the resulting slice is printed as a tuple containing the element 5 at indices 0, element 20 at index 3, and element 35 at index 6. You can check the output on the console. Now, look at example 4. In this example, we use tuple slicing with a step of 2 to extract elements from index 4 to the end of the tuple. Now, look at the second picture. The slice, for 2, includes elements starting from index 4 and up to the end of the tuple in steps of 2. Therefore, the resulting slice is printed as a tuple containing the element 25 at index 4, element 35 at index 6, and element 45 at index 8. You can check the output on the console. Let's learn about tuple concatenation. Tuples can be concatenated or joined using the plus operator. For example, tuple 1 plus tuple 2 creates a new tuple by combining elements from tuple 1 and tuple 2. In Python, tuples are immutable, which means they cannot be modified once created. Therefore, when you want to concatenate tuples, you create a new tuple that contains the elements of the original tuples. Now, let's see an example. Example 1. Tuple 1 contains the elements 1, 2, 3, and tuple 2 contains the elements 4, 5, 6. The line concatenated underscore tuple equals tuple 1 plus tuple 2 performs tuple concatenation. It uses the plus operator to combine the elements of tuple 1 and tuple 2 into a new tuple called concatenated underscore tuple. So the output printed is a new tuple holding elements 1, 2, 3, 4, 5, 6. Let's work out some more examples. Example 1. Variable tuple 1 holds the elements 10, 20, 30, 40. The second line, print tuple 1 of 1:3 plus 50, 60. This line retrieves a slice of tuple 1 from index 1 to index 3, exclusive, which returns 20, 30. You can check the above picture for reference. Then, it concatenates, that is joins this slice 20, 30 with the tuple 50, 60 using the plus operator. The resulting tuple is printed as 20, 30, 50, 60. You can check the output on the console. Example 2. Print tuple 1 of 1:3 plus a tuple 1 of 0, This code retrieves the slice 20, 30 from tuple 1 and concatenates it with a tuple holding tuple 1 of 0, Here, tuple 1 of 0, creates a tuple with a single element, which is the first element of tuple 1 of 10. The resulting tuple is printed as 20 of 30, 10, which is outputted on the console. Example 3. Print tuple 1 of 1:3 plus tuple 1 of 0. In this example, the code attempts to concatenate the slice 20 of 30 with tuple 1 of 0, which is the first element of tuple 1 of 10. However, there is an error in the code. The plus operator for concatenation expects a tuple on both sides. When you use tuple 1 of 0, it is a single element, integer, not a tuple. So, it results in type error. Let's learn about tuple replication. To replicate a tuple in Python, you can use the multiplication operator, asterisk. Let's see some examples. Example 1. We define a tuple my_tuple containing the elements 1, 2, 3. We create a new tuple replicated tuple by multiplying my_tuple by 3. This replicates the elements of my_tuple 3 times. We print the replicated tuple, which outputs 1, 2, 3, 1, 2, 3, 1, 2, 3. Example 2. We define a tuple my_tuple containing the element hello, Note that the comma after the element is necessary to indicate that it is a tuple. We create a new tuple replicated tuple by multiplying my_tuple by 3. This replicates the element of my_tuple 3 times. We print the replicated underscore tuple, which outputs hello, hello, hello. Example 3. We define a tuple my underscore tuple containing the elements 1, 2, 3, 4. We access a slice of my underscore tuple using the indices 1 and 3, exclusive. This returns a new tuple containing the elements 2, 3. We multiply the sliced tuple by 3, replicating the elements 2, 3, 3 times. We print the replicated tuple, which outputs 2, 3, 2, 3, 2, 3. Note that in all the 3 examples, the original tuples are not modified, and the multiplication operator creates new tuples or strings with a replicated content. Also remember, asterisk operator requires a tuple and an integer as operands. Let's discuss about the membership operators in and not in. In Python, the membership operators in and not in can be used to check if an element is present or not present in a tuple. These operators return a Boolean value indicating the result of the membership test. Let's see some examples. Example 1. In this example, we have a tuple called fruits containing 3 elements, apple, banana, and orange. We use the in operator to check if apple is present in the fruits tuple, and it returns true because apple is indeed present. Example 2, when we check 4 grapes, which is not in the fruits tuple, the in operator returns false. Example 3. Similarly, we use the not in operator to check if apple is not present in the fruits tuple, and it returns false because apple is present. Example 4, when we check 4 grapes, which is not in the fruits tuple, the not in operator returns true. The in and not in operators can be used with tuples, lists, sets, and other iterable objects in Python to perform membership tests. Tuples in Python support several built-in functions that can be used to perform various operations. Here are some commonly used built-in functions that work with tuples: len, count, any, min, max, sum, sorted, index. Let's see one by one in detail. Len function returns the length or the number of elements in a tuple. It counts the total number of elements in a tuple. Let's see some examples. Example 1. The tuple tup1 contains 6 elements, so the len function returns 6. Example 2. The tuple tup1 contains 5 elements, including a nested tuple. The len function counts the nested tuple as a single element, so it returns 5. Example 3. The tuple tup1 contains 4 elements, including an integer, a string, a float, and a list. The len function returns 4. The count function returns the number of occurrences of a specified element within the data type. Let's see some examples. Example 1. In this example, the count function is used to find the number of occurrences of the element 2 in the my underscore tuple. The function returns 3 because 2 appears 3 times in the tuple. Example 2. Here, the count function is used to count the occurrences of a specific tuple 1, 2. In this example, the count is indeed 3 because tuple 1, 2 appears 3 times in my underscore tuple. In Python, the any function is a built-in function that can be used with various data types, including tuples. The any function returns true if at least one element in the iterable is considered true and false otherwise. Example 1. In this example, the any function is applied to the tuple my underscore tuple. The elements of my underscore tuple include 0, empty space, false, an empty list, and none. Since all of these values are considered as falsy in Python, the any function returns false. Example 2. In this example, the tuple my underscore tuple contains an additional element, 42, which is considered as truthy. As a result, the any function returns true. You can use the any function with tuples or any other iterable to check if any element evaluates to true. If at least one element is true, any returns true. If all elements are false or falsy, it returns false. Let's learn about the min and max function in tuple. Min function shall return the element with minimum value from the tuple. Max function shall return the element with maximum value of the tuple. To use the min and max function, all values in the tuple must be of same type. Let's see some examples. Example 1. The first line creates a tuple called my underscore tuple with elements 5, 3, 8, 2, 1. It consists of numeric values. The next line uses the min function to find the minimum value from the my underscore tuple. The smallest value in the tuple is 1, so minimum is assigned the value 1. The following line prints the message the minimum value is 1, using the print function to display the minimum value. Example 2. Next, the code uses the max function to find the maximum value from the my underscore tuple. The largest value in the tuple is 8, so maximum is assigned the value 8. The subsequent line prints the message the maximum value is 8, displaying the maximum value. Example 3. The code reassigns my_tuple with a new tuple, 5s8 byte 1, that contains both numeric and string values. When attempting to find the minimum value of this new tuple, which includes mixed data types, type error may occur because all values in the tuple must be of same type. You can check the outputs displayed on the console. In Python, the built-in sum function can be used to calculate the sum of elements in a tuple. However, the elements in the tuple must be numeric for the sum function to work properly. Now, look at the example. In this code, the sum function is called with the my_tuple as the argument, which calculates the sum of all the elements in the tuple. The result is stored in the total variable and then printed to the console. Note that if any of the elements in the tuple are not numeric, you will encounter a type error. Sorted is used to sort the elements of a tuple. It returns a list after sorting. Example 1. In this example, we start with a tuple called my_tuple with elements 5, 3, 8, 2, 1. Next, we use the sorted function to sort the elements of my_tuple. Since the sorted function returns a new list containing the sorted elements, we assign the result to the variable sorted_tuple. After that, we use the print function to display the sorted tuple. The output will be sorted tuple 1, 2, 3, 5, 8. The sorted elements are enclosed in square brackets because the sorted function returns a list. You can check the output on the console. Example 2. Here, we continue with the previously defined my_tuple. We apply the sorted function to my_tuple, which returns a sorted list. To convert the sorted list back to a tuple, we use the tuple function. The result is assigned to the variable sorted_tuple. Finally, we use the print function again to display the sorted tuple. The output will be the same as before. Sorted tuple 1, 2, 3, 5, 8. This time, the sorted elements are enclosed in parentheses, that is round brackets, because the tuple function converts the list to a tuple. You can check the output on the console. The index function in Python is used to find the index of a specific value within a tuple. The syntax is tuple.index of value start:end. Here, start and end are two optional parameters for the start and end of the tuple's index. Let's see some examples. Example 1. In this example, a tuple named tuple is defined with the elements right, wrong, right, wrong, right, wrong. The index function is then called on tuple with the argument right. This will return the index of the first occurrence of the value right in the tuple. The output will be 0. Since right appears at index position 0, the output is 0. I have highlighted right in yellow color. So accordingly, you can check the index 0 given on the above box. Example 2. Here, the index function is called on tuple with the argument wrong. It returns the index of the first occurrence of the value wrong in the tuple. The output will be 1. Since wrong appears at index position 1, the output is 1. I have highlighted wrong in yellow color. So accordingly, you can check the index 1 given on the above box. Example 3. In this example, the index function is called on tuple with two arguments, right and 1. This means that the search for the value right will start from index position 1 onwards. It will return the index of the first occurrence of right after index 1. The output will be 2. Since the first occurrence of right after index 1 is at position 2, the output is 2. I have highlighted the right in yellow color. So accordingly, you can check the index 2 given on the above box. Example 4. The index function is called on tuple with wrong and 2 as arguments. This means that the search for the value wrong will start from index position 2 onwards. It will return the index of the first occurrence of wrong after index 2. The output will be 3. Since the first occurrence of wrong after index 2 is at position 3, the output is 3. I have highlighted the wrong in yellow color. So accordingly, you can check the index 3 given on the above box. Example 5. In this example, the index function is called on tuple with 3 arguments, right, 1, and 4. This specifies a search for the value right between index positions 1 and 4, exclusive of 4. It will return the index of the first occurrence of right within this range. The output will be 2. Since the first occurrence of right within the specified range is at position 2, the output is 2. I have highlighted the right in yellow color. So accordingly, you can check the index 2 given on the above box. Example 6. Here, the index function is called on tuple with the argument yes. However, since yes is not present in the tuple, a value error will be raised. To compare tuples in Python, you can use the comparison operators, less than equal to, greater than equal to, not equal to, just like you would with other data types. Tuples are compared element-wise, starting from the first element. If they are equal, it goes on to the next element, and so on, until it finds elements that differ. Let's see some examples. Example 1. The first line defines tup1 as a tuple containing the elements 10, 20, 30, and the second line defines tup2 as a tuple containing the elements 40, 50, 60. The line print tup1 greater than tup2 compares tup1 and tup2 using the greater than operator. Since the first element of tup1 is 10 and the first element of tup2 is 40, the comparison stops there, and the result is false. Therefore, the output will be false. Example 2. The line print tup1 not equal to tup2 compares tup1 and tup2 using the not equal operator. Since at least one element in tup1 is not equal to the corresponding element in tup2, which is true for all elements, the result is true. Therefore, the output will be true. Example 3. Here, tup1 is a tuple of integers 10, 20, and 30, and tup2 is a tuple of floats 10.0, 20.0, 30.0. In Python, when comparing tuples, elements are compared based on their values and types. However, when comparing an integer with a float, Python considers them the same as long as their values are equal. In this case, all elements in tup1 and tup2 have the same values, although their types differ. So, the comparison tup1 equal to tup2 will evaluate to true. Therefore, the output will be true. In Python, tuples are immutable, meaning their elements cannot be modified once created. However, you can delete an entire tuple using the del keyword. Let's see some examples. Example 1. Tuple named my_tuple holds the value 100, 200, 300 and printed. Output displayed is 100, 200, 300. Next, the del keyword is used to delete the my_tuple. After deleting the tuple, attempting to print it will raise a name error since the variable no longer exists. It's important to note that once a tuple is deleted, you cannot access or use it anymore. If you need a data structure that allows modifications, consider using a list instead of a tuple. Packing and unpacking are two operations related to tuples in Python. Packing a tuple. Packing refers to creating a tuple by grouping multiple values together. You can pack values into a tuple by simply separating them with commas and enclosing them in parentheses. Example of tuple packing. In this example, the values 1, 2, and 3 are packed into a tuple called my_tuple without explicitly using parentheses. Python automatically recognizes the comma-separated values as a tuple. Unpacking a tuple. Unpacking is the process of extracting individual elements from a tuple and assigning them to separate variables. It allows you to conveniently access and work with the elements of a tuple. In this example, the tuple my_tuple is unpacked, and its elements are assigned to the variables a, b, and c. Each variable receives the corresponding value from the tuple. Packing and unpacking are complementary operations that allow you to easily group values into a tuple or extract values from a tuple into separate variables. Features of Python. Immutable. Tuples are immutable, meaning their elements cannot be modified or reassigned after creation. However, you can create a new tuple by concatenating or slicing existing tuples. There is no append or extend methods for tuples. You can't remove elements from a tuple. Tuples have no remove or pop method. Heterogeneous data. Tuples can contain elements of different data types, such as integers, floats, strings, or even other tuples. This allows you to group related data together. Iterable. Tuples are iterable, which means you can use them in loops or apply iteration-related functions, like for loops, in operator, len, and tuple function. Arbitrary length. Tuples can have any number of elements, including 0 elements, an empty tuple. Ordered. The elements in a tuple have a defined order, and this order is preserved when accessing or iterating over the tuple. You can access individual elements using indexing or slicing. Packing and unpacking. To change a tuple you can unpack it first, then change the value and pack it again. Advantages of tuples. Immutable. Tuples are immutable, meaning their elements cannot be modified after creation. This immutability guarantees the integrity of the data, making tuples useful for storing values that should not be changed accidentally. Order and indexing. Tuples preserve the order of their elements, allowing for easy indexing and retrieval of specific values by their positions. Heterogeneous data. Tuples can contain elements of different data types, making them versatile for grouping related data together, such as coordinates, database records, or function return values. Memory efficiency. Tuples are more memory efficient than lists because they are immutable. This immutability allows for better memory optimization and faster operations. Hashable. Tuples are hashable, making them suitable for use as keys in dictionaries or elements in sets. The ability to hash tuples allows for efficient data lookup and manipulation. Disadvantages of tuple. Immutability. While immutability can be an advantage, it also means that you cannot modify, add, or remove elements from a tuple once it is created. To make changes, you need to create a new tuple, which can be less efficient when dealing with large data sets. Limited functionality. Tuples lack some of the functionality provided by other data structures, such as lists. For example, you cannot append or extend a tuple directly. Instead, you need to create a new tuple with the desired values. Less flexible. Tuples do not provide the flexibility of dynamically modifying their elements. If you need a data structure that can be modified during program execution, a list may be more suitable. Lack of named elements. Unlike dictionaries, tuples do not have named elements. Accessing values in a tuple relies on positional indexing, which can make the code less readable if the positions are not self-explanatory. Dictionary in Python, Part 1. In this video, we are going to discuss about creating a dictionary, methods to create a dictionary, accessing elements in a dictionary, traversing a dictionary, appending values to a dictionary, updating elements in a dictionary, removing an item from dictionary, membership operator in dictionary, and practical implementation. So let's dive in and get started. Let's learn about dictionary in Python. A telephone directory can be compared to a dictionary. It is a book that contains names and phone numbers of people. A telephone directory is like a dictionary, where names are the keys and phone numbers are the values. In Python, we can create a dictionary to store similar information as a telephone directory. The names will be the keys in the dictionary, and the corresponding phone numbers will be the values. Now look at this example. A dictionary named telephone_directory holds the key value pairs of elements. Each name, for example, Sam, Alice, Bob, is a key, and each phone number, for example, 12345678890, 987654321, 55512345667, is a value. Similarly in Python 2, we have a concept of key-value pair using dictionary. Python dictionary is an unordered collection of items where each item is a key-value pair. Dictionary in Python is a collection of keys values, used to store data values like a map, which, unlike other data types which hold only a single value as an element. You can see in this picture how each key holds a single value as an element. Let's learn about the features of dictionary. Key value pairs. Dictionaries store data in the form of key value pairs. Each key is unique and associated with a corresponding value. This allows for efficient and fast lookup of values based on their keys. Each key is separated from its value by a colon, the items are separated by commas, and the entire dictionary is enclosed in curly braces. Mutable. Dictionaries are mutable, meaning that you can modify, add, or remove key value pairs after the dictionary is created. This flexibility makes dictionaries useful for dynamically changing data. Unordered. Dictionaries are unordered, which means that the order of key value pairs is not guaranteed. The order in which the items are stored in a dictionary may vary and is not important for their retrieval. Flexible key types. Dictionary keys can be of various data types, such as strings, numbers, or even tuples. However, keys must be immutable types because they are used as hash values to access values quickly. Arbitrary data types for values. Dictionary values can be of any data type, including numbers, strings, lists, other dictionaries, or even custom objects. This flexibility allows dictionaries to store and retrieve a wide range of information. No duplicate keys. Dictionaries cannot have duplicate keys. If you try to assign a value to an existing key, it will replace the previous value associated with that key. Let's learn how to create a dictionary. To create a dictionary in Python, you can use curly braces and specify key value pairs separated by colons. Syntax is dictionary_name equals open curly braces key 1 value 1, key 2 value 2, key 3 value 3, updo, key n, value n, close braces. Let's see some examples. Now, look at example 1. In the line my_dict equals curly braces, you are creating an empty dictionary named my_dict. In this case, by assigning curly braces to my_dict, you are initializing an empty dictionary with no key value pairs. This provides you with a dictionary object that you can populate with data later on by adding key value pairs. Now, look at example 2. The line creates a dictionary named my_dict1 with 4 key value pairs. Key r, value rainy. This key value pair associates the letter R with the value rainy. Key S, value summer. This key value pair associates the letter S with the value summer. Key W, value winter. This key value pair associates the letter W with the value winter. Key A, value autumn. This key value pair associates the letter A with the value autumn. Let's see some examples. Example 1. In this code, an empty dictionary named my_dict is created using curly braces. The print of my_dict statement outputs an empty dictionary. Since no key value pairs are added, the dictionary is empty. Example 2. In this code, a dictionary named my_dict1 is created with 3 key value pairs. I have marked key value pairs in pink color for your reference. The keys are integers, 100, 200, 300, and the corresponding values are strings, red, blue, green. The print statement outputs the dictionary my_dict1 with its key value pairs. The output is 100:red, 200:blue, 300:green, enclosed in curly braces. Example 3. In this code, a dictionary named my_dict2 is created with 4 key value pairs. I have marked key value pairs in pink color for your reference. The keys have different data types. An integer, 1, a string, 2, a tuple, 3, 4, and a float, 3.14. The corresponding values are integer, string, tuple, float. The printf statement outputs the dictionary my_dict2 with its key value pairs. The output displayed is 1:integer, 2:string, a tuple holding values 3, 4:tuple, 3.14:float, enclosed in curly braces. Let's learn the methods to create a dictionary. To create a dictionary in Python, key value pairs are separated by a comma and are enclosed in 2 curly braces, and in key value pairs, each key is separated from its value by a colon. Look at the first method. To create an empty dictionary by assigning 2 curly braces to a variable name. In the code, you are creating an empty dictionary and assigning it to the variable my_dict. This line prints the value of the my_dict variable, which is an empty dictionary. When you execute this line, you will see an output and empty curly braces, indicating an empty dictionary being printed. The next line prints the type of the my_dict variable. The type function in Python returns the type of an object. In this case, it will output class dict, indicating that my_dict is of type dict, which stands for dictionary. Now, look at the second method. To create a dictionary using string data type for both key value pairs. This code creates a dictionary named computer_dict with key value pairs representing computer-related terms. In this case, the output indicates that the computer_dict dictionary contains 4 key value pairs, representing computer terms such as CPU, RAM, SSD, and OS. Next method is to create a dictionary with built-in function dict. The function dict is used to create a new dictionary with no items. You can create an empty dictionary using the built-in dict function. The dict function, without any arguments, returns a new dictionary with no items. Here's an example. In this example, the dict function is called without any arguments, creating an empty dictionary. The output shows empty curly braces, indicating an empty dictionary. Next method is to create a copy of dictionary by passing a dictionary as an argument to dict. In this example, the original _dict contains key value pairs representing information about a fruit. The dict function is used to create a copy of the original dictionary by passing original_dict as an argument. The resulting copy_dict dictionary contains the same key value pairs as the original_dict, as fruit:_apple, color:_red, quantity:5, enclosed within curly braces. Both dictionaries are separate entities, so modifying one dictionary will not affect the other. Next method is to create a dictionary by passing a nested list as an argument to the dict function. You can provide the nested list in a specific format where each inner list contains 2 elements, the key and the value. Let's see an example. In this example, the nested _list represents a list of key value pairs. Each inner list contains 2 elements, where the first element is the key and the second element is the value. By passing the nested _list as an argument to the dict function, a new dictionary my_dict is created. The dict function maps each inner list's first element, the key, to its second element, the value, in the resulting dictionary. The output displays the my_dict dictionary, which contains the key value pairs extracted from the nested list. In this case, the dictionary formed is subject:_maths, students:30, teacher:_Joel, room:_B205, which represents information about a math class, including the subject, number of students, teacher's name, and room number. You can see how a nested list with arguments forms a dictionary of key value pairs using dict function. Next method is to add an item to the dictionary. We can use square bracket for accessing and initializing dictionary values. In this example, an empty dictionary my_dict is created. Using square brackets and the assignment operator equal to, new key value pairs are added to the dictionary. Each key is enclosed in square brackets, and its corresponding value is assigned. After adding the key value pairs, the output displays the updated my_dict dictionary, which now contains the added items. Fruit: apple, color: red, quantity: 5, enclosed in curly braces. To access elements in a dictionary in Python, you can use square brackets along with the keys of the dictionary to retrieve their corresponding values. Let's see some examples. Example 1. In this line, a dictionary called my_dict is created with 3 key value pairs. Key, name, value, Nancy. Key, age, value, 12. Key, city, value, New York. The next line prints the value associated with the key name in the dictionary my_dict. You can see the square brackets used along with the key name of the dictionary to retrieve the corresponding name. Since the key name exists in the dictionary, the output will be Nancy. Example 2. This line prints the value associated with the key age in the dictionary my_dict. The key age exists in the dictionary, so the output will be displayed as 12. Example 3. This line tries to print the value associated with the key grade in the dictionary my_dict. However, the key grade does not exist in the dictionary, so an error will occur as key error grade. Let's learn about traversing a dictionary. To traverse or iterate over a dictionary in Python means accessing each element of a dictionary. This can be done by using a for loop. Iterating over keys using a for loop. You can use a for loop to iterate over the keys of the dictionary. Within the loop, you can access the corresponding values using the keys. Let's see an example. In line 1, a dictionary called my_dict is created with 3 key value pairs. Key, name, value, Nancy. Key, age, value, 12. Key, city, value, New York. In the second line, this code uses a for loop to iterate over the keys of the dictionary my_dict. During each iteration, the current key is stored in the variable key. The line value equals my_dict key retrieves the value associated with the current key and assigns it to the variable value. Finally, the print statement prints the key, a colon, and the corresponding value. The output will be name: Nancy, age: 12, city: New York. The for loop iterates over each key in the dictionary, and for each key, it accesses the corresponding value. Thus, the loop effectively traverses the dictionary and prints each key value pair. Let's learn about appending values to a dictionary. To append or add values to the existing dictionary in Python, you can extend it with single pair of values or join 2 dictionaries into one. Syntax is dictionary_nameof, key equals value. Now look at the example. In the first line, a dictionary called my_dict is created with 4 key value pairs. Key, mon, value, Monday. Key, to, value, Tuesday. Key, wed, value, Wednesday. Key, thurs, value, Thursday. The second line adds a new key value pair to the dictionary my_dict. The key fry is assigned the value Friday. Since the key fry doesn't exist in the dictionary, a new key value pair is appended. The third line prints the dictionary my_dict after adding the new key value pair. The output will be open curly braces, mon: Monday, 2: Tuesday, wed: Wednesday, thurs: Thursday, fry: Friday, close curly braces. To update elements in a dictionary in Python, you can modify existing key value pair or by merging another dictionary with an existing one. Syntax is dictionary_nameof key equals value. Now, look at this example. In the first line, a dictionary called my_dict is created with 3 key value pairs. Key, name, value, Nancy. Key, age, value, 12. Key, city, value, New York. The next line updates the value associated with the key age in the dictionary my_dict. The line my_dict of age equals 13 assigns the new value 13 to the existing key age. After the update, the dictionary is printed using printf my_dict. The value associated with the key age is updated from 12 to 13. The dictionary my_dict is modified, and the updated dictionary is printed. The output displayed is open curly braces, name: Nancy, age: 13, city: New York, close braces. Now, look at example 2. This code adds a new key value pair to the dictionary my_dict. The line my_dict of grade equals A assigns the value A to the new key grade. Since the key grade doesn't exist in the dictionary, a new key value pair is added. After the addition, the dictionary is printed using printf my_dict. Output displayed is open curly braces, name: Nancy, age: 13, city: New York, grade: A, close braces. The dictionary my_dict now contains 4 key value pairs, including the newly added key grade with the value A. 2 dictionaries can be merged into one by using update method. It merges the keys and values of one dictionary with another and overwrites values of the same key. Syntax is dic_name1.update of dic_name2. Using this, dic_name2 is added to dic_name1. Now, look at example 1. In this example, dict1 and dict2 are initially separate dictionaries. After calling dict1.update of dict2, the key value pairs from dict2 are merged into dict1. The resulting merged dictionary is A:1, B:2, C:3, D:4, enclosed in curly braces. However, dict2 remains unchanged. The output of dict2 is C:3, D:4, enclosed in curly braces. Now, look at example 2. In this example, both dict1 and dict2 have a common key value pair. When dict1.update of dict2 is called, the value of the common key B in dict1 is overwritten by the value from dict2. The resulting merged dictionary is A:1, B:5. Again, dict2 remains unchanged. The output of dict2 is A:1, B:5, enclosed in curly braces. The update method merges dictionaries by adding or overwriting key value pairs from the second dictionary into the first dictionary. The original dictionaries are modified in place, and any modifications to one dictionary do not affect the other. Let's learn about removing an item from dictionary. To remove an item from a dictionary in Python, you can use the del command or the pop method. First, we will learn using the del command. The syntax is del dict name of key. Let's see some examples. Example 1. In this example, a dictionary named my_dict is created with 4 key value pairs representing different fruits and their quantities. The print function is used to display the initial contents of the dictionary. The output shows the dictionary with all its key value pairs. Apple:3, banana:5, orange:2, grape:4, enclosed in curly braces. Now, look at example 2. Here, the del statement is used to remove the item with the key banana from the dictionary my_dict. After removal, the updated dictionary is displayed using the print function. Apple:3, orange:2, grape:4, enclosed in curly braces. As shown in the output, the item with the key banana is no longer present in the dictionary. Now, look at example 3. In this part of the code, an attempt is made to remove an item with the key cherry from the dictionary my_dict using the del statement. However, since the key cherry does not exist in the dictionary, it will result in a key error being raised. The code will terminate at this point and the key error message will be displayed. The key error is raised because del my_dict of cherry is trying to remove an item with a key that does not exist in the dictionary. Let's learn using pop method in a dictionary. Pop method will not only delete the item specified by the key from the dictionary but also return the deleted value. The syntax is dictName.pop of key. Now, look at the example. Look at line 2. A dictionary named my_dict is created with 4 key value pairs representing different fruits and their quantities. Now, look at line 5. The pop method is used on the dictionary my_dict to remove the item with the key banana. This method takes the key as an argument and removes the corresponding key value pair from the dictionary. Additionally, the removed value is returned by the pop method and assigned to the variable removed_value. Now, look at the 7th line. The print function is used to display the value stored in removed_value. In this case, the value associated with the key banana is 5, so it will be printed as the output. Look at 8th line. Finally, the print function is used again to display the updated dictionary my_dict after removing the item with the key banana. The output will show the dictionary without the key value pair that was removed. Output is Apple:3, orange:2, grape:4, enclosed in curly braces. As shown in the output, the value 5 is returned and stored in the variable removed_value. The dictionary my_dict is printed without the key banana and its corresponding value, reflecting the removal of that item. Let's learn about the membership operator in and not in dictionary. The in operator checks whether a particular key is there in the dictionary. It returns true if specified key element appears in the dictionary, otherwise returns false. Now, look at the example. Now look at line 2. A dictionary named my_dict is created with 3 key value pairs representing weekdays and their corresponding full names. Look at line 5. The in operator is used to check if the key wed is present in the dictionary. Since wed is a key in my_dict, the first condition is satisfied, and the corresponding message is printed. The output displayed is, wed is present in the dictionary. Now, look at line 9. The not in operator is used to check if the key thurs is not present in the dictionary. As thurs is not a key in my_dict, the second condition is satisfied, and the corresponding message is printed. The output displayed is, "Thurs is not present in the dictionary." Now look at line 12. The "and" operator is used to directly check if the key wed is present in my_dict. The result is true, indicating that wed is indeed a key in the dictionary. Now, look at line 13. The "not" and operator is used to check if the key "thurs" is not present in my_dict. The result is true, indicating that "thurs" is not a key in the dictionary. The output confirms the presence or absence of the specified keys in the dictionary using the membership operators. Dictionary in Python, Part 2. In this video, we are going to discuss about dictionary functions and methods and practical implementation. So let's dive in and get started. In Python, there are several built-in functions and methods that you can use to work with dictionaries. Let's see one by one in detail. Let's learn about the len function in dictionary. In Python, the len function returns the number of items or elements in a collection, such as a string, list, tuple, or dictionary. When used with a dictionary, the len function returns the number of key-value pairs in the dictionary. The syntax is len of d. Here, d is the dictionary. It returns number of key-value pairs in the dictionary. Now, look at this example. In this example, the dictionary my_dict contains 3 key-value pairs. The len function is used to determine the number of key-value pairs in the dictionary. Here the length of the dictionary is 3. I have marked the length 1, 2, 3 in red color above each key-value pair for your reference. Let's learn about the clear function. In Python, the clear method is used to remove all the elements from a dictionary. It modifies the dictionary in place, resulting in an empty dictionary. Let's see an example. In the first line, we create a dictionary called my_dict with some initial key-value pairs, A:1, B:2, C:3. The second line prints the original dictionary to see its contents as A:1, B:2, C:3, enclosed in curly braces. Look at the fourth line. We then call the clear method on the my_dict dictionary. This method removes all the key-value pairs from the dictionary. After calling clear, we print the dictionary again to see its contents. Since the clear method modified the dictionary in place, the output is an empty dictionary showing empty curly braces. You can check the output on the console. Let's learn about the get function. In Python, the get method is used to retrieve the value associated with a specified key in a dictionary. It allows you to access dictionary elements while providing a default value none if the key is not found. The syntax is dict.get of key, default equals none. Here, key is the key to be searched in the dictionary. Default is the value to be returned in case the key does not exist. The get method returns a value for the given key. If key is not available, then returns default value none. Let's see an example. Now, look at line 1. In this line, we create a dictionary called my_dict with 3 key-value pairs, A:1, B:2, and C:3. Now, look at line 4 and 5. These two lines demonstrate retrieving the values associated with existing keys. When we call the get method on the dictionary with the key A, it returns the corresponding value 1. Similarly, when we call it with the key B, it returns the value 2. Now, look at line 8. In this line, we attempt to retrieve the value associated with the non-existing key D. Since the key is not present in the dictionary, the get method returns none. This can be useful to handle cases when you are unsure if a key exists in a dictionary and want to avoid raising a key error. Now look at line 11. Here, we provide a default value of 0 as the second argument to the get method. Since the key D doesn't exist in the dictionary, the method returns the specified default value 0. This allows you to provide a fallback value when the key is not found. Now, look at line 14. In this line, we demonstrate that the default value can be any valid Python object. Here, we provide the string never as the default value. Since the key D is not found in the dictionary, the get method returns the specified default value never. In Python, the items method is used to return a view object that contains tuples of key-value pairs from a dictionary. Each tuple represents a key-value pair, where the first element is the key and the second element is the corresponding value. The syntax is d.items function. Here D is the dictionary. Let's see an example. In the example, a dictionary named my_dict is created with 4 key-value pairs. Each key represents the name of a student, and each value represents their corresponding score. Key Alice, value 85. Key Bob, value 92. Key Charlie, value 78. Key Diana, value 95. Now, let's look at the print of my_dict items statement. The items method is called on the my_dict dictionary, which returns a view object. This view object represents the dictionary's key value pairs as a list of tuples. Each tuple contains two elements, the key as the first element and the corresponding value as the second element. By printing my_dict.items, you'll see the view object that represents the key value pairs. Dict_items of list holding 4 tuple values, tuple holding elements, Alice, 85, second tuple holding elements, Bob, 92, third tuple holding elements, Charlie, 78, fourth tuple holding elements, Diana, 95. Note that items returns a list of tuples having key value pairs. Lists are enclosed in square brackets and tuples are enclosed in round brackets. In this output, you can see that the items method has converted the dictionary's key value pairs into a view object, and each pair is represented as a tuple within the list. The dict_items part indicates that it is a view object containing the items of the dictionary. The items method is useful when you need to iterate over the key value pairs of a dictionary or convert them into a different data structure, like a list of tuples, as shown in this example. In Python, the keys method is a dictionary method that returns a view object containing the keys of the dictionary. Note that keys returns a list of the key values in a dictionary. Lists are enclosed in square brackets. Syntax is d.keys function. Here, D is the dictionary. Let's see an example. In the example, a dictionary named my_dict is created with 4 key value pairs. Each key represents the name of a student, and each value represents their corresponding score. Key, Alice, value, 85. Key, Bob, value, 92. Key, Charlie, value, 78. Key, Diana, value, 95. Now, let's look at the print of my_dict.keys statement. The keys method is called on the my_dict dictionary, which returns a view object containing only the keys of the dictionary. By printing my_dict.keys, you'll see the view object representing the keys. Dict_keys of list holding elements, Alice, Bob, Charlie, Diana. So, the keys method provides a way to access only the keys of a dictionary in Python. Let's learn about values method in dictionary. In Python, the values method is a dictionary method that returns a view object containing only the values of the dictionary. The syntax is d.values function. Here, D is the dictionary. Let's see an example. In the code, a dictionary named my_dict is created with 4 key value pairs. Each key represents the name of a student, and each value represents their corresponding score. Key, Alice, value, 85. Key, Bob, value, 92. Key, Charlie, value, 78. Key, Diana, value, 95. Now, let's look at the print of my_dict.value statement. The values method is called on the my_dict dictionary, which returns a view object containing only the values of the dictionary. By printing my_dict.values, you'll see the view object representing the values, dict_values of list holding values 85, 92, 78, 95. The dict_values part indicates that it is a view object containing only the values of the dictionary. In Python, the copy function is used to create a shallow copy of a dictionary. It returns a new dictionary object that contains the same key value pairs as the original dictionary. We cannot copy a dictionary by using assignment equal to operator, as it will create a reference to the same dictionary variable and modifications will also be reflected in both dictionaries. We can use built-in function copy to create a new dictionary and modifications done on base dictionary will not be reflected. The syntax is dict_new equals dict_old.copy function. Let's see some examples. In the given example, in line 1, we have a dictionary original_dict with key value pairs representing days of the week. Original_dict equals Monday, 2 Tuesday. Now, look at line 3, we are assigning a dictionary here, copy_dict1 is assigned the reference of original_dict. This means both copy_dict1 and original_dict refer to the same dictionary object in memory. In line 4 and 5, we are printing the dictionaries. The output of print of original_dict will be the same as print of copy_dict1. You can check the output 1 and 2 as Monday, 2 Tuesday, enclosed in curly braces. Now, look at line 7, we are going to modify copy_dict1. Here, copy_dict1 of wed equals Wednesday. We add a new key value pair to copy_dict1. Next in line 8 and 9, we are printing the dictionaries. Both copy_dict1 and original_dict will have the same updated content, as they refer to the same dictionary object. You can check the output 3 and 4 as Monday, Tuesday, Wednesday, enclosed in curly braces. So, changes made in copy_dict is reflected in original_dict. Modifying copy_dict1 affected original_dict because they both point to the same dictionary object. Now look at line 11. We are copying a dictionary. Copy_dict2 equals original_dict.copy function. Here, copy_dict2 is created as a new dictionary object with the same key value pairs as original_dict. It is a shallow copy, meaning the keys and values are copied, but if the values are mutable objects, the references to those objects are still shared. So the fifth output. The output is Monday, Tuesday, Wednesday, enclosed in curly braces. Now, look at line 14. We are modifying original_dict. Original_dict of Thurs equals Thursday. Here, we add a new key value pair to original_dict. Next, look at line 15 and 16. We are printing the dictionaries. Copy_dict2 remains unaffected by the changes made to original_dict because they are separate dictionary objects. Now look at the output 6. The output of copy_dict2 is Monday, Tuesday, Wednesday, enclosed in curly braces. Now, look at the output 7. The output of original_dict is Monday, Tuesday, Wednesday, Thursday, enclosed in curly braces. The changes made to original_dict are not reflected in copy_dict2. So assigning a dictionary to a new variable creates a reference to the same dictionary object, while using the copy method creates a new dictionary object with the same key value pairs. Let's learn about FromKeys method in dictionary. In Python, the FromKeys method is a built-in method available for dictionaries. It is used to create a new dictionary with specified keys and a default value for all the keys. The syntax is new_dict equals dict.FromKeys of keys, value. Here, keys is an iterable, such as a list or tuple, containing the keys for the new dictionary. Value is the default value assigned to each key. The FromKeys method returns a new dictionary with the specified keys and default value. Let's see some examples. Example 1. Using FromKeys with a single value for all keys. Look at line 1. Keys 1 equals 10, 20, 30, 40. Line 2. Values 1 equals 2000. Line 3. D1 equals dict.FromKeys of keys 1, values 1. Here, the FromKeys method creates a new dictionary D1 with keys from keys 1 and assigns the same value 2000 to each key. Now, look at output 1. The resulting dictionary has key value pairs 10:2000, 20:2000, 30:2000, 40:2000, enclosed in curly braces. Now, look at example 2. Using FromKeys with a tuple of keys and a single value for all keys. Line 6, keys 2 equals Monday, Tuesday, Wednesday, Thursday. Line 7, values 2 equals weekdays. Line 8, D2 equals dict.FromKeys of keys 2, values 2. Here, FromKeys is used to create a new dictionary D2 with keys from keys 2, and the same value weekdays is assigned to each key. Now, you can check the output too. The resulting dictionary contains key value pairs, Monday:weekdays, Tuesday:weekdays, Wednesday:weekdays, Thursday:weekdays, enclosed in curly braces. Now, look at example 3. Using FromKeys with only keys and no values specified. Line 11, keys 1 equals 10, 20, 30, 40. Line 12. D3 equals dict.FromKeys of keys 1. In this case, the values argument is not provided to FromKeys, so the default value none is assigned to each key. Now, look at output 3. The resulting dictionary D3 has key value pairs 10:none, 20:none, 30:none, 40:none, enclosed in curly braces. Now, look at example 4. Using FromKeys with different lists for keys and values. Line 15, D1 equals dict.FromKeys of 100, 200, 300, 400, 10, 20, 30, 40. In this case, the FromKeys method is used to create a new dictionary D1. The first argument, 100, 200, 300, 400, provides the keys, and the second argument, 10, 20, 30, 40, provides the values. Each key in D1 is paired with the same list, 10, 20, 30, 40. Now, look at output 4. The resulting dictionary has key value pairs 100: 10, 20, 30, 40, 200: 10, 20, 30, 40, 300: 10, 20, 30, 40, 400: 10, 20, 30, 40, enclosed in curly braces. Let's learn about the zip function. The zip function in Python can also be used to create a dictionary by zipping two or more lists and creating a dictionary using dict function taking zipped lists as arguments to it. You can create a dictionary with a list of zipped keys and values. Let's see some examples. Example 1. Now, look at line 1. Here, we have two lists. 10, 20, 30, and 1, 2, 3, 4. The zip function combines corresponding elements from these lists into pairs. Since the second list has one extra element, the pairing stops at the third element of the first list. The resulting pairs are 10, 1, 20, 2, and 30, 3. The dict function then takes these pairs and creates a dictionary from them. The first element of each pair becomes the key, and the second element becomes the value. Now look at output 1. The resulting dictionary is printed as 10:1, 20:2, 30:3, enclosed in curly braces. Now look at example 2, line 4. We have a list called keys with three elements, A, B, and C. Next, look at line 5. We have another list called values with three elements, 1, 2, and 3. Now look at line 6. Using zip, we combine the corresponding elements from keys and values. The resulting pairs are A, 1, B, 2, and C, 3. The dict function takes these pairs and creates a dictionary from them. The first element of each pair becomes the key, and the second element becomes the value. Now, look at output 2. The resulting dictionary is printed as A, 1, B, 2, C, 3, enclosed in curly braces. Let's learn about the pop item function in dictionary. The pop item method removes the last item from dictionary and returns this deleted item. The syntax is d.popItem function. Here, D is the dictionary. Let's see an example. Example 1. Line 1. We initialize a dictionary called my_dict with three key value pairs. A mapped to 1, B mapped to 2, and C mapped to 3. Now, look at line 2 and 3. The pop item method is called on the my_dict dictionary. It removes and returns an arbitrary key value pair from the dictionary. In this case, the last key value pair C mapped to 3 will be removed and printed. The output displayed is removed item C mapped to 3. Now, look at line 4. After the pop item method is called, the dictionary my_dict is modified and no longer contains the removed key value pair. This line prints the updated dictionary, showing the remaining key value pairs. The output displayed is A, 1, B, 2, enclosed in curly braces. The dictionary shows the modified version with the removed pair. Let's learn about the setDefault function in dictionary. The setDefault method is used to retrieve the value of a specified key from a dictionary. If the key exists in the dictionary, the method returns its corresponding value. If the key does not exist, the method creates a new key value pair with the specified key and a default value, and then returns the default value. The syntax is dictionary.setDefault of key, default_value. Here, key is the key to be searched in the dictionary. Default_value is the value to be set as the default if the key is not found. None if key is not in the dictionary and default_value is specified. Let's see some examples. Example 1. Now look at line 1. We initialize a dictionary called person with one key value pair, name mapped to Alan. Now, look at line 4. Salary equals person.setDefault of salary. The setDefault method is called on the person dictionary with the key salary. Since the key salary does not exist in the dictionary, the method creates a new key value pair salary, none, and returns the default value, which is none. The returned value is assigned to the variable salary. Line 5. This line prints the person dictionary. You can check the output printed. Since the salary key did not exist before, it has been added with the default value. Therefore, the dictionary will now have two key value pairs. Look at the output, name is mapped to Alan and salary is mapped to none. Now, look at line 6. This line prints the value of the salary variable, which is the default value returned by the setDefault method. In this case, the output will be salary equals none. You can check the output salary equals none. Now, look at line 10. Age equals person.setDefault of age, 22. The setDefault method is called again, this time with the key age. Since the key age does not exist in the dictionary, the method creates a new key value pair age, 22, and returns the default value, which is 22. The returned value is assigned to the variable age. Line 11. This line prints the updated person dictionary. The dictionary will now have three key value pairs. You can check the output. Name is mapped to Alan, salary is mapped to none, age is mapped 22. Line 12, this line prints the value of the age variable, which is the default value returned by the setDefault method. In this case, you can check the output will be age equals 22. Let's learn about the max and min functions in dictionary. In Python, the max and min functions can be used to find the maximum and minimum values, respectively, from a dictionary based on either the keys or the values. Let's see an example. Finding the maximum and minimum keys. Look at line 2. In this code, we have a dictionary my_dict with 3 key value pairs, A mapped to 10, B mapped to 20, and C mapped to 5. Look at line 3. The max function is called with my_dict as the argument, which returns the maximum key from the dictionary based on their natural ordering. In this case, since the keys A, B and C are strings, the maximum key is determined by the ASCII values. The maximum key C, holding ASCII value 99, is assigned to the variable max_key. Now, look at line 4. The min function is called with my_dict as the argument, which returns the minimum key from the dictionary based on their natural ordering. Similarly, since the keys are strings, the minimum key is determined by ASCII values. The minimum key, A, holding ASCII value 97, is assigned to the variable min_key. Line 5 prints the maximum key C, obtained from max_key. Line 6 prints the minimum key, A, obtained from min_key. Next is finding the maximum and minimum values. Now look at line 9, we have the same dictionary my_dict with 3 key value pairs. Look at line 10. The max function is called with my_dict.values as the argument, which returns the maximum value from the dictionary. In this case, the maximum value 20 is assigned to the variable max_value. Now, look at line 11. The min function is called with my_dict.values as the argument, which returns the minimum value from the dictionary. The minimum value 5 is assigned to the variable min_value. Line 12 prints the maximum value 20, obtained from max_value. Line 13 prints the minimum value 5, obtained from min_value. Let's learn about sorted function in dictionary. In Python, the sorted method sorts the elements of a dictionary by its key or value. Let's see some examples. Example 1. Look at line 1. You create a dictionary called my_dict with 3 key value pairs, C:3, A:1, and B:2. Now, look at line 2. Here, you use the sorted function to sort the keys of the my_dict dictionary. The keys method returns a view object containing all the keys in the dictionary. By passing this view object to sorted, you obtain a new list containing the keys in sorted order. Finally, in line 3, you print the sorted keys. You can check the output shows the sorted keys of the dictionary in alphabetical order as list holding elements A, B, and C. Now, look at example 2. This code sorts the values of the my_dict dictionary using the sorted function and assigns the sorted values to the variable sorted_values. The values method returns a view object with all the values in the dictionary. By passing this view object to sorted, you obtain a new list containing the values in sorted order. Finally, in line 5, you print the sorted values as list holding values 1, 2, 3. The output displays the sorted values of the dictionary in ascending order. Now, look at example 3. In this line, you sort the items, key value pairs, of the my_dict dictionary using the sorted function. The items method returns a view object with all the key value pairs in the dictionary. By passing this view object to sorted, you obtain a new list with the key value pairs sorted based on the keys. Then, you convert the sorted list of items back into a dictionary using the dict constructor. Finally, you print the sorted dictionary as A:1, B:2, C:3, enclosed in curly braces. The output represents the sorted dictionary, where the key value pairs are sorted based on the keys in ascending order. Python modules, Part 1. Welcome to the fascinating world of Python modules. Let's start learning about modules in Python. Have you heard about the term modules, but what exactly are they, and why are they so important? Modules in Python serve as organized containers for code, much like compartments in a toolbox. Just as a toolbox keeps similar tools together for easy access and organization, modules group related functions, variables, and classes in a Python program. For instance, imagine a toolbox where all screwdrivers are kept in one compartment, wrenches in another, and so on. Similarly, in Python, a module could contain functions for mathematical operations, another for handling file operations, and yet another for working with dates and times. Each module encapsulates functionality that can be reused across different programs, much like referring to different chapters in a book for specific topics. This modularity allows developers to efficiently manage and maintain their codebase by separating concerns and promoting code reusability. So, when we import a module into our Python script, we're essentially accessing a collection of related tools or information that we can utilize to accomplish various tasks within our program, making our code more organized, understandable, and versatile. In Python, a module is a file containing Python code that defines functions, classes, and variables that can be used in other programs. The set of functions stored in a file is called module, and this approach is known as modularization. Modules help organize code and promote code reusability. They allow you to break your program into smaller, more manageable parts. Commonly used modules that contain source code for generic needs are called libraries. Let's discuss about module creation. You can create your own modules by writing Python code in a .py file. Each file represents a module, and its name is usually the same as the file name, excluding the .py extension. A module in Python is a file that contains a collection of related functions. Therefore, when we speak about working with libraries in Python, we are in fact working with modules that are created inside the packages, or we can say it as library. Thus, a Python program comprises of three main components: library or package, module, functions, or submodules. Let's see the relation between module, package, and library in Python. Module. A module is a file containing Python code that can define functions, classes, and variables and statements with .py extension related to a particular task. A module allows us to organize our code by grouping related code, which makes the code easier to understand and use. Package. A package is a directory of Python modules. It is a namespace that contains multiple packages or modules. It is a directory which contains a special file $init_.py through which Python interpreter interprets it as a package. Library. A library refers to a collection of modules that together cater to specific needs or applications. For example, Math Library of Python caters to mathematical computations, NumPy library deals with scientific computing, etc. Let's learn about the objects in Python module. Docstring. String literals enclosed with triple quotes that appear right after the definition of a function, class, method, or module. It is mainly used for documentation and can be accessed using $_doc_attribute. Variables and constants. For storing values. Classes. To create blueprint of any object. Objects. Object is an instance of class. It represents class in real world. Statements. Instruction. Functions. Group of statements to perform a specific task. Let's see the advantages of Python module. Code reusability with modules. Let me explain. Modules facilitate code reuse by allowing the importation of module functionality into other Python scripts, reducing redundancy and promoting efficient development. Next advantage is organized and documented boundaries. Python modules create well-defined and documented boundaries within a program, aiding in code management and maintenance. Next advantage is logical organization. Modules enable logical organization of Python code, enhancing readability and facilitating collaboration among developers. Next advantage is improved understandability and usability. Grouping similar attributes into modules enhances code understandability and usability, providing a structured approach to organizing code and simplifying access to specific functionality. First, we can discuss about modules. A module is a single file containing Python code that defines variables, functions, and classes. Let me explain this with an example. If the content of a book is not indexed or categorized into individual chapters, the book will become boring and complicated. Hence, dividing the book into chapters makes it easy to understand. In the same way, Python modules are files which have a similar code. Thus, a module simplifies a Python code where classes, functions, and variables are defined. Now look at the second point. It serves as a way to organize code and make it reusable by allowing you to import its contents into other Python scripts. Modules can be small, containing just a few functions, or larger, encompassing several related functions and classes. Examples of modules in Python include math, random, and datetime. Look at the first box. How to create a module. To create a module, just save the code you want in a file with the file extension .py. Example, save this code in a file named mymodule.py. Def greeting of name, : print, hello, plus name. Now look at the right side box. How to use a module. Now we can use the module we just created by using the import statement. Example, import the module named mymodule and call the greeting function. Import mymodule. Mymodule.greeting of Sam. There are several built-in modules in Python, which you can import whenever you like. Let's discuss about Python module names. A module name is the file name with the .py extension. When we have a file named empty.py, empty is the module name, the double underscore name double underscore is a variable that holds the name of the module being referenced. Let's see this example. Import random. This line imports the random module from the Python standard library. After this line executes, you can use functions and classes from the random module in your code. In line 2, random.double underscore name double underscore. This line accesses the double underscore name double underscore attribute of the random module. In Python, modules have several attributes, and double underscore name double underscore is one of them. The double underscore name double underscore attribute is a built-in variable that holds the name of the module as a string. Output of example 1 is random. The reason for this output is that the double underscore name double underscore attribute of the random module is set to random. In other words, the value of random.double underscore name double underscore is the string random. Look at the second example, line 6. The double underscore name double underscore attribute is particularly useful when you want to determine whether a Python script is being run as the main program or being imported as a module into another script. When a Python script is executed directly, its double underscore name double underscore attribute is set to double underscore main double underscore. If the script is imported as a module in another script, the double underscore name double underscore attribute will be set to the name of the module, in this case, random. Look at the code of example 2. If you have the following code in a script called example.py and if you run example.py directly, Python example.py, it will print. Now look at the output. This script is being executed directly. This is some underscore function in example.py will be printed. However, if you import example.py in another script, the if double underscore name double underscore equals double underscore main double underscore block will not be executed, and only the functions and classes defined in the module will be available for use. To use a module in your program, you need to import it. Python provides import keyword to import modules in a program. You can import the whole module or specific parts of it. The import statement is used for importing modules. There are two methods to import modules: importing entire module and importing selective methods from a module. Let's see one by one in detail. Importing entire module. To import an entire module in Python, you can use the import statement followed by the name of the module. Syntax is import module underscore name. For example, let's say you have a module called math.py that contains various mathematical operations. To import the entire module, you would use import math. It gives access to all the functions of math module. Next is to import multiple modules in a program. Syntax is import module underscore name 1, module underscore name 2, and so on. Example. Import math, time. This will import two modules in a program. Next is, we can access any function of the imported module by using dot notation. Example. Math.sqrt function. Importing the entire module may load more code into memory than necessary. If you only need specific functions or variables from a module, you can use the from statement to import them selectively. Now, let's discuss about importing selective methods from a module. To import selective methods or entities from a module in Python, you can use the from statement. This allows you to import all or specific functions, classes, or variables directly into your code without referencing the module name. Syntax is from module name import star. Example. From math import star. It gives access to all the functions of math module. Next is to import a particular function of the module. Syntax is from module name import method name. Example, from math import sqrt. This will import only sqrt function from the math module. Next is to import multiple functions. Syntax is from module name import method 1, method 2, up to method n. Example, from math import sqrt, pow, pi. This will import multiple functions, that is, sqrt, pow and pi functions of math module in a program. Let's see some examples. Line 1 imports the sqrt, pow, and pi entities from the math module. Now you can use these entities directly in your code without referencing the module name, math. In line 2, the sqrt function is imported from the math module, allowing you to calculate the square root of a number. In this line, it calculates the square root of 625, which is 25.0, and printed. In line 3, the pi constant is imported from the math module. It represents the mathematical constant pi. In this line, it is printed after rounding it to 2 decimal places using the round function. The output will be 3.14, which is the rounded value of pi. In line 4, the pow function is imported from the math module, allowing you to calculate the power of a number. In this line, it calculates 3 raised to the power of 3, which is 27, and printed. To import all methods from a module. Syntax is from module name import star. It imports all the functions and constants from a module. Example. From math import star. This will import all the constants and functions or methods of math module. Let's see some examples. When you use from math import star, it imports all entities from the math module into your code. This includes functions, constants, and other entities defined in the math module. Look at line 1. This line imports all entities from the math module. It allows you to use any function, constant, or other entities from math without explicitly mentioning the module name. In line 2, the pi constant is part of the math module and represents the mathematical constant, pi. Since you imported all entities from the math module, you can directly access pi. The value of pi will be printed, which is approximately 3.141592653589793. In line 3, the factorial function is part of the math module. It calculates the factorial of a number. In this case, factorial of 5 calculates the factorial of 5, which is 120 and printed. In line 4, the sqrt function is also part of the math module. It calculates the square root of a number. In this line, sqrt of 225 calculates the square root of 225, which is 15.0 and printed. Let's see the key points of import statement. Import statement is the simplest and the most common way to use modules in our code. For example, import math. On executing this statement, Python shall perform 3 operations. Search for the file, math.py. Create space where module's definition and variable will be created. Execute the statements in the module. Import statement does not directly import the functions and constants in the program. To access or use any of the functions present in the imported module, we have to specify the name of the module followed by the name of the function, separated by a dot, also known as a period. This format is called dot notation. Let's see this example. Line 1 imports the math module, which is a standard library module in Python that provides various mathematical functions and constants. Line 2, the sqrt function is part of the math module. It calculates the square root of a number. In this line, math.sqrt of 144 calculates the square root of 144, which is 12.0 and printed. Retrieving objects from a module. There is another function dir, which, when applied to a module, gives you the names of all that is defined inside the module. Let's see an example. When you pass an object as an argument to dir, it lists the attributes and methods available for that object. Here, area is passed as mObject as an argument to dir function. You can see the output, how it has listed the attributes and methods available for area module. From the previous examples, we have observed that import statement in Python can be represented in any of the following for importing module in some other program. Let's recall. Point 1. Import test. Imports the module test and creates a reference to that module in the current calling program, or namespace. After executing this statement, you can use test.name to refer to the objects defined in module test. Point 2. Import test1, test2, test3. This statement shall import 3 modules, namely test1, test2 and test3 in current namespace. As a result, all the definitions of these modules are available and can be used as module_name, name. Name represents the submodule or any object. Point 3. From test import star. When you use import start statement, it shall import all the submodules or objects defined in the module test into the current namespace. So, after executing this statement, you are required to simply give the name of the object to be referred to, defined in the module test. In other words, name would now be used as name only, without specifying module's name, that is, test.name is not required to be given. If name was already defined, it is replaced by the new version, the one imported from the module. Point 4. From test import T1, T2, T3. This statement shall import the module test and create references in the current namespace to the given objects. In other words, you can now use T1, T2, and T3 in your program without specifying their module's name along with them. Note: whenever we are using a module in our program, for that module, its compiled file will be generated and stored in the hard disk permanently. Let's learn about module aliasing. Module aliasing in Python refers to the practice of giving a shorter or more convenient name, alias, to a module when importing it. This can be helpful when working with modules with long or complex names, or when there is a possibility of name conflicts. It allows you to use a shorter name to refer to the module's contents without affecting its actual name in the Python standard library or file system. Module aliasing is achieved using the import statement. Syntax is import module_name as alias_name. Here's an example of importing the math module and giving it an alias m. In this example, we can use m instead of math to access the functions and constants provided by the math module. Similarly, you can also use aliasing when importing specific items from a module using the from module_name import item_name as alias, which is the syntax. In this example, square_root is an alias for the sqrt function from the math module. Remember that while aliasing can improve code readability, it is essential to use meaningful aliases that convey the purpose of the module or item being imported. Overusing very short or cryptic aliases may make the code harder to understand for others and yourself in the future. Let's discuss about locating modules. When you import a module, the Python interpreter searches for the module in the following sequence. Current directory. Python looks for modules in the current working directory of your script or interactive session. This allows you to create and import your own modules easily. If the module isn't found, Python then searches each directory in the shell variable Python path. So, what is Python path environment variable? The Python path environment variable can be used to add custom directories to the module search path. By setting this variable, you can tell Python to search for modules in specific directories not included in the default sys.path. Finally, if all else fails, Python checks the default path, which is the location where Python has been installed on your computer screen. Python modules, Part 2. In Python, we have worked with script mode in the previous videos, which provides the capability to retain our work for future usage. For working in script mode, we need to write a module or function in Python and save it in the file having .py extension. A Python module is written once and used or called as many times as required. Modules can be categorized into built-in modules and user-defined modules. Let's learn about the standard built-in Python modules. Some of these important modules are explicitly designed to encourage and enhance the portability of Python programs, such as math module for mathematical functions, random module for pseudo-random number generation, and statistics module for calculating mathematical statistics of numeric data. Let's discuss about the math module. The math module in Python is a built-in module that provides various mathematical operations and functions. It allows you to perform complex mathematical calculations easily. To use the math module, you need to import it into your Python script using the following line of code. Import math. This is the very first statement to be given. Let's discuss about the given function one by one. Python's built-in mathematical functions. Let's discuss about the two mathematical constants pi and Euler's number. In Python, you can access two commonly used mathematical constants, pi and Euler's number, through the math module in the Python standard library. Pi is a well-known mathematical constant, which is defined as the ratio of the circumference to the diameter of a circle, and its value is 3.141592653589793. Look at example 1. To import this single object pi from the math module, let's see the code. Line 1, import math. We are importing the math module. In line 3 and 4, we are importing a single object pi from the math module and storing in a variable pi_value and finally printed. Now, look at example 2. Alternatively, it can be done without prefixing the module name and writing the name of the object directly after keyword import. From math import pi. Print pi. The output will be the same as example 1. Similarly, another well-known mathematical constant defined in the math module is e. It is called Euler's number. And it is a base of the natural logarithm. Its value is 2.71828182845945. Look at example 3. These constants can be directly called and used from math module. Note that we should remember not to use module name with imported object. If imported through from module import command, because now the imported object is part of your program's environment. The math.ceil of x function in Python returns the smallest integer greater than or equal to the given number x. It rounds the number up to the nearest integer. Let's see these examples. In line 1, the import math statement imports the math module, allowing you to access its functions and constants in your code. In line 2 and 3, the math.ceil function is called with the argument -25.17. This function returns the smallest integer greater than or equal to -25.17, which is -25, and is printed to the console. In line 4 and 5, the math.ceil function is called with the argument -200.12. The function returns the smallest integer greater than or equal to -200.12, which is -200, and is printed to the console. In line 6 and 7, the math.ceil function is called with the argument -200.72. The function returns the smallest integer greater than or equal to -200.72, which is -200, and is printed to the console. In line 8 and 9, in this last example, the math.ceil function is called with the argument 200. Since 200 is an integer, the math.ceil function simply returns the same integer value 200 and is printed to the console. The math.floor of x function in Python returns the largest integer less than or equal to the given number x. It rounds the number down to the nearest integer. Let's see these examples. In line 1, the import math statement imports the math module, allowing you to access its functions and constants in your code. In line 2 and 3, the math.floor function is called with the argument minus 25.17. This function returns the largest integer less than or equal to minus 25.17, which is minus 26, and is printed to the console. In line 4 and 5, the math.floor function is called with the argument minus 200.12. The function returns the largest integer less than or equal to minus 200.12, which is minus 201, and is printed to the console. In line 6 and 7, the math.floor function is called with the argument minus 200.72. The function returns the largest integer less than or equal to minus 200.72, which is minus 201, and is printed to the console. In line 8 and 9, the math.floor function is called with the argument 200. Since 200 is an integer, this function simply returns the same integer value 200 and is printed to the console. The pow function in Python is used to calculate the power of a number. It takes two arguments, the base number and the exponent. It returns the output in floating point number. Syntax is pow of base, exponent. The pow function returns the result of raising the base to the power of the exponent. It is equivalent to using the exponentiation operator. Let's see some examples. In line 1, the import math statement in Python is used to import the math module, which provides a set of mathematical functions and constants. In line 2, this statement calculates 2 raised to the power of 2 using the pow function from the math module. The result is 4, and it is printed to the console. In line 3, this statement calculates 10 raised to the power of minus 2. The pow function supports both positive and negative exponents. In this case, 10 raised to the power of minus 2 is equal to 0.01 and is printed. In line 4, this statement calculates 4 raised to the power of 2, resulting in 16.0, and is printed to the console. In line 5, this statement calculates 5 raised to the power of 0. Any number raised to the power of 0 is always 1. Therefore, the result of this expression is 1, which is printed to the console. The fabs function in Python is a built-in function provided by the math module. It is used to return the absolute value, positive value, of the expression or number. It returns a floating point number, even if the argument is an integer. Now, look at this example. In line 1, the import math statement in Python is used to import the math module, which provides a set of mathematical functions and constants. In line 2, math.fabs of number returns the absolute value of the variable number, which is minus 25. The result is then printed, giving us the output 25.0. Let's see the difference between fabs and abs function. Data types. The fabs function is specifically designed to work with floating point numbers, while the abs function can handle both integers and floating point numbers. Module requirement. The fabs function is part of the math module, so you need to import the module using import math before you can use it. On the other hand, the abs function is a built-in function in Python, so you can use it without any imports. Return type. The fabs function always returns a floating point number, even if the input is an integer. In contrast, the abs function returns an integer if the input is an integer, and a floating point number if the input is a floating point number. The sqrt function in Python is used to calculate the square root of a number. This function accepts a number which is greater than 0, otherwise results in runtime error. It is available in the math module, so you need to import it before using the function. Let's see some examples. In line 1, the import math statement imports the math module, making all its functions and variables accessible in the current script. In line 2 and 3, we use the math.sqrt function to calculate the square root of 16. The output is 4.0. In line 4 and 5, we calculate the square root of 22 using math.sqrt of 22, and the output will be 4.69041575982343. In line 6 and 7, we calculate the square root of 22 using math.sqrt of 22, and then apply the round function to round the result to the nearest integer. The rounded value, which is 5, is printed on the console. In line 8 and 9, when trying to calculate the square root of a negative number, such as minus 22, an error occurs because the square root of a negative number is not defined in the real number system. This will result in a value error being raised. The log10 function in Python is used to calculate the logarithm base 10 of a number. It is available in the math module, so you need to import it before using the function. Let's see some examples. In line 1, the import math statement imports the math module, making its functions and variables accessible in the current script. In line 2 and 3, we calculate the logarithm base 10 of 100 using math log10 of 100. The result, which is 2.0, is printed on the console. In line 4 and 5, we calculate the logarithm base 10 of 100.42 using math, log 10 of 100.42, and the output is 2.00182021703838, is printed on the console. In both cases, the math.log10 function takes the argument as the number for which you want to calculate the logarithm base 10. It returns a floating point number representing the logarithm base 10 of the given number. The cos function in Python is used to calculate the cosine of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the cosine of different angles using the math.cos function and print the results. In line 2 and 3, we calculate the cosine of 0 radians, or 0 degrees, using math.cos of 0. The result will be 1.0, as the cosine of 0 degrees is 1. In line 4 and 5, we calculate the cosine of 30 degrees using math.cos of 30. The argument is in degrees, but the math.cos function expects the angle in radians. So, internally, the value is converted to radians. The result will be approximately 0.15425144988758405. In line 6 and 7, we calculate the cosine of minus 3 radians using math.cos of minus 3. The result will be approximately minus 0.9899924966004454. Negative angles are allowed, and the math.cos function will calculate the cosine accordingly. In line 8 and 9, we calculate the cosine of pi radians using math.cos of math.pi. The result will be minus 1.0. The sine function in Python is used to calculate the sine of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the sine of different angles using the math.sine function and print the results. In line 2 and 3, we calculate the sine of 0 radians, or 0 degrees, using math.sine of 0. The result will be 0.0, as the sine of 0 degrees is 0. In line 4 and 5, we calculate the sine of 30 degrees using math.sine of 30. The argument is in degrees, but the math.sine function expects the angle in radians. So, internally, the value is converted to radians. The result will be minus 0.98803162409286818. In line 6 and 7, we calculate the sine of minus 3 radians using math.sine of minus 3. The result will be approximately minus 0.141120008059867. Negative angles are allowed, and the math.sine function will calculate the sine accordingly. The tan function in Python is used to calculate the tangent of an angle given in radians. It is available in the math module, so you need to import it before using the function. Let's see some examples. In this code, we calculate the tangent of different angles using the math.tan function and print the results. In line 2 and 3, we calculate the tangent of 0 radians, or 0 degrees, using math.tan of 0. The result will be 0.0, as the tangent of 0 degrees is 0. In line 4 and 5, we calculate the tangent of 3 radians using math.tan of 3. The result will be minus 0.14254654307427778. In line 6 and 7, we calculate the tangent of minus 3 radians using math.tan of minus 3. The result will be approximately 0.14254654307427778. The help function in Python is used to access the built-in documentation, docstring, of a particular object, module, function, or class. It displays information about the object and how to use it. Now, look at this example. When you run this code, the documentation for the math.tan function will be displayed in the console or interactive shell. It will provide information about the function's purpose, parameters, and usage. Note that the help function returns the documentation as a string, so you need to use print to display it. Now, let's see about the random module. The random module is like a magical tool that helps us create randomness and surprises in our programs. Generating random numbers. Just like rolling a dice and getting a random number between 1 and 6, the random module helps us generate random numbers in our programs. We can use these numbers to make computer games more exciting or make decisions in our programs. Picking random things. Imagine you have a jar filled with different colored candies. The random module can help us pick a random candy from the jar. We can use this to create surprises in our programs, like picking a random character in a game or a random question in a quiz. Shuffling things. Think of a deck of playing cards. The random module can help us shuffle the cards so that they are in a random order. We can use this to create random sequences or mix up things in our programs. Pseudo-random numbers on lottery scratch cards. reCAPTCHA, like in login forms, use a random number generator to define which image is to be shown to the user. In Python, random numbers are not enabled implicitly. Therefore, we need to invoke random module or random code library explicitly in order to generate random numbers. The first statement to be given in a program for generating random numbers is import random. Let's see the various functions associated with the random module. The randRange function is a part of the random module in Python. It allows us to generate a random number from a specified range. This method generates an integer between its lower and upper arguments. By default, the lower argument is 0 and upper argument is range -1. The syntax is random.randRange of start, stop, step. The randRange function takes in 3 parameters. Start, optional. It specifies the starting point of the range, inclusive. If not provided, it defaults to 0. Next parameter is stop. It specifies the ending point of the range, exclusive. The function will generate random numbers up to, but not including, this value. Step, optional. It specifies the step size or interval between numbers in the range. If not provided, it defaults to 1. The start, stop, and step values can be integers. Let's see an example. In line 1, the import random is used to bring the random module into our code. By importing the random module, we gain access to various functions and capabilities that allow us to work with random numbers and randomness in our program. In line 4, we are using the randRange function from the random module. The randRange function generates a random number within a specified range. The first parameter, 0, specifies the starting point of the range, inclusive. In this case, we want our range to start at 0. The second parameter, 10, specifies the ending point of the range, exclusive. We want our range to go up to, but not include, 10. The third parameter, 2, is the step size or interval between numbers. It indicates that we want to generate only even numbers within the range, as we are incrementing by 2 at each step. The randRange function will then produce a random even number between 0 and 10, exclusive, based on the specified range and step size. This random even number is assigned to the variable even_number. Finally, we use the print function to display the value stored in the even_number variable. The output will be the randomly generated even number between 0 and 10. Here, you can see the output displayed each time a random number, for the first code 4, for the second code 8, and for the third code 6. Let's see another example. In line 2, the line import random imports the random module into our code. This module provides functions that allow us to work with random numbers, make random selections, and more. In line 3, we define a list called subjects that contains 4 different subjects as elements. Each subject is represented by a string. In line 4 and 5, we use the randRange function from the random module. The randRange function generates a random number within a specified range. The first parameter, 2, specifies the ending point of the range, exclusive. Since we provide only one parameter, the starting point is assumed to be 0. The randRange function will then produce a random number between 0 and 2, exclusive. It could be either 0 or 1. The random number generated by randRange is assigned to the variable ran_index. This number will serve as the index to select a random subject from the subjects list. Finally, we use the print function to display the subject at the randomly chosen index in the subjects list. Since the ran_index variable holds a random number between 0 and 2, it will randomly select one of the subjects from the list. So, the overall code imports the random module, creates a list of subjects, generates a random index using randRange, and then prints the subject corresponding to the randomly chosen index. You can see the output that, each time the code is run, a different subject will be printed, adding an element of randomness to the program. The random function generates a random decimal number between 0 and 1. This function can be used to generate random floating point value in the range 0.1, 1.0. It takes no parameters and returns values uniformly distributed between 0 and 1, including 0, but excluding 1. Let's see some examples. In this code, each time random function generates a different number. Program to calculate the sum of the digits of a random 3-digit number. This code generates a random number n between 100 and 1000, and then separates the digits of n to calculate the sum of its individual digits. Look at line 4. The random function generates a random fractional number from 0 to 1. When a random number generated using random function gets multiplied by 900, a random number is obtained from 0 to 899. When we add 100 to it, we get a number from 100 to 999. Line 7 and 8 converts the random number to an integer. Line 11, 12, and 13 extracts the individual digits from the random number. Line 16 and 17 calculates the sum of individual digits. When you run this code, it will output 2 numbers. The first number, n, is a random integer between 100 and 1000. The second number is the sum of the individual digits of n, that is, a plus b plus c. In this case, n is 547, and the sum of its digits, 5, 4, and 7, is 16. Next time when you run the code, n is 670, and the sum of its digits, 6, 7, and 0, is 13. The randint function generates a random integer between a specified range. It is part of the random module in Python. Now, look at this example. In this code, randint of 1, 10 generates a random integer between 1 and 10, including both endpoints. Each time you run the code, it will output a different random number within the specified range. For example, the output could be 2 and the next time it could be 3 and so on. Let's learn some more functions of the random module. The uniform function is another function provided by the random module in Python. It generates a random floating point number between two specified values. The syntax is random.uniform of x, y. Now, look at this example. In this code, uniform of 0, 1 generates a random floating point number between 0 and 1. The range is inclusive of 0 but exclusive of 1. Each time you run the code, it will output a different random number within the specified range. You can see the output below. The choice function is another useful function provided by the random module in Python. It allows you to randomly select an element from a sequence, such as a list or a string. The syntax is random.choice of sequence. Let's see an example. You can also use the choice function with strings. In this case, choice of my_string selects a random character from the my_string string. The output could be any character from the string, such as R, next time it could be L, and so on. The shuffle function is another useful function provided by the random module in Python. It allows you to randomly shuffle the elements of a sequence, such as a list. The syntax is shuffle of list. Let's see an example. In this code, shuffle of my_list shuffles the elements of the my_list list in place, meaning it modifies the list directly. Each time you run the code, it will output a different order of the elements in the list. For example, the output could be list of elements 4, 3, 5, 1, 2, and next time it could be list of elements 3, 4, 2, 1, 5. The shuffle function is particularly useful when you want to randomize the order of a list or when you need to randomly permute a sequence of elements. It can be handy for implementing algorithms like shuffling a deck of cards, randomizing quiz questions, or generating random permutations. In Python, the statistics module is a built-in module that provides functions for mathematical statistics of numeric data, that is real-valued data. The statistics module implements many common statistical formulas for efficient calculations using Python's various numerical types, that is int, float, decimal, and fractions. Before using the functions of this module, it is required to be imported first using the statement, import statistics. Let's see the popular statistical functions which are defined in this module. Mean, median, and mode. The mean function calculates the arithmetic mean of the numbers in a list. What do you mean by arithmetic mean? It is calculated by summing up all the values in a dataset and then dividing that sum by the total number of values in the dataset. That is finding the average. Let's look at the Python code. The first line imports the statistics module in Python. The statistics module is a built-in module in Python that provides functions for mathematical statistics of numeric data, including mean, median, mode, standard deviation, and more. Next, we define a sample list of numbers named data. This list contains 5 numbers, 10, 20, 30, 40, and 50. Next, we calculate the mean of the numbers in the data list using the statistics.mean function. The mean function takes a list of numbers as input and returns the arithmetic mean, average, of those numbers. Finally, we print the result, which is the mean of the numbers in the data list. The mean_value variable holds the result of the statistics.mean function calculation, and it's printed along with a descriptive message. So, now look at the output. Mean of the numbers is 30. That is 10 plus 20 plus 30 plus 40 plus 50 is equal to 150, then 150 is divided by the number of count, that is 5, and hence the output is 30. Next statistics module is the median function. The median function is a measure of central tendency that represents the middle value of a sorted dataset. To find the median, arrange the data in ascending order. If the dataset has an odd number of values, the median is the middle value. If the dataset has an even number of values, the median is the average of the two middle values. Let's see an example. Let's calculate both the median for the odd and even dataset. For the odd dataset, 20, 5, 10, 25, 15. Sort the data, 5, 10, 15, 20, 25. Since the dataset has an odd number of values, 5, the median is the middle value, which is 15. For the even dataset, 20, 5, 10, 25. Sort the data, 5, 10, 20, 25. There is no single middle value, so the median is the average of the two middle values, 10 plus 20, divided by 2 is equal to 15. Let's see the Python code. The first line imports the statistics module in Python. The statistics module provides functions for calculating mathematical statistics of numeric data, including functions for mean, median, mode, standard deviation, and more. In the first section, you define an odd dataset data_odd containing the numbers 20, 5, 10, 25, 15. Then, you use the statistics.median function to calculate the median of this dataset. The result is stored in the variable median_odd. Finally, you print the calculated median. In the second section, you define an even dataset data_even containing the numbers 20, 5, 10, 25. You calculate the median of this dataset using the statistics.median function and store the result in the variable median_even. Finally, you print the calculated median. Let's look at the output. Median of odd dataset is 15 and median of even dataset is 15. In Python, the mode function from the statistics module is used to find the mode of a dataset. The mode is the value that appears most frequently in a dataset. The mode is a statistical measure that represents the most frequently occurring value in a dataset. In other words, it's the value that appears with the highest frequency. Example, consider the dataset 2, 3, 3, 5, 5, 5, 7, 7, 7, 7. In this dataset, 2 appears once, 3 appears twice, 5 appears 3 times, 7 appears 4 times. Among these values, 7 occurs most frequently, 4 times, making it the mode of the dataset. Let's see the Python code. The first line imports the statistics module, which provides functions for calculating mathematical statistics of numeric data, including functions for mean, median, mode, standard deviation, and more. Next, you define an example dataset named data. It's a list containing the numbers 2, 3, 3, 5, 5, 5, 7, 7, 7, 7. Next, you use the statistics.mode function to calculate the mode of the data list. This function returns the value that appears most frequently in the dataset. If there are multiple modes, that is, multiple values with the same highest frequency, it returns the smallest one. If there's no repeated value, it raises a statistics error. Finally, you print the calculated mode value using the print function. The message mode of the dataset is concatenated with the value of mode_value and printed to the console. When you run this code, it will output mode of the dataset 7. Thanks for watching. Keep coding, keep learning, and stay curious with Sally and Bytes.